Well, that was a nice intro. I like that. I think everybody missed Alex's dancing there. That's a shame. We should have brought you on early. There we go. Anyway, hello, folks, and welcome to JetBrains GameDev Day for Game Dev's Day. How many S's are there in there? Game Dev Day 2025. Very nice to have you all here. And I'm Matt, and this is Alex. Say hello, Alex.
What up, folks?
This is good. I hope everybody's nice and busy in the chat. Tell us where you're from, what's happening, what you're up to, all that kind of stuff. And yeah, we've got a great day for you today, I think. Actually, let's bring on a few slides and have a look at what's going on. Usual bit of housekeeping before we kind of kick anything off. Please keep the conversation going in the chat. If you got any questions throughout the day, please just throw them in the chat and we'll either answer them right there and then, or we'll keep a list of them for the different speakers and we'll ask them after the sessions have gone on themselves. Of course, the session's being recorded. You're on YouTube. It's obviously being recorded. You can obviously pause and rewind the stream right now. There's not a problem. If you need to go and answer the door, that's okay. But don't quit the whole session. Just pause it. It's fine. And once the whole thing is finished, we will chop the videos up and make them available as well too. If you've already registered with us to join the agenda, there, we'll send you out an email with a link to all the other channels that we've got there. As well. And so thank you for joining, really. If you are interested in any other sort of content we've got from JetBrains, you can go to the JetBrains TV YouTube channel and see a whole load more useful stuff there. There's live streams like this. We did the .NET Days one last week, which was a great set of sessions. A whole load of really interesting stuff. A couple of mind-blowing sessions about async await if you're into that kind of thing. Plenty of other stuff there, product information for all the different products and stuff like that as well. Alex, do you fancy having a quick look through the agenda and seeing what's coming up?
Sure. Let's go ahead.
Let's go ahead. Well, very good. In about 10 minutes, we've got Gian is going to have a great session then on accessibility, which I think is going to be a really useful topic, actually, because it can be one of those things which you don't tend to think about very often. And then that one, I think, will be followed by Konrad with talk about beyond object-oriented programming and looking at cache misses and whatnot. Alex, are you a big fan of monitoring your cache?
Oh, always. I mean, it's always a hot topic, especially when you are striving for the last mile of optimization for the game, like making sure that there's no cache misses. That's crucial for your performance.
I say you up with a good cache pun, and you just run with the actual proper answer, honestly.
It flew like straight over my head. My bad.
I think too subtle. All right, I've got to think of worse jokes then. There we go. After that, then we've got Dom talking about optimizing for the web, which is going to be good, and some useful tips there for Unity and Godot. So we'll be looking at sort of cache misses and low-level type stuff, and looking at Unity and Godot. After that, in web type stuff. So we're having lots of looks at different things, and then following that, we're going to have a little lunch break as well. So about half an hour's break in between sessions there. Following that, then Johannes is going to be talking to us about Godot and PlayFab. So we're kind of want to cover up as many different sort of engines and things as we can, really, and lots of different areas that we can look at. And then following on from that, we also need to look at CI and CD, because obviously building a game, well, coding your game and choosing which engine and everything is not the main, the whole thing of the package there. We've also got to build and deploy your game. And so Ilya is going to be talking to us a lot about the CI/CD pipeline for mobile game development. Then we've got some Chancer who's just snuck in somehow. I'm not entirely sure how he's on the agenda here, but I'll be having a look at what we've got for game development from JetBrains. So if you haven't been keeping up to date with the latest versions, we'll have a quick look at what's going on there. I also want to do a bit of a Q&A around there as well, because you got the chance then to ask me stuff, ask Alex stuff as well. Alex, you do know your stuff, don't you, Alex?
I mean, at least I make, I try to make a vision like that I know something about my stuff.
Yeah, he's been very modest. He knows a whole lot of things there. So if you have any questions for either of us about Rider, about JetBrains, about game dev tooling within JetBrains and so on, or even if you just want to chat and ask Alex about his hats, then that's also fine. So yeah, you can ask anything as part of that. Be quite informal. And then Johnny Thompson's going to take us through some netcode stuff for entities and Unity there, which should be an interesting talk. We're also going to be looking at some of the things which are, some more of the softer skills side of things, basically, which is also very useful. Quite a lot of games are built on collaboration, working with teams and so on. And while a lot of us can be very technical, we also need to make sure that our soft skills are working just as well and that we can actually work well together. And that's always a useful thing, isn't it, Alex?
I mean, always. People tend to double down on the hard skills when it comes to the game development or development in general, but it is especially crucial with the amount of the technologies that are popping up, the frameworks, especially like web frameworks. Every single day a new framework comes up. It is crucial to work together in the team to make sure that you collaborate efficiently and you can find a common ground with your colleagues.
Yep, exactly. So Sheena will be talking to us about that. And then to round off the day, then we're going to be talking to Gabriel and Henry from AWS Solution Architects, talking about the cloud game development toolkit, because cloud is obviously a big deal in the industry, just as much as it is with, as we are concerned with devices and mobile and console and PC and everything. Cloud is still a very important thing there. And so that brings us to that'll sort of round out our whole day there. It's a nice rounded set of sessions, I think, covering a whole load of interesting topics. So I'm looking forward to getting stuck into it, really.
Yeah, that sounds like a long and busy day, but I'm looking up for it. While I have a minute, that I mentioned some mentions of the state of the work in game development industry, and especially mentioning the Godot engines, that it is hard to find a job using the Godot. That may be true right now, but I think the adoption of Godot is coming on the rise. So just mentioning that recently Battlefield 6 has been released, and for the modder community, they decided to use actually the Godot to be as an engine, as like an editor to edit maps and mods and stuff. So right now, it is easier as ever to jump in the AAA development using the Godot engine. And I know for a fact that there were multiple other AAA studios that I cannot name that were also considering Godot as their like third-party editing tool. So they are not using it for the inside job, but for the outside job. It's kind of interesting.
It is. I think it's a great way to integrate new tooling into your pipeline. There is to not have to try and replace everything all at once, but to integrate it in small steps into into tooling like that, and into other areas, internal tools or even external tools for your modding. I always remember the idea of talking about new test frameworks, for example. That's always a good place to use it. Or new languages. Last week, for example, with the .NET Days, we were talking about F# and how using F# is a great way to write tests because you can write them very cleanly. And it's a nice way for you to get experience with it without having to sort of throw everything away and suddenly destroy your own velocity. You don't have to lose a whole lot of time. You can actually start to do little baby steps, as it were, to learning a new technology and picking up and integrating it into your own workflow. I think that's a really nice idea.
I mean, it's a good pro coin, but on the con side, that you have to use the F#.
Oh, come on, jeez! This is. I didn't think we were going to get this route this early. This is. You're just lucky you weren't here last week. The .NET Days, those folk in the chat, they would have ripped you to pieces for that. Here, I think the game dev people, they're going to be much, much nicer. And as long as you don't say something mean about their engine, we should be able to get away with it.
I mean, game dev is my domain, so it's my safe space while I can use this kind of words.
Yeah. Fine. I was using it as an example. It's like I think using Godot as an extra tool is going to be a great way of bringing it in, understanding how it's different to your existing engine and integrating it there. Honestly, see, I feel like I'm being a peacemaker now after you and your hand grenades.
I'm starting hard. So Speaking of conferences, so today we have the lovely Game Dev Day by JetBrains, but later this week there will be actually a game industry conference in Poland, Poznan, and JetBrains will actually attending the conference, and me personally, we're standing in booth. So if you are Eastern developers, press E in the chat if you are from like the this kind of countries. Feel free to join the conference, to attend the booth, to see all the demos for the new cool game dev and AI stuff from JetBrains, and just hide, say hello.
Yeah, definitely make sure you say hello. It's always nice to speak to people and hear what's going on, hear their stories, and find out how they're using the different tools and things.
So speaking of Eastern Bloc, do we have a C++ developers in the chat? Can we have a quick vote on whether or not you are East Coast or West Coast developer?
You had me for a minute there. I'm like, what? East Coast developer? East Const. Okay.
Const.
Yeah. That took me a moment. Oh, you see, now it's been too long since I've done C++ in anger, and so I can't remember what I am. I think I'm just, don't know, probably a bit of both. I'm not sure that's the appropriate answer.
What's good about C++ is it is absolutely community agreeable that you can bash at C++ whether or not you are the C++ user or not.
That's nice. It beats the F# thing. Then no, this is good. So I see. So you're saying I can be rude about F#, but I can also be rude about C++.
Always. Like it actually makes you a greater C++ developer. The more you hate it, the more you understand it.
We're an equal opportunity language hater. Yeah. Okay. Yeah. This is good. Right. Well, I think we've probably done enough talking. Then I think maybe we'll bring on our first guest speaker and say hello. We've got Gian coming. Hello, Gian. How are you doing?
Hi. Thanks for having me.
It's our pleasure. Very interested to hear what you have to say today about accessibility. It's a big topic and one which perhaps doesn't get as much attention as it should.
Yes. Now, some important housekeeping before I get started. I have 2 greyhounds who I have managed to terribly train. When I talk, they go, "Oh, if we bother her, she'll give us lots of treats." So if I'm just fluffing around, that's what I'm doing. So thank you very much for having me here, and let's share the screen. How do we do that?
Yep, don't worry, we've got that sorted back here. I think Sergey's going to. Yes,
excellent.
There we go. We've got
Thank
the screen.
you very much.
We can see your slides then, and if you're comfortable, we'll leave you to it, I think, and we'll hope the dogs don't interrupt too much.
Yes, well, hopefully they're supposed to be pretty quiet right now. It's like 8 o'clock at night, so they've been fed and everything, but you never know. Dogs are an unknowable quantity. So today I'm going to be talking about the mobile site native app accessibility testing guidelines, specifically basically what they are so that you can actually apply them when creating accessible games. The first thing I'd like to do is acknowledge the Yugara people as the traditional owners of the land. They still have a strong attachment to the area. I am here from Australia, from Queensland. It's 8 p.m. and still 28 degrees. So that's, I don't know, maybe 95 degrees Fahrenheit. So yeah, it's pretty warm here. The first thing I'd like to do is say, if you'd like to access the presentation, because that's kind of the first question I always get, you can go to the Accessibility Oz conferences page, and I'll put it up after the presentation. Go to About, and then the conferences page. And as you can see, you've got JetBrains here. It will move down to parts conferences, and I will include the PowerPoint presentation so you can have a look at that. I'd like to introduce you to our team. This is a photo that was taken a while ago at CSUN in California. CSUN's one of the biggest accessibility conferences in the world. And when I started Accessibility Oz, I wanted to support people with disabilities by providing them with employment opportunities, as well as creating accessible websites. And so over the almost 15 years that we've been operating, we haven't had any less than 60% of our staff have some kind of significant disability that affects their daily life. And when you look at us, we all look normal. And that's something to be aware of, is that just because you know everyone that's using your system or your website, your game, and none of them look disabled, that doesn't mean that they aren't. About 20% of the population has some kind of significant disability that affects their daily life. That doesn't mean the need to use glasses or anything like that. Significant disability. And it's often you can't tell just by looking at someone, and it's really quite rude to ask. So over the, as I said, almost 15 years that we've been running, we've had people with dyslexia, moderate vision impairment, severe vision impairment, epilepsy, migraines, physical impairment, fibromyalgia, multiple sclerosis, Crohn's disease, post-traumatic stress disorder, autism, and long COVID. And one thing to remember is it's not just about vision impairments. A lot of people, especially if they're new to accessibility, think that accessibility is all about making things accessible to a screen reader. That's absolutely not the case. Of course, it's very, very important. But the largest group of people with disabilities who use the web are actually people with cognitive disabilities. And they often have diametrically opposed requirements to people with vision impairments. So people with vision impairments prefer text instead of images. People with cognitive disabilities prefer images instead of text. So if you're like, hey, I'm just going to create this text-only site for all the people with disabilities, you're actually locking out a large group of disabilities, people with disabilities by doing so. A little bit about me. Sorry, just one moment. Go on. A little bit about me. I started in 1998. I like to joke that I started when I was 5 years old, but that was not the case. I worked on the very first accessible website in Australia. I created Australia's first automated accessibility testing tool. I was an invited expert to the W3C WCAG working group, so I contributed to writing WCAG 2, which are the guidelines that you need to follow to make things accessible. I worked on the Melbourne 2006 Commonwealth Games and every Commonwealth Games since then. And I then spent 5 years managing usability and accessibility services at Monash University, which is one of our Ivy League colleges here in Australia. So I know what it's like to be on the other side. In 2011, I founded Accessibility Oz. We released a couple of products. I spoke at the United Nations on the importance of accessibility in disasters. And I was inducted into Australia's Hall of Fame as Accessibility Person of the Year in 2019. And I also spent the last few years as chair of the Mobile Accessibility Testing Guidelines. So that's what we're here to talk about. That's all just to prove that I do know what I'm talking about. So let's get on to these guidelines. So a little bit of background. Why did we develop this methodology? So if you know anything about accessibility, you should know that there's this thing called the Web Content Accessibility Guidelines, and that's what you need to follow to make your content accessible. However, really, it doesn't go far enough when it comes to developing native apps or websites that you view on mobile. And so at a conference called the ICT Accessibility Testing Symposium in 2017, we all get together as a community. So we were all accessibility testing specialists. And at the end of that conference, they always have a town hall where they say, hey, what is it that you would like to see change in the community? And in 2017, the overwhelming discussion was around how there weren't guidelines for mobile accessibility. Well, actually there were guidelines, but everyone had their different set of guidelines. So Accessibility Oz had our own, every different accessibility company had made up their own guidelines. So we decided to form a committee at that point to come up with guidelines. And initially we just amalgamated everyone's guidelines and said, this is what, this is what the mobile guidelines should be. And we did that because we knew that WCAG 2.1 it was going to be released in 2018. And it was released a couple of weeks after we released our mobile guidelines. And we were like, once WCAG 2.1's released, which is kind of iterative version of WCAG, it's going to address all the mobile stuff. We don't need to worry about developing these guidelines any further. So what about WCAG 2.1 and 2.2, which has also been released? So as I mentioned, WCAG 2 are applicable to mobile. However, not all aspects of mobile accessibility are specifically covered by WCAG. So, for example, WCAG 2 requires that sites be fully accessible to the keyboard user. However, it doesn't require that everything be fully accessible to a mouse user or to a touchscreen user. WCAG 2.1 does build on this and includes more criteria-related touchscreens, pointer gestures, things, etc. However, it really doesn't cover all the user needs. And so that became patently obvious when 2.1 was released, because we had another big gathering at a conference, and we all found that there was one success criterion that we all agreed on, and that was that touch target size the touch targets had to be a specific size. So they had to be, the links had to be a certain height and a certain width. We all agreed on that. And yet WCAG 2.1, it did have a touch target size requirement, but it was relegated to level AAA. So there are 3 levels to WCAG, level A, AA, and AAA, and everyone is meant to follow level A and AA, and AAA is seen as the nice to have. I like to say level AAA is where success criterion go to die. And guess where the touch target size requirement was? It was in AAA. So we reformed the committee and we went, you know what? We need to do this properly. And we spent 2 years writing very detailed mobile guidelines, including how to test with examples, etc., etc. And so that's how this came about. Please note that this methodology does not include anything that's already in WCAG 2, but it does include things that are in WCAG 2.1. And at the moment, it does not include WCAG 2.2 because it was published before 2.2 was released. So where can you find these guidelines? If you go to the Accessibility Oz website, you'll see that under resources, there is the link mobile testing, and that is where these guidelines are. So you have this introduction, why we did it, and some webinars. So something like this you can access as well. There are some blog posts about part of the functionality. We talk about WCAG 2.1 and 2.2, mobile sites versus native apps, and hybrid native apps. And then we have the methodologies. So there are 2 sets of methodologies. One is the mobile site methodology and the other is the native app methodology. They are very similar, but we did find it was easier to pull them apart. And basically you have this methodology, which is the equivalent of your success criterion in WCAG. So these are the rules that you need to follow, but just the rule itself, not, how you would go about doing it. And so you have that for mobile site and native app. And then you have an about, this document. So about talks about devices, assistive technologies, site types, variations of the page, capturing errors, etc., specifically to mobile sites or specifically to native apps. And then you have the 3 documents that have the methodology in much more detail. So you have a document on critical test cases, a document on test cases, and then assistive technology test cases, once again for mobile sites and for native apps. I know Word documents, not great. We are trying to convert them into an online resource, but there's so much information there. So that's how they are available at the moment. And I also want to let you know, even though it's on the Accessibility Oz website, that doesn't mean it's actually an Accessibility Oz product. The only reason it's on the website is because I was the chair, and after it was published, it was on the testing conference website, which it is now, links back to us, and I just kept sending them updated versions saying, I found this typo, or this heading's at the wrong level, and they went, oh my god, Gian, just put it on your website and we'll direct it to you. So it was developed by a whole bunch of different accessibility companies, people with disabilities, software vendors and things like that. It is a bipartisan document. And the thing to remember also when it comes to accessibility is that that's kind of what we do as an industry. WCAG, the very first WCAG, was released in 1998. It was actually written in 1995 by just a random group of accessibility specialists who got together one day and said, hey, we need some guidelines for this new thing, the web, to make sure that people with disabilities can use it. So they created the guidelines, updated it a few times, and then the W3C took it over. So, and that is by far not the first time and not the last time that has happened. So this is very common in our industry. We do find that the W3C, which is really kind of responsible for the policy documents, doesn't move very fast. As an example, WCAG 1 was released in 1998, WCAG 2 was released in 2008, WCAG 2.1 was released in 2018, and WCAG 2.2 was released in 2023. So it's a long time. There's a lot of difference between 2008 and 2018. If you think about it, the iPhone was only released in 2007. The web content accessibility guidelines have been completely written by then. So that's why it doesn't include all these mobile kind of things, because there were no mobiles. We had monochrome displays on flip phones. And I did do some testing of mobile sites like that. It was very unfriendly. We had no concept of no native apps or anything like that. So the reason why this is here is because we just don't feel that the W3C moves fast enough. So why is mobile so different to, say, a desktop? So firstly, there are native screen readers and other native assistive technologies that you just don't get in the PC world. In a Mac, of course, you have an inbuilt assistive technology called VoiceOver. But if you're using a PC, you could use, the Windows narrator, but it's absolutely terrible. Anyone who actually needs a screen reader would not be using Windows narrator. So you have to download NVDA or JAWS or something along those lines. And so when it comes to mobile, there's a huge variety of assistive technologies and features that people use even if they don't consider themselves having a disability. For example, I use dark mode, which reverses the colors. So I see white text on a black background. I do it mainly to conserve battery, but that's something that I don't use on my desktop. My stepmother, for example, she reads all her books on an iPhone now because she significantly increases the text size. She would never ever consider going into a library and asking for a large print book, but that is exactly what she's doing. So these kind of assistive technologies are much more commonly used on mobile devices. So you have to be much more careful when you're developing these systems to make sure they operate correctly with them. You have a level of volume control that you don't usually have on desktop. If you think about how many times you change the volume on your phone versus the volume on your desktop, you have things like a vibrational keyboard. There's visual, auditory, and vibrational notifications. There's screen rotation. I personally have 3 screens. I have a landscape, and a portrait. And I can tell you there are a lot of websites that do not work on a portrait screen. But of course, that's what we're expecting on a phone. But there are some people with disabilities who have their phones affixed to, say, their wheelchair or something like that. And so they can't change their orientation. So allowing things to operate in multiple orientations is really important. Mono audio, voice control, increased text and display size, reduction of motion, zoom, and then things like reader and simplified view. Another thing that makes mobile really interesting is the page variations. So as part of WCAG 2, you should be able to, on your desktop, zoom to 200% on any browser and still be able to use the site properly. So, of course, that's not included in this methodology. But people who do that and increase the zoom to 200 or 300% often end up triggering the mobile version of the site on their desktop. So what does that mean? It means there are some people with disabilities who only ever see a mobile version of your page. So that means that everything that you have on your desktop website, you need to have on your mobile website as well. This is a really good example. This has been fixed. So this is YouTube, and this is a screenshot of YouTube on desktop at 100% screen size. And you can see in the top right-hand corner, there's the upload and the notifications button. Now, if you increase the text size to 200%, it disappears. So all of a sudden you can't upload or access your notifications if you're looking at the page at 200% on desktop. Now, why would that be the case? Because that screen size, the developers assume that you would only be looking at it on your mobile phone. And they don't want you to upload videos through the YouTube mobile site. They want you to upload videos, on the YouTube native app. So they've taken that functionality away. But that means people who increase text size on desktop, they're not going to be able to do it. So that's one thing to remember when you're talking about different screen variations and things like that, that you need to make sure you have the same amount of content in every single variation. It doesn't have to look the same. It could be hidden under a collapsible menu or something like that, but it all needs to be there. So another thing to remember is under WCAG 2, there's something called accessibility supported. Basically, you need to use implementation techniques that support assistive technologies. So if you use, say, PDF, then you need to tag the PDF using the PDF accessibility features. What does this mean for mobile? So what this ends up meaning is that when you are using native apps, you need to really test to ensure that the assistive technologies work with those native apps. And this is much more important with native apps than it is for a mobile site, because you can't access the code of a native app if you're testing. Obviously, if you're building, it's different kettle of fish. But if you're testing, you can't access the code of a native app. So sometimes the only way to determine if something has an accessible text alternative is to actually use an assistive technology. So the assistive technologies that are included in this set of guidelines are for Android: talkback, keyboard and switch, magnification, remove animations, color inversion, grayscale, color correction, increase display size, increase font size, increase text size with Chrome, and simplified view for mobile sites only. For iPhone, it's voiceover, keyboard and switch, zoom, reduce motion, invert colors, grayscale, large text for native apps only, reader view for mobile site only, and reader view and increased text size for mobile site only. Now, exactly the same assistive technologies also need to be tested on an iPad if you are testing for iPads, because it uses a completely different operating system. So if it works on your iPhone, doesn't necessarily mean that it works on your iPad. So testing methods. There are a variety of testing methods when it comes to mobile testing. For mobile sites, there are 4 main testing methods. You test on a device, you test on a device with an assistive technology, you test on a responsive window, or you test on desktop. When it comes to native apps, there's only 2 testing methods: testing on devices and testing on devices with assistive technologies. And so I know you're all going to say, no, but we've got simulators, so we can test on a bunch of things. We don't need to test on actual devices. This is why you need to test on actual devices. So I used to fly to the States fairly regularly, and we'd get to LAX and we'd sit on the tarmac for like half an hour. But the one good thing is that back before planes had Wi-Fi, you could access the LAX Wi-Fi on the plane. But if you did so, you get this page, and it has small text here that says, this page will redirect, so content doesn't really make sense to have here. And all of a sudden, I don't really feel safe for giving you my contact details. Now, how does this happen? This happens because this was tested by and developed by someone who is sitting in front of a desktop. They've never tested it on their phone in that actual location, in the way that people would actually use it. So that's why you have to test with real devices. And also, when it comes to assistive technologies, the simulators are absolutely rubbish at showing you what the assistive technology will say or do. Even if they are, browser farms and they have mobiles that you are supposed to see the actual screen of, still absolutely rubbish. So you cannot use them. So the actual methodology, the methodologies have the same 5 steps with the exception of step 2. So the mobile site methodology is identify devices, identify site types and variations, test critical issues, test mobile specific issues, and test mobile assistive technology and feature support. And then for the native app, it's exactly the same except for step 2, which is define application functionality. So for step 1, identify devices. Firstly, you should determine what devices your system should work on. So in the United States, Australia, other Western countries, iOS devices are most popular. In Asia and other Eastern countries, Android devices are most popular. So if you have a site, the best way is to look at Google Analytics to determine who's using your system and then build from there. In terms of the Android system, there are actually tens of thousands of Android operating system and browser combinations available. It's not possible to test on all these systems. And also another thing to remember is that the internet browser that comes pre-packaged with most Samsung phones is very dependent on that operating system itself, and a better representation is to test with Chrome. So whatever Android of what a lot more people will see. And just remember that even if the site is a desktop site, people will still use that desktop site on mobile, and I'll talk about that in a moment. And then when it comes to devices with assistive technologies, it's important to remember that there are assistive technologies that are named the same, say that work on a Mac and work on iOS, but they are actually different technologies. So you can't say, oh, I tested this on a Mac with VoiceOver, so I don't need to test VoiceOver on my iPhone or my iPad. You do have to, because they're actually completely different technologies. They're just labeled the same. If you want to talk about screen readers read aloud the content on a page for people who are blind. There is a WebAIM screen reader survey which talks about which are the most popular screen readers. If you're talking about mobile, the only 2 that you really need to worry about are VoiceOver for iOS and TalkBack for Android. Be aware that Samsung does, because Samsung likes to be different, they have an additional screen reader called Voice Assistant, but TalkBack is still available. And Amazon Fire also uses a different screen reader called Voice View. So if you look at your statistics and you find that 90% of the people using your system are using Samsung devices, then maybe consider testing on with Voice Assistant. If you have a system that's going to work exclusively on Amazon Fire, then you need to test with Voice View. In reality, though, TalkBack for Android and VoiceOver for iOS is sufficient. The recommended devices and browser combinations are iPhone with Safari, iPad with Safari, and an Android phone with Chrome. You should also consider an Android tablet with Chrome, and alternative devices such as a Kindle if your system can operate on those. The guidelines recommend that you test on the latest version of iOS and iPadOS and the latest 2 versions of Android. However, in the use of this testing methodology, I found that it's actually sufficient just to test on the latest version of Android. So that's something that you can, reduce your testing. And just think also, when a site is directly aimed at people with a particular kind of disability, you can consider including assistive assistive technologies used by potential users. So for example, if you have a site or a game that's aimed at people with acquired brain injury, then you should be testing with an assistive technology like Dragon Naturally Speaking, because that's what they use. I did notice in the chat that someone said, does anyone knows if this is pre-recorded? It's absolutely not pre-recorded, but there is a recorded version of this on the mobile page if you would like to access it later. And just another note that you need to meet WCAG 2 and this mobile testing methodology. So step 2, when it comes to determining what it is that you should be doing, you need to really identify the site type and variations of the page. So is your site going to be a desktop, M.dot, responsive site? If the site is responsive, are there variations of a page? So basically desktop sites are ones that have only one display, whether viewed on desktop or mobile or tablet. M.dot, they have a particular display for mobile and tablet sites, and it's actually a completely separate site. So you have a www site that is on your desktop, and then an M.dot site, which is completely different code that you see on your mobile. And then responsive websites that change depending on the screen size or other feature determined by the developer. And that's, of course, the most common. So this is an example of a desktop site, and basically what you can do is if you drag the browser window smaller, you can see nothing really changes, it just gets smaller. And so it's not very common to have desktop sites anymore, but they do occur. And if you are wanting to identify an M.dot site, you need to really do 3 things, which is ask the client if they have an M.dot site, then change the URL to start with M instead of www, and then compare the site on desktop to the site on a mobile device. And so this is something that seems like overkill, but I did do some training for Stanford University, and I asked them, you know, do you have an M.dot site? They said, no, we don't have an M.dot site. Guess who had an M.dot site? So, of course, this is not really applicable if you are building games, but it's something to be aware of, and it's something, a good reason to explain to people why everything should be responsive. So this is the Sephora website, and this is what it looks like, the www version on desktop, and this is the M.dot version on desktop. You can see it's got a hamburger menu, it's much cleaner, and if you look at them both on mobile, you can see that they are very different. So that's an M.dot site. So most likely sites are going to be responsive. If a site's responsive, it's definitely not desktop, but there could still be an M.dot site. Easy way to identify a responsive site is basically change the size of the browser window. If you have a site like this, you make the window smaller and it actually changes quite significantly. That's how you identify it. Now, if you ever go, oh my gosh, I have no idea what she's talking about, all this information is in the documentation. So the next step when it comes to determining what should be accessible for native apps is define application functionality. So through your understanding of the purpose of the native app, define which functionality is critical to its purpose and use, and that must be tested for efficacy, operability, and workflow from a user experience perspective. So for example, if you think about the Wells Fargo website versus the Wells Fargo app, they do very different things. The Wells Fargo website might have their share price, how you can apply for a job, store locations, when they're open, etc. And the Wells Fargo banking app will be specifically about banking. So you find that native apps have much more streamlined information and content, and that's what you need to be aware of when looking at accessibility. So ask the question, how would the experience be impacted if the functionality failed, the content could not be reached, and or the experience caused a barrier to the user, and then prioritize. So all functionality should be accessible. However, it's important to define and include the critical functionality for each individual app to be prioritized in the testing. And then there are common elements that need to be tested to make sure that they are fully accessible: navigation, landing screens, emergency sections, login flows, settings, account and profile, contact us, real-time updates, privacy policy, terms and conditions, interactional functionality, help section, widgets, calendars, geolocational maps, and high traffic areas. So now that you know a little bit more, you might be a little bit more interested in looking at the guidelines. So I'll just show you again. You just go to the resources and then mobile testing, and that's how you can find it. So the next step is testing critical errors. And so this is where there are traps. New features mean new traps. A trap is where a user is trapped within a component and cannot escape without closing the browser or the app. There are many more traps in mobile sites and native apps than on desktop. The most common one known on desktop is the keyboard trap. You tab into a component, but you can't tab out of it. So the only way to escape is to close the browser and start again. We identified that there are 5 different traps that can occur on mobile sites and native apps: the exit trap, the swipe scroll trap, the text-to-speech trap, the headset trap, and the layer trap. So the exit trap, you need to ensure there is always an accessible actionable item, e.g. a close button that meets color contrast requirements and has an accessible name that closes any feature that overlays the current page, such as a full page ad. It applies to all users, and it's both methodologies. This is an example here. You have a full page ad. You can see there's text just at the bottom here, and there's no real way to close that ad. You can't tap on the address. The back button doesn't work. So that's basically the only way you can get around that, is to close the app and start again. This is a much more common example where you have a pop-up when you first go onto a page, and this fails because the close button is very, very small. It doesn't meet touch target size requirements, and it also doesn't meet color contrast requirements. So the swipe scroll trap is: ensure you do not override standard mobile touch functions, swiping, scrolling, etc. on the majority of the page. So this applies to touch users, and the mobile methodology is mobile site and native app. This is an example. It doesn't exist anymore. I call it the zoom of doom. If you swipe anywhere on the map moves. The only way to swipe up and down the page, because this is just a map on a page with content above it and below it, is to hit these small areas of white around the map itself. And that's almost impossible for a number of users. So that's the swipe scroll trap. The text-to-speech trap is: if the app has an ability to provide content via text-to-speech, the screen reader user must be able to pause or stop the app speaking in a similar manner, e.g. by performing a swipe on a screen. So this applies to screen reader users, and the methodology is native app. And this is an example here. This is Pocket. It allows you to speak an article, but once activated, you can't turn that speech off. Now, why would that be a problem? The problem is that a screen reader also reads aloud content. So in order for the user to find out how to turn off that speech, they're going to have to listen to their screen reader, but they can't listen to their screen reader because the article is speaking at the same time over it. And now this is extremely problematic, especially if then the next article just plays automatically. And then you've got a headset trap. So headset users must always be able to pause media, audio or video content by using the pause play control on the headset. This applies to screen reader users, headset users, and it's both methodologies. So here you have, this is just a weird thing, a website, and there's a video that's just popped up in the bottom right hand corner. If you want, and it has audio as well as movement, and if you want to turn off the audio, you just have to tap that little mute button. But of course, once again, the screen reader user, if they're using a headset and they hit pause, the pause doesn't pause that video, the pause pauses the screen reader, and they have the same problem as before. And last but not least is the layer trap. The user should not be trapped on a non-visible layer. It applies to all users, but mostly encountered by screen reader users, sometimes keyboard users, and it's both methodologies. So this is an example here. You have just an ordinary website, and if you tap on the menu, For the visual users, that's fine, but for the screen reader or the keyboard users, they are stuck on the underlying layer. So why is that a problem? Because A, they can't access the menu, B, they can't close the menu, and C, they can't see what it is or activate what it, as a keyboard user, they can't see what it is that the keyboard is actually on. So this is a real problem. So you can find details of each of these traps on the Accessibility Oz blog. I've put a lot of detail into them, so they are at least HTML, those ones. And then the next step is to test mobile specific issues. There's different categories in step 4. It's alternatives, display, actionable items, navigational aids, audio and video, forms, and mobile desktop interactions, so for mobile sites only. So I'll show you an example from the document. So everything that you see is in PowerPoint, but is actually in the Word document. So the requirement is touch gestures. Any touch gesture must have an alternative any touch gesture must have an alternative, accessible, actionable item. For more information, see Success Criterion 2.5.1 pointer gestures. So this is very similar to WCAG 2.1 requirement, the Success Criterion 2.5.1, but we have detailed it in this methodology as well. So what is a touch gesture? Touch gesture, swiping up and down or left and right, dragging up and down or left and right, double tapping, tap and hold, tap and swipe, 2-pinch zoom, and press and long hold. And so the requirement is any touch gesture must have an alternative, accessible, actionable item. So what is an alternative, accessible, actionable item? It is a link, a button, a drop down, or a separate page with the same functionality, coded in, coded accessibly, of course. So each requirement has an about this requirement section, which I'll read. You may notice that I'm reading from the slides, and that's because there will be some people here who can't see the content on the slides. So I'm making sure my presentation is accessible. So this requirement says, this requirement is particularly important for screen reader users. For example, if you require your user to swipe right to complete a purchase, when the screen reader is on, the swipe right gesture moves you to the next focusable item and doesn't complete the purchase. You must be able to perform the same action by using a link, an up or down swipe, or some other gesture. Please note that this requirement is similar to the exit trap requirement. A failure of the exit trap requirement is that a user cannot escape from a content or a page. A failure of the touch gestures requirement is that a user cannot choose content or a page, so they're not trapped. And then there's a how to test section, identify any site controls. If they require any of the following gestures, is there an accessible, actionable item provided as an alternative? And then you have the different touch gestures that you need to test. So this is a past example. This is, a weather app, and you can see that some of the content is cut off on the right-hand side. That's a very common indicator that you can swipe from right to left to get more content. But as I said before, there are certain users that can't do that. So even though that content is there, there's also a link at the bottom that says see more, and that takes you to a page that has all the content in a linear fashion. So even though it does require you to swipe right, you can still access all the content by selecting that link. This is another example. This is Google Weather. Obviously, when I was putting this presentation together, I was very interested in weather. And you have a dragger, a dragging thing that you can drag to a particular time to determine what it is, what the weather would be at that time. But each hour and half hour is also a link. So you can just tap on those links as well. So that's another past example. So the next step is testing mobile assistive technology and features. And so there's one requirement that has to work across all the assistive technologies and features. And the requirement is all actionable items and content can be accessed and activated by the following assistive technologies or when the following feature is enabled. And so these are the Android assisted technologies and features that I mentioned before. You've got the iPhone ones and the iPad ones. So this is an example of the New York Times games, which I am very obsessed with. And here, what I've done is I've turned on voice control. And so the little highlight content, see where it says daily, 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 that's what's going to get read to a screen reader. That is basically the accessible name for that content. So you can see that they can't see the screen. You can see that the crossword, PAX, and archive, they're all called the same name. So a screen reader user is going to hear daily, daily, daily. And this is a common issue in New York Times games. So if anyone's here from New York Times games, please fix it. So this is names not being descriptive. This is another example, which is even worse, also New York Times games, where the letters that you're supposed to use for the spelling bee don't actually have any names at all. So they're all just called image. So a screen reader user will hear image, 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 image. Another thing to be careful of is keyboard order. So here you can see the numbers, and the number indicates the order that the keyboard focus will be in. So you can see the first one is the first clue, and then the second is your down arrow, and then the third and fourth, fifth are your items across the top, and then 6 is the second clue, and then 7 and 8 are your items at the top, and then 9 doesn't exist, and then you go 10, and oh no, 9's down there, and then 11 and 12 is there, 13 and 14 is there, 15 and 16, and you're thinking, oh well, that's 17, so that should be 17, but then you get down here and 55 is 21. Your previous button is 34. Your next button is 42 in terms of the order that these things get read or tabbed to. So you can imagine that a keyboard user would find this almost impossible to use because the keyboard focus would be running around all over the place. This is another example, which is not as bad. But this is a Talkback Android. So if they activate the clue, you would expect that it would take you to that item on the crossword. But instead, activating the clue takes you to the next clue. And that's, once again, there's no indication for a screen reader user as to what is happening. So that's just going to be really confusing. This is, this is why grayscale can be a problem. Now, there's not going to be people using, monochrome displays. And if they are, they're choosing to use it. It's not an accessibility issue. But there are people who are colorblind or have various different color issues. And so the best way to test for them is to test your system in grayscale or in various different color correction modes. So if you see this, the left-hand side, you can see the yellow item means that 1 is in focus. But if you're looking at it in grayscale, you can't tell which one of those things are in focus. Now that's really easy to fix, right? You can put a bigger border around what's in focus. So these are the kind of things to be aware of. And then this one, this is increased text size. So as I mentioned, increased text size is very common. And so on the left, you have the normal size, and on the right, you have it on increased text size. And that's not something that you could use in any kind of way. That's not friendly at all. So that's the kind of thing that you need to watch out for. Another thing you need to be aware of is that if you increase text size in your system settings and it doesn't change, that's also a problem. So that's something else to think about. Okay, so what's next? I personally contracted long COVID in 2023. So the whole mobile testing methodology committee is kind of on hold. But there are a number of things that we need to do. We need to update it to include WCAG 2.2. We need to include additional assistive technologies and mobile assistive features, voice control being one of them. You can use the mouse with an iPhone now. Those kind of things need to be included in the methodology. We need to review existing test cases. Some of the traps that I mentioned, they're starting to occur on mobile sites when they only ever occurred on native apps, etc. We need to remove some assistive technologies and mobile assistive features because, for example, if you test grayscale on iOS, if it fails, it will also fail on Android. So you don't need to test both. You only need to test one. And the same occurs with color correction. The same occurs with reduced motion. So you don't need to test both devices. You can test one. And then the creation of an online resource is what I'm really, really, really hoping for. So thank you very much for coming. If you are interested, tomorrow, though it's going to be a terrible time for you guys, I am actually running a session on WCAG 2.1 and WCAG 2.2 editions. And so if you know about WCAG and you need to learn about WCAG 2.1 and 2.2, please have a look at that. We're also running a bunch of training. As I said, it's going to be terrible, terrible time for you guys. If you go to training and then public seminars, that's where it is. We're doing training on WCAG 2.2 for content authors, for developers. If you're really interested in the mobile site and native app, I have a one-day training course which goes through every single criteria, accessible document principles in Word, PowerPoint, and Excel. And if you are interested in that, if you use the access code GameDev is yay, doesn't matter about the case, then you'll get a 10% discount. This presentation will be available on the Accessibility Oz conferences page. And last but not least, you can access the methodology under the resources menu in the Accessibility Oz page. Does anyone have any questions?
Hi, Gian. Thank you very much for that. There's absolutely packed full of information and full of useful advice in there, I think. And I only counted one dog treat.
Really? Wow, they had thousands.
Yeah, you might have just been yeah, you might have just been sneaking those under the table while I wasn't noticing. But I thought I really caught one of them. But there we go. Lost my page there. Yeah, so I thought the examples you had with the New York Times were really fascinating. You know, it's especially the keyboard order on that, the crossword one there. That's really well. I mean, they're all pretty enlightening. I think really, you know, the keyboard order is pretty impressively painful. But also just the fact that you know, the letters are just all of them just read image, and everything's was marked as daily and stuff like that. So those are really tricky. But it made me think: are these games more suited to being, you know, having sort of accessibility baked into them, as it were? You know, based on them being sort of like a puzzle game, and based on like an easy sort of structure there. So, kind of, is there a type of game which is better suited to accessibility?
So I have to say the answer is no. I've always been so surprised at the number of different games that people use, and we actually were an accessibility partner for McDonald's for about 5 or 6 years, and they released the Sonic the Hedgehog game and a whole bunch of different games with their Happy Meals, and we tested them, and they were like, well, Sonic the Hedgehog, you know, you're supposed to go around and collect things and it sounds and blah blah, and we have someone on our team who is vision impaired and entirely reliant on a screen reader, and he made those games accessible by using sounds as well as visual identification and things like that. And he talks about how he plays games all the time because, you know, if you think about it, someone who's blind, there's not a lot of audio described you know, content. If you think about what we spend our relaxing hours doing. For me, it's watching TV or, you know, reading a book or something like that. Of course, people who are blind can read a book, but, you know, not a lot of content on TV or those streaming apps are actually audio described. So there's not a lot available to them. So what else are they going to do? And so games is one thing where, you know, it also often doesn't require, you know, a visual medium. So if you think about the spelling bee, it doesn't matter whether I can see or not to come up with the, you know, 100 words that have those 6 letters. So I think that it's really important, even more so, to make games accessible, because, you know, people with disabilities are kind of locked out of a lot of other content.
No, I absolutely agree. I think it's it's really important thing to be thinking of, and it's very easy to overlook it and to skip it and to miss it. But you know, Sonic the Hedgehog, that's a fairly sort of surprising one to me. Again, because, you know, based on what you're saying there, it does feel like it would be easier, I guess, to implement it on these sort of puzzle games. So how would you go about doing something like Sonic the Hedgehog, which I think would require, you know, faster feedback perhaps than I would expect for an audio description type thing. So how would that kind of thing work?
I personally don't actually, I've never played Sonic the Hedgehog. I was involved with the game, but it was a long time ago. But if you think about it from like, you know, Space Invaders, and that's a very visual thing as well, right? A space invader trying to eat things. So basically, you would have different sounds. Say if there was a diamond in front of you, then, you know, it would make a particular sound. If you turned away from it, then the sound would become lower. If it wasn't on your particular area, then it would be on one side instead of the other. So it's really turning that visual content into oral content or audio content, which is something that we don't really think of, but isn't that hard to do. And I can tell you right now, these games, they were developed and then we added accessibility. It was not something that you know, we had to build in right from the beginning. I'm sure it would have been easier, but it was added in at the end. Yeah, so it was, and there's some interesting documentation around, you know, creating games for blind people and the kind of oral information, because people who are blind, they are much more sensitive to, you know, oral feedback. So, you know, being on one side, they'll notice much more, you know, they can play in that way, in a way that perhaps we regular people can't.
Yeah, I can imagine.
You know, I can imagine a separate set of Steam achievements for playing the game with the blind mode enabled.
But, you know, sometimes blind people are much faster at doing things, because when they use a screen reader, and I sometimes speak fast, but their rate, the screen reader voice, is often so fast that you and I could not understand it. It's just like gobbledygook, and they can understand it because that's how they use it all the time, I guess. So they can actually access a lot more information in that way than, you know, we would think that they could.
I've recently heard like statistics that people were like human body was designed to operate with the sound more efficiently than with the vision. So, for example, in a fast-paced game like FPS shooters, the sound cue is often more efficient for you than what's actually happening on the game. Like you, like on multitude times faster to react on a sound of like a step to turn and shoot than to actually see somebody perform something on the screen.
So audio is very different to visual content. One thing about audio is that it's not persistent. So visual content remains the same. Obviously, whatever changes. But I'm looking at a screen here, and this side of the screen is not changing at all. So if I have difficulty reading, I can look at that part of the screen for 5 minutes to determine what it is that it says. But because oral content is not persistent, you can actually provide a lot more information, because you can have the sound increasing, you can have the sound changing in a certain way, you can have the sound loud, then, you know, not loud. So you actually can provide a lot more information because there's a lot more availability. And that's, you know, I think it's a really interesting concept to sort of think of games in that way.
Yeah. Do you think accessibility would almost force a change in the game mechanic? So if you're kind of having to do things differently based on what cues you're getting, would you have to change the game mechanic, do you think?
What, I don't think so. I'm a really big believer in, there's always a way to make something accessible, and also to make the existing system accessible, not create an alternative. And I think that it sometimes requires some thought, but I don't think that there's anything that you could, and correct me if I'm wrong, there's any kind of game that is so inherently visual, if you use that as an example, that you couldn't make it accessible to a screen reader. Because I mean, the most visual thing that I can think of is like Space Invaders, and I can figure out a way to make that accessible to a screen reader user. So I play a game called Two Dots, and it's a kind of array of dots, and you have to select this section to get rid of the fire and blah blah blah, but it's not timed. So someone with a screen reader could actually go through and select each dot, and it would tell you what it was that those dots were. Now if that was timed, then that might be a little bit different, but it's not timed, so a screen reader user can take the time to listen to those things, as opposed to just looking at it the way that we glance at it.
And I think the idea of something being timed could be I guess an allowance. Let me rephrase that as a question. Do you think it would be useful to have to add in allowances then for change, which do change the game mechanic, because it goes from like a timed based thing that you got to solve to something which is more I guess endless type.
We did have that. Yeah, we did have that issue with one of the games with McDonald's, and they were like, no, this game, you've got 30 seconds and you've got 30 seconds to choose all of these things, and that's it. If you can't do it in 30 seconds, I'm like, it's a game. It doesn't matter if it takes someone 30 seconds or a minute. And so what they did is we had screen reader instructions, and in that screen reader instructions, we had play the game with an extended timeline. So it wasn't obvious or easy for people to choose. It was something that screen reader users would come across. And so they extended the time that way. But yeah, I remember it being no, people are going to get 30 seconds and that's it. And it's like, but these are, the whole point of games is to enjoy them and to have fun. And, it's not, WCAG talks a lot about this, about things being essential. And, a time limit, for example, you need to be able to extend it, et cetera, unless the time limit is essential. What's an essential time limit? If someone's going up for an auction, if someone's doing a test, for example. But a game shouldn't have an essential time limit unless it's supposed to replicate something in real life. So I think that kind of extension, you can do it in a way where it's not obvious, but people who need it can get to it.
I like the idea of giving these allowances while using the technology which requires the allowances. So if you need a time allowance, a time extension, then it's available through the screen reader itself.
Yeah.
So that's a nice way of doing it, I think. Yeah. We've had a couple of questions in the chat. One was asking about screen readers and like a frame rendering engine. So not like a web-based thing like the New York Times, but more of an actual game engine. Can screen readers operate in that kind of an environment?
I don't know. If you can get that person's details, I can do some research and I can send you an email. So I don't know much about game rendering engines. Screen readers are pretty good at figuring things out. 20 years ago, they were terrible, but now they're pretty good. So I would say they probably could, but let me do some research.
Okay, thank
you. There was another question, like, are you aware of blind shell? And if yes, do you have an opinion on it?
I feel terrible. I don't know blind shell. You have to give me a question I can answer.
Right.
But once again, if that person wants me to an answer, I will have a look at it and send an email.
Okay, well, another question then, perhaps. Someone's asking in the chat if they could share data on the size of the mobile market for people with disabilities. I guess, do we know how many people are using the accessibility features?
Yeah, now that's an interesting question because every accessibility testing person in the world would like to know how many people are actually using the assistive technologies. No, you cannot get that information, for love nor money. In reality, it is important to realize that people with disabilities are more likely to use mobile phones than they are to use desktops. So if you have, say, 45% of normal people using mobile and 55% using desktop, you'll actually find that those it's kind of reversed. 55% of people with disabilities are using mobile and 45% are using desktop. The reason why is because people with disabilities are often come from lower socioeconomic backgrounds, so they have less money. So they often, will buy a phone because everyone needs a phone, but they won't have a laptop. They're often underemployed as well. So, I have a laptop for work. I'm not quite sure if I'd have a laptop if I didn't work. So they, once again, are much more likely to use their phone. Also, because of all the assistive technologies and features that are inbuilt into the phones, there are some people who know how to access content through a mobile phone and don't know how to do that on a desktop. There might be some ways by downloading certain products, but it's not obvious to them. They haven't learned how. They only can do it through a phone. So, mobile phones are much more used by people with disabilities. But in terms of who's using what assistive technology, unfortunately, there's no way to tell. Take it up with Apple.
Yeah, I mean, there's a bunch of fascinating points in there. I wouldn't have thought of those reasons for more people using phones. I wouldn't have thought of that as a statistic, but those reasons are all very, very interesting.
So there is a government kind of system in Australia called Job Access, which if you hire someone with a disability who needs an assistive technology, the government will actually buy that assistive technology. So when I hired a vision impaired person in Australia, she said, "Oh, I don't have JAWS, which is a preferred screen reader, but I'll get the government to pay for it." And then she said, "You know what? I don't need a laptop. I can do everything off my phone." And if you think about it, if someone's blind, why wouldn't they do everything off their phone? Because why would they sit in front of a computer? They can't see anything. Why I choose to use a laptop instead of a phone is because there's the 3 monitors. If I can't see those monitors and I can actually access Word documents, et cetera, through a phone, why wouldn't I do that? And so we had a big fight because the government wanted to give her an iPad. And she said, "I want an iPhone because I want to be able to carry it around easily." And they're like, "No, you need an iPad." And she's like, "I can't see the screen. Like, why should I have an iPad when an iPhone would be so much better?" And eventually we got her an iPhone. And she'd be like, "Oh, so I'm sitting outside in the sun doing blah, 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 setting up feedback forms, etc." So, it is something that is quite common for people with disabilities to rely on phones more than, desktop computers.
Yeah, and somebody's just mentioned in the comments as well that it's interesting how advertisers can track a whole bunch of things about us, and yet we don't have this kind of information. I think it would be really helpful if we had access to this kind of these kinds of statistics, because then it makes it easier to argue the case for actually implementing this as well.
But the problem with that is there aren't going to be any blind users using screen readers using the New York Times because it's not accessible to screen reader users. So the New York Times could say, "Well, we don't have any screen reader users, so we don't need to make it accessible." So it's kind of a chicken and egg thing. So, I think that there has been very much a kind of an overarching decision by policymakers and browser manufacturers and stuff like that to not report on this information. But I definitely can see a client saying, "Oh, well, we don't have any screen reader users, we checked." And it's like, because, no one can log into your site. So that's one of the problems with it.
But it'd be nice to be able to get the information sort of industry-wide, as you say,
Yeah.
take it up with Apple and Android, to be able to sort of see that, okay, you know, maybe this site doesn't work with screen readers or other assistive technology, but people are trying to use it with those technologies.
Yeah, industry-wide, that would be fantastic. And I mean, that's what the WebAIM screen reader survey has tried to do, but specifically about screen readers. And that's a great survey, and it has really good information about who's using which screen readers and browsers and how often they use it, etc., etc.
Mm-hmm. Yeah, I think just to finish off, there are a couple of comments in the chat as well about different games and so on, which do work really well with accessibility features. So that's nice. Commented there that Last of Us does a very good job apparently, and they said if that can be made accessible, then so can many others. Yes,
true. I mean, the only thing I can think of that I can imagine you could have a game like, you know, those dance games where you have to, you know, jump on different colored buttons. I can imagine someone who's in a wheelchair would not be able to do that. But even saying that, like, I don't know what you could have it in front of you and press it, or even someone who's quadriplegic could have like a head wand or something like that. I always believe there's a way. And it comes back to, so many people think that people with disabilities just don't do anything. I mean, when I was working with Melbourne 2006 Commonwealth Games, Ticketmaster was the ticketing company, and they showed up with 7 project managers to a meeting with me when I was like, hey, you need to make your system accessible. And they said, well, you know, we don't need to, because people with disabilities aren't going to come to the Commonwealth Games. And I'm like, what about the Paralympics? You know, like, and they were like, oh, and I was just like, you know, you need to think about these things. And so people with disabilities, they're just like, we're all the same, really. So yeah, definitely try to, and some of the things are really easy to do. That keyboard focus order, I don't know how they managed to do that, but someone messed up somewhere. And adding, you know, names to things is not hard, you know, so yeah.
It's remembering it. You know, if you don't need to use it, then it can be hard to remember to actually do it. So making sure it's on your checklist and raising awareness to get it done, I think is really important. Lots of really great info and hints and tips in there. Alex, I don't know, do you have any questions before we round up?
No, I just was fascinated with the video. Like, I am personally a colorblind person, so that's one of the things that the first thing that I done when I came to JetBrains, having a color scheme that was actually working for me, and still this is one that I'm using all the day. And I have a bunch of friends who are dyslexic, and they didn't know, for example, that there are actually dyslexic fonts that are available for them. That when I opened and showed them and like show them how to integrate them into the applications they chose, they said, like, finally, I was like always struggling to work with the application and thought like, that is my life now, that I will be struggling for the rest of my life. But now I'm actually feeling freedom and to be able to work with it. That's really nice.
Yeah, funnily enough, I'm slightly colorblind as well. I get confused between different shades, and some of the games that you've mentioned, like the New York Times ones, similar type things. It's not the is it New York Times? I can't remember. One of those sort of casual games where you just kind of guess at things. They had colors. Oh, it's Wordle. That was the one. Wordle. I think it was the green and the orange or something. It confuses me now, and I have to really kind of concentrate. I have to put it into dark mode, so it's I think it's blue and orange now. So but now it's blue and orange. I can see that they're different, but I don't know which one's which.
Which is exactly.
I don't know which one means which. Anyway, thank you very much for your time, and thank you very much for a really interesting presentation. I hope we'll all take a whole bunch of awareness away from this and try and improve the accessibility in our own games and products as well.
Excellent. Thank you very much.
Brilliant. Thank you very much.
Thank you, Gian. Okay. Have a nice day.
Yeah, that's a lot of food for thought in that one, I think. A lot of interesting ideas.
And apart from the accessibility, like people that are required, there are like a whole new market. For example, I like to like work out or run and to listen to, I don't know, podcasts or books. So like text-to-speech thingy just allows me to read any text, like technical stuff or like C++ standard. The best thing to do while you have a deadlifting. recommend for anyone.
What? You firstly, text-to-speech on a C++ standard. That is going to be interesting. And listening to technical documents while you're weightlifting. We're definitely seeing a whole new side to you.
You train your brain while you train your muscle. Like,
Jeez,
double the work.
You're so wholesome. This is fantastic. Right then, I think we should move on and introduce our next speaker. So do we have Konrad there? Hello, Konrad. How are you doing?
Hello, I'm good. How are you?
Fantastic. Doing well so far, thank you. So what are you going to be talking to us about today then?
Well, we will be talking about kind of tech stuff. So I want to present to the audience how we can think about data and how to process data, because I think if someone is a programmer, I think they know that what is object-oriented programming, but they might maybe not know what is data-driven development and how to move from one place to another and why you should move to Godot. So I want to say something about that.
Well, that sounds fascinating. I think if you're ready, we'll bring your screens on. Yeah, we can see your slides now, and we'll leave you to it then.
Okay, so we can start. So hello, everyone. My name is Konrad, and I'm a gameplay programmer at Fool's Theory. You may know us or not know us. We created games like The Thaumaturge or 7. Now we are working on The Witcher remake under artistic supervision of CD Projekt Red. And in that company, I'm working using stuff that I want to show you today, for example. So this is one of the approaches that we can do when we created gameplay features. So this is a quick look on the agenda. Firstly, I will show you how CPU processes data, because this is kind of important to understand why we are even want to think about moving from object-oriented approach to data-driven approach. So I want to everything was clear for everyone, because maybe not everyone know how it looks like. Later, I will show you some examples how we can use that data-driven development in games, and at the end, there will be some time to talk about that, I think. Okay, so first, how CPU processes data. So if you ever program stuff in any language, I think, but I will be using C++ here as an example, you know more or less how it's working. So if you, for example, create some struct, and this struct will have some variables, these variables will have some space that they need to take some space from your memory. Yeah. So depends on the type you use. This may be 1 byte, this may be 4 bytes. So it's everything depends. And when we are trying to allocate that space in RAM, they are like the CPU trying to find a place for that. They trying to find where there is enough space to allocate that, and is placing that in our RAM. And this must be placed in a good position. So each depends on the size of our data. Different pointers will be used, because pointer address must be divided by the size of the data we want to allocate. So sometimes there will be some, when we are trying to create object, from example from that struct, there may be some blank spaces between data. So you can see this is that yellow rectangle. There is 3 white rectangles, which is like blank space, and this is some blue. So this is what we are called memory alignment. So each data must be stored in a memory that must begin at the address that is divisible by the size of the data. So that's where this is that blank space. But this is not work like that we have some like missing memory here, because our CPU are I'm placing here some dummy data to have one continuous struct of data in that memory. We are not really talking about that much, but I want you to know that this is some space that is filled between these variables. So it's not like this is like, empty space. And now, when you want to do something with that struct, so you have that struct, you have struct that has 2 variables, and you are saying, okay, I want to perform some operation using that timer variable, for example. So you are sending that to CPU, and CPU has something what is called cache. And these caches are three. There are three of them. They have different purpose and they have different speed, I would say. But each of that cache is much faster than getting data like directly from the memory. So when you are saying, for example, I want to perform operation using the timer variable, CPU will check if has that data loaded in his cache, for example. So he will like to say, okay, if do I have this data here in L1 cache? If not, it will check in L2. If not there, it will check in L3. And if not, like there is no data in any of that cache, it will have to load that data to cache using your random access memory. Yeah, so here will be something we call cache miss. And why this is important? Because for CPU, like on your architecture of your hardware, when some data is loaded to cache, this is really, really fast for CPU to get that data. So if something is in cache, it will take you nanoseconds, milliseconds to get there. And if you need to go to your memory, it will be much slower. It's not like super slow, but in some cases that might be visible if you have a lot of objects, which we will talk about that later more. Okay, so this is what is called cache miss. And if you want to have super fast code, your target, your goal should be to not have a lot of cache misses. Okay, but we have cache miss. So what will happen next for CPU? CPU will say, okay, this is address I want in my cache to do some operation on that. So we are not loading only this one part of data we have here, because depending on the processor, data is written in blocks. So we are not loading only one variable, for example, to the cache. We are load the whole chunk of the memory. And this might be 32, 64 bytes most often, but depends on CPU. We will use in that example the 64 bytes. So when you are loading data to CPU cache, we are loading the whole chunk. So we are starting from boundary of that data. So if this is, for example, 64 bytes chunk, we will start, for example, from 0 to 63 address, later 64 to 127, and so we are jumping addresses by 64 if we are using CPU that load 64 bytes of memory. So even though we want that address on 44, for example, that pointer with address 44, we will start with address 40 and we will load the whole chunk. So the CPU will load starting from there, load the whole 64 bytes of memory. Yeah. So this is how CPU works, and what is doing here, he's loading that, and we are calling that cache line. So when the CPU is loading something from RAM, it's doing that using that cache lines. And each cache line might be that 63 bytes, 64 byte, or something like that. And when this is loaded to the cache, the whole chunk is loaded. So we are loading additional data with that chunk. So even though we wanted only that one variable, for example, timer, we also loaded that ID variable, the whole struct, and all the data that was next to that struct in our memory. And thanks to that, if you, for example, want to do something different, for example, we want to do something with ID, so not with timer variable, but with ID variable. So we are using different variable, but now when CPU will check in that L1 cache, this data will be there, because together with that timer, in that whole chunk, there was also ID variable. So thanks to that, CPU will get the data from there really quickly, and that will be super performant for your gameplay or for your code. So conclusion is that from that introduction, that CPU will process data that is contained in one continuous block memory the fastest. So you won't have data next to each other to have the most performant way to process data that you can. And keep that in mind, because now we are going into object-oriented programming, and we want to see how this approach to programming, that is most common one, I think, like how this is utilized, how that memory is stored by that paradigm, by that approach. So I have some sample code there. This is really simple code. We have one class, one actor in Unreal Engine, and here we have mesh component, which will like render some object. We have time accumulator, and we have tick to do some stuff. And what that code will doing is like just scaling up cube up and down. So this is like pulsing cube on your scene. And what I'm doing next, I'm just like spawning a lot of these cubes on grid on my scene. So when you're doing that, so you are spawning the cube on your scene, that your memory might look like that. Of course, this is like simplified image of that. So these lines like here, so they might be much farther away from each other. So it's not like that. This yellow is here, and like 2 lines below that, this is another memory. That maybe in normal situation, they will be much farther away from each other, but it's easier to show you that way. So when you create, for example, that cube, and you are allocating that object will be allocated in one place of the memory. And together with that object, you allocate some pointers, which will point to other part of the memory, and in that other part of the memory might be you will allocate the concrete components you want to use. So for example, that yellow color here, here's your object, and this object has pointer to static mesh component. But that static mesh component is not allocated together with that object. It is allocated in totally different place in your memory. So if you want to do something with that static mesh component, you need to dereference pointer, go to totally different place in your memory, get that object, and thanks to that, you can do something with it. So here, like you can imagine, you cannot use cache lining. I would say CPU cache will not be used in performant way, because in one cache line you have one component, and if you want to use something different, it will be in the totally different place on the memory. So you need to load that data again to CPU. So this will be difficult to reuse. Okay, so this is one object. But if you allocate second object, these components and this float timer accumulator, it won't be next to each other. It will be in the different part of memory. So the object will be next to previous object if you are allocating one after another, like I was. But only that object will be one after another. But the mesh component and time accumulator might be in the totally different part of the memory. Depends on what happened between of that. Yeah. So because of that, still, when you iterate over that object, it will be not really performant to do some operation on that. Okay, so now I created here that, like I said before, I created some scale changing cube, and I want to iterate over all the cubes I have on a scene and just like change its scale up and down. So this is like simple code, nothing really fancy. And this is looking something like that. Yeah. So what we wanna do there, we wanna present what will happen if I want to I want to execute one function over big chunk of objects. So a lot of objects and one operation, and I'm iterating over it like every frame, and I want to do that something with that. And in that object-oriented stuff, because of nature, how that memory is stored, you need to go object by object, because each object has its own memory layout. Each object has its own pointers, and these pointers are pointing to some other part in your memory. And if you want to do something, you need to go to one object, you need to go to dereference that pointer, go to the data in memory where the pointer points, load that data. If you want to next object, you need to go to next object, dereferencing another chunk of memory, load that to load that to CPU, next object, next chunk of memory, next loading to CPU, because these pointers are like not next to each other, they are farther away. So this is not like on our first example at the beginning, that when I created second, when I loaded that one variable in, like, I loaded two variables because they were in one cache line. Here you are not doing that, because when you load one cache line and you want to create something on different object, that different object data won't be in that cache line. So you need to load another cache line, and another cache line, and another cache line. So you need to jump on the memory from place to place. And of course, this will be quite fast if you don't have a lot of objects, but when your object going up, this will be difficult to maintain. So if you look on for example, profiling stuff, you can see that that operation is there's a lot of execution. Yeah. So if I have, for example, 100 objects, I need to create 100 executions. So it's really difficult to execute the same operation on the different objects. I need to process them one by one. And because of that, I need to jump on memory one by one. So this is difficult to optimize in that object-oriented approach. So when we look at the numbers, of course, because you may say, okay, but when I should be scary of that, yeah? So this depends what you are doing, because of course it's not like object-oriented programming is bad. It's of course good, yes, but you need to answer question. Okay, if my system, my game, if I have enough resources to do what I want to do. So if I want to, for example, do that stuff on 100 actors, it's not a big deal because it's only less than millisecond. But when your number of actors is growing up, the time is also growing up, and then at some point you don't have enough milliseconds in one frame to execute that operation. And what I'm doing here is a really simple operation, because I'm only doing like scaling up, scaling down. Yeah. So in normal game, this is much more complex, and you have much less time to do something like that. So when your actors number growing, your time is really valuable, and you need to think how to fix that. Okay, so what problems are with object-oriented programming when we are trying to do something like that? So data are scattered throughout memory. So we have frequent cache miss because CPU must jump from place to place and load the different chunks of memory. So they are not next to each other, they're not connected. So we are not utilizing what CPU is good at. So loading a lot of data in cache and later loading that from cache, because there are no cache for that. We are chasing pointers. So the engine needs to access nested objects, which requires a lot of pointed referencing, because this is how objects are created. Yeah, so we have a lot of pointers. They are pointing on different places in memory, so we need to jump from place to place, like I said in before. Tick overhead, so it's more like engine thing that we have a lot of many virtual calls, because inheritance and this is how object-oriented stuff is working. And also we have some memory bloat, because when we are creating some new object or actor and stuff like that in Unreal, we are not creating only stuff you want to use. So even if your actor, for example, has two variables you want to use, it will be allocated much more memory that is useful by engine to work. Yeah, so you have some variables for naming, variables for stuff that to display stuff in the engine and so forth and so forth. So there's memory bloat. So you need to allocate much more memory than you use. So if, for example, you use one variable which have 2 kilobytes of size, but your whole object will have 7 kilobytes, for example. So I would like just shooting with numbers, but it's work something like that. Okay, so how we can approach that differently? So to approach that differently, we need to start to think in other way about processing the data we want to use. So that's when data-driven development is coming into action. And data-driven development in Unreal Engine is, we are doing that using MAS. It's like plugin provided by Epic Games. If you are using Unity, for example, you maybe heard about ECS, Entity Component System. This is pretty much the same stuff. So in both engine, like the approach for that is same, I would say. But of course, like naming may be kind of different because of naming convention used by developers. Yeah. Okay, so what we want to do, we have data scattered throughout memory, so we want to related data to be kept in a single memory block. So thanks to that, CPU will load with one cache line a lot of data and later use CPU to load that. And thanks to that, it will be much quicker. We don't want to have a lot of pointers everywhere. We want to access memory block directly. So without pointer dereferencing, we want to iterate over memory. We want to change. So then, thanks to that, we eliminate the referencing problem, and this will be much quicker for CPU to do. With tick, because each object has its own tick, so we need to, like you said, like you saw in my profiler, a tick is executed one by one, so object by object. So we don't want to do that. The best would be to iterate only over the data we want to change without need to call function per object. So to execute that in one function, for example. So that would be nice because we will have only one call instead of 100 calls, for example. And we only allocate data we use. That's goal we want to achieve by moving into data-driven approach. So how we can store our data differently. So in Unreal Engine, like I said, there's that MAS plugin, which provides something like that. And this pretty much looks more like that. So we will go like step by step what all of this is. So what is fragment, what is archetype, what is entity. But in like general, instead of treating everything like an object, we want to store our data in the arrays and iterating over that arrays. So how this will work. So let's start with fragment. Fragment represents data used in calculation. So fragments include transform, velocity, LOD index, etc., etc. So you can treat them like some collection of variables you want to use on your object. Yeah. So, for example, when you have fragment transform, that could be, for example, position, scale, and rotation, for example. That will be transform fragment. And this is only to store data. So there is no logic there. This is only storing data, nothing more, nothing less. Next stuff, we have entity. An entity is a collection of fragments that make up a specific agent or actor. So each entity has an assigned ID, which tell us which fragment belongs to whom. So, for example, when you create 5 actors or 5 agents on your scene, and each of these actors will have transform fragment, for example, these fragments will be stored in one array, which will have 5 records in it, and each of that entities will have ID. Yeah, and using that ID, you can get from that array data which belongs to the specific entity, specific actor. So when you are iterating over that array, you are using that entity you want to edit using its ID. So this is just ID. So entity is just ID to use the data from an array. So fragment entities only define the data we operate on. There is no logic there. So this is important to have it in mind. Next stuff is archetype. So archetype is a collection of entities with identical fragment composition. So each archetype is unique and is constructed from different fragments. So you can, if you want to think about that like you would think in object-oriented programming, your archetype is kind of like class, I would say. So because in that archetype, you are like just like saying, okay, for that to achieve some feature, for example, I want to use this fragments and this fragment. So I want this I want these variables and these variables because I need to store data from calculation in these variables. Yeah. So this is kind of like some composition of fragments that will be used to spawn some actor on scene. Okay, and how to process, because what we say now is like we want to define some, like we want to define some some data we are operate on. But how we operate on that data, that's maybe a question. So to do that, we are using something what is called processor. So processor is a single class that is responsible for executing logic and updating state of the fragments. So here in that approach, you have to tell like your data is in one place and your logic is in other place. So they are not connected. So like in the class, you have fields, and you have functions in one place, but there will be totally separated. Yeah, and processor is something what we say this is our function. Entity query is something we are using to get actors we want to change. Yeah, because you have entities that those entities have a lot of different fragments. And maybe you want only actors that have this fragment and this fragment. So with that query, you can filter it out and only iterate over that you want to really change. And the last thing, which is important, is trait. Trait is like a collection of fragments that must create for a given entity to provide specific functionality. It's used mostly for organizing stuff. Yeah, because you want to, for example, if you want look at a feature, for example. You want some fragments to be always there to provide that feature. So you don't want to do that to keep it in mind which fragments I need to provide look at target. You want to group them in some trait, and later if you add some trait, all that fragments will be added automatically, and you don't need to think about that. Yeah, so there's some kind of organizing stuff. So okay, so if you look at object-oriented programming, you will see that you have hierarchy of classes, a lot of inheritance, everything is connected, and data and logic are packed together inside the class. Each object stores its own memory layout. Components are nested using pointers and scattered across different memory locations, and it's difficult to process the same data from different objects in groups. In mass, on the other hand, you have arrays, and arrays store your data. So its data and logic are completely separated. Data is stored in fragments, and entity contains only an ID. It stores no data. Fragments are grouped in memory by archetype and held together, and data is processed per archetype for all entities that match it. Okay, so if you want to move from that object-oriented approach to data-driven approach, we can use our class. And in that case, that mesh component we are using maybe some rendering trait, so some fragments provided by plugin or something we want to create that will render that stuff. So this is one thing. That timer accumulator might be some fragment we want to use, and processor instead of tick to provide that scaling up, scaling down feature. So we create fragment with that accumulator. Next, we create a trait because, of course, scaling up, scaling down needs some fragments. So we need transform fragment to have that position, rotation, scale, and we need that timer fragment to create that animation. Later, we can set that up in the unit in Unreal, and we have some data asset for that. So we are setting, okay, we need the trait for mesh visualization, we need that scaling trait we created. So we are creating here archetype. Yeah. So we are saying, okay, we need these fragments when actor is spawned to process it later. And that's how it looks in the editor. So you just saying you have a special object that you can place on a scene. You are attaching that entity config, and here this is your archetype, and you have that on your level. So that's how it looks in object-oriented programming. Yeah. So data are in different places in memory. And in data-driven development, this is how it looks. So transform and timer are pretty close to each other. And if you create another object, that data still will be next to each other, and so on and so on. And so this will look like that. Yeah. So entity one will be this part of the memory, entity two will be this part of the memory. And thanks to that, if your CPU is loading it, you will have it in your cache pretty quickly, and it will access it pretty quickly because it loads a lot of the data by one cache line and don't need to jump from place to place. Okay, so at the end we have that processor. So how we want to do that? So in that processor we need to do two things. First thing, we need to create that query I said. So we are like saying, okay, to this processor to execute, it needs all the entities that have transform and timer fragment. And from all the entities in the memory, we are like filtering out only this with these two fragments. So if they are here, we are using it. And later we are just getting to that chunk of the memory. We are iterating over entities, and our iterator, so our index is the entity ID. And we are getting the view on that array with that fragments. And we are just like getting that fragment from that array using index, and we are doing stuff on that, and we are like passing this to that array. So we are not using pointers, we are like iterating over the memory directly. So this is super fast, and thanks to that we are doing this in one go. So this is only one call instead of 100 calls like in object-oriented programming. We have only one call, which is much quicker because we are utilizing that CPU caching lines, and this is super quick. So if you look at some numbers here, you can see that with this approach, even if you have 10,000 of actors, this is still less than 1 millisecond. And at some point, object-oriented programming is not even usable, and with mass, you still have some time, which is, so this is very difficult to make it to be not performant, I would say. So this is really cool to have it next to each other. Yeah? And when in your game you can use that, because my example was super simple. So you can, for example, use it to crowd simulation. When you have a lot of NPCs in your game, this could be it. When this is a lot of objects, and it's easier to treat them as a group, not as a unique object. You can use it in bullet hell, where it's a lot of bullets, I would say, floating everywhere on the scene. So this will be much more performant using it that way. You can use to environment effects, for example, because there's also a lot of objects that need to be handled in large-scale systems, like in grand strategies. There's also a place for mass system. So, summary, last thing. So it's not like that OOP object-oriented programming is not usable. It is usable, but you need to decide where to use it. So if you need the complex unique behavior and you rely on built-in systems such as physics, collision, animations, you design mechanics that are heavily oriented on working with editor tools, blueprint, level design, the number of objects is limited, and you care about its debugging, object-oriented programming is super cool for that. So if uniqueness of object is important for you, object-oriented programming is super cool. But if that uniqueness is not that important for you, but you want to treat some group of actors as a group, so you can iterate over it and do some stuff, then mass is super cool for that, because you can handle hundreds of thousands of actors pretty quickly. Objects share simple data and behavior. You care about maximum efficiency. You want centralized data-related logic. So bullet system, crowd system, status effect, particles, environment effect, all of that is super cool when you use mass, because you can do it in one go. You can utilize CPU cache, and this is super quick. So I would say OOP for uniqueness and mass for something that should be treat as a group, but by your code. And that's everything from me. So thank you for your attention, and I hope you're still with me with that technical stuff.
Hello there. It was a red presentation, but alongside that, we've unfortunately lost Matt. He has some pretty heated argument with his internet provider. So yeah, we had some obstacles. So while he was still with us, he had a question, like specifically as a mostly C# developer, like what actually mass means, like the acronym.
That's very difficult because I checked that. I will check that because I checked that yesterday because I thought it will be a question like that.
So while you are on the search, Rider at the JetBrains can actually show the alignment in Toolkit for your like fields of the object. Although recently, while we were digging heavily into different like compiler implementation, turns out that every single compiler toolchain like GCC, Clang, and MSVC, they use different semantics and differently align the structs depending on the attributes that you use for the structs. So be aware.
Yeah, that's true.
So yeah, sorry, I've been having kind of technical difficulties back here, so I missed a couple of things with the mass. Is mass a system using yourself created, or is this something that's available for others to use?
Yeah. This is usable for everyone because this is how Epic wanted to have, because they wanted to have some plugin that utilize that data-driven approach in games. So they provided that mass plugin like some time ago, but it was experimental for some time, and now like I think some versions ago it become like part of the engine that everyone can use, and you can like do stuff with it. So it's not like super it's not like unique stuff that I created. I'm sharing with you. It's like mass. It's Unreal part, so you can use it. And I only wanted to show how it could be useful for you.
Yeah, no, that's cool. I hadn't realized it was by Epic and it was actually part of the engine now. So that's really useful. It's going to be available for everyone to use.
Yep.
So ChatGPT says that mass is actually like a massive array of structural simplicity. So maybe just like a...
Might be. To be honest, I never think about that, because for me, like I heard word mass. For me, it would be it's obvious because there's a lot mass of factors I want to handle. So for me, I even didn't thought about that it will be what is underneath. Yeah.
For me, it just sounds like a fancy way to say like the instead of the array of structs, the struct of arrays.
Yeah. That might be that, because on the when you look at this, okay, this is a struct of arrays, but underneath you need to switch your mindset, I would say, how you organize data to have that struct of arrays at the end. So I think if you say struct of arrays, it would be the whole picture. So that would be misleading for someone. Yeah.
Mm-hmm. Mm-hmm. It does feel like a very different way of thinking about your data and everything. How easy is it to rewrite from one system to the other, from classic object-oriented to something like mass?
Okay, so that depends mostly on the system, because of course if system is quite simple, it will be quick, but if this is really big system, it will be difficult, but take months, hours, months, years even. So I think it's not the best idea to go with totally revolution of your system. It's better to, for example, if you have huge system in object-oriented, you should use your profiler, find places that are not really performant. So when you need to optimize it and just move only that places. So these critical places that are most heavy, that should be moved, and that could be like that. So some kind of evolution, because it's not like you can easily move object-oriented into data-driven, because you need to rewrite how data are organized, because this is a totally different approach, totally different mindset, everything is different. So it's easier to find what should be moved and move that step by step. And it's difficult to say how long could it be, because it's case by case, and you need to find places you want to move. So I would recommend something like that.
Mm-hmm. Would you go straight to something like maths, or would you do object-oriented first and then only change when you've measured and you can see that actually you need something a bit more performance?
Well, I think still my favorite saying depends on the system, yeah, because sometimes you have some system that you know from the very beginning that will be big, will be difficult to maintain in object-oriented programming, and in that case you can go straight to math and don't care about object-oriented programming. But in most cases, I think you can start with object-oriented programming. So, for example, in that example I said about bullet hells, for example, you can start with object-oriented because this is easier for everyone, and maybe you wouldn't have that many objects to consider that a problem at any point. So in that case, you can stay with object-oriented because it will be easier for you to think, because it's easier. But if at any point you will see, okay, this is going to out of hand, my time is reduced, I doesn't have resources in my time frame. So in that case, you should move. Yeah. So depends what you want to get. So if you know from the very beginning, okay, I want to use thousands of vectors, you go math, because with OP will be difficult. But if you have some number, but you don't really know at the moment when you will end up with that, you can start with object-oriented and you decide it later if you want to switch, for example.
Mm-hmm. It is nice to know there's a migration path, but also it's a classic software answer of it depends.
Yeah, it depends, because it always depends, unfortunately. Yeah. There's no easy
always
answer.
It's always the best answer. Well, thank you very much for that presentation. That was really interesting there. It's a great visualization as well of how to understand this problem and how it can impact you as well. So thank you very much for that.
Thank you.
And Alex, have you got anything you want to add?
Nope, I guess not.
Very good. Well, then, thank you very much, Konrad. We'll say goodbye for now. Very much appreciate your time. And I think looking at the time, we'll get straight into our next session, which is great. That should be Dom, I think, if I'm reading it correctly. And there's Dom. Hello, Dom. How are you doing?
Hello, I'm good, thanks. Yes, how about you?
Well, if my internet holds up, I'll be a whole lot
Yes,
more relaxed, I'll tell you that. Because it's only another 6 or 7 hours left of this. I mean, what could possibly go wrong? Anyway, thank you very much for joining us. And I think you're going to be talking to us today about, what was the topic again?
Optimizing on the web. So specific
Fantastic.
Optimizations for web games.
Brilliant.
Web games are a bit of a growing market, and there are some challenges.
Oh yeah, very much so. Right, we've got your slides on. We can see those. If you're happy, we'll leave you to it.
Brilliant, thank you. So yes, I'm going to be talking about optimizing on the web. I've got some specific tips for Godot and Unity, but it's broadly applicable to kind of most of what you're doing. Unreal Engine doesn't build for the web in UE5. They got rid of that, so not so much for Unreal. But I am Dom. I am the web games advocate at Crazy Games, and that is a fancy title to say I am the techie on the business team. So I kind of bridge the business team. So that's kind of outreach to developers, kind of doing SDK integrations and that sort of thing, and partnerships in particular. And I kind of bring all of the technical expertise to that team. So over the last 20 years, I've been making games largely in Unity. I did 10 years professionally using Unity to make apps and games, and then moved on to Crazy Games, and basically I've used every engine. I actually started with Flash games, so I've been around the web game space for quite a while. I've got quite a fun job because I get to basically make stuff in all of the engines and make stuff work. So I'm talking about the web in particular because it's actually a really exciting space. As an indie developer, you don't really have to put as much resources into your web games. So it doesn't have to be these big 40-hour epic games. You don't need a massive team or a year-long development cycle. Like, you can do smaller games that work well, and that it just kind of de-risks, and you can earn a bit of money from that, and then you can kind of build that over time. There are a few challenges on the web, so it's largely a different audience. So there are a lot of players. Web games tend to be free with ads, but that does mean you get tons and tons of players. On Crazy Games, we have 45 million players that come back every month. And that usually translates into pretty much every launch game seeing 20 to 50,000 players in the launch week. But the problem with that is that you've got to keep them coming back, and that kind of ties into why optimization works really well, or is really important, sorry. But the kind of core things you focus on are playtime and retention, and those numbers both go up when you've got a really fun game. And that, to me, just is really good, because that's the bit that, as a game developer, you want to really focus on. So that's a bit about why web games are great. But the big challenge in web games is getting players into your game. And for this talk, we're going to be focusing on getting your players playing the game as quickly as possible. You need to get players playing fast on the web. You really, everything you can do to cut down that initial load time is going to really improve the amount of plays you have. So why does it even matter? This is some research Google did a little while ago, but for every second, the bounce rate, so players that see a game and then leave, goes up a lot. So 1 and 2 seconds, kind of around the same ballpark. Then as soon as you start getting beyond 3 seconds of loading time, players are bouncing at really high rates, and you don't want that, because web games are all about numbers. So there's a bit of research that's been done that says basically there are 3 kind of levels of interaction time for the player. So less than 100 milliseconds is kind of seen as instant. So you don't really need to give any feedback. The player feels like the actions they take immediately make an effect on the game or on what they're doing. Under a second, you're still in this state of flow. So the player's not interrupted. You still don't need to do anything, but they have noticed the delay. They're starting to think, okay, something's not happening. It's not instant. And then kind of above that, in the 1 to 10 second range, you really need to put something on the screen. At this point, the player's attention is wandering. They're thinking about other things they can do. They've lost focus on this. If you have something on the screen, whether that's a loading bar, a nice little animation, some text to kind of explain your game, in Skyrim, they have the loading text that gives hints about the game and little background bits of context. All of that sort of thing is really, really important if your load time is kind of greater than a second. And then above 10 seconds, probably a lot of your players have already left. So this is really, really important, because you want your players to be playing games. So providing feedback as quickly as possible is the main goal with a web game, and optimization in a web game. So actually, Google, in that feedback, in that research they did, it was at 5 seconds, 90%, the probability of a player bouncing has increased by 90%. So that's, you need players, and you want players to be playing your game. You don't want them to be leaving. So you have to kind of switch your thinking about optimization on web away from runtime performance more into this initial load time. That's where the bulk of your effort should be spent. And your objective isn't to load the full game instantly. It's to get something on the screen that the players can see is happening and kind of move along a little bit with that. So the actual loading process, when a player clicks a link and sees your game, the browser will download the game. That's obvious, I know, but it's worth saying. The bigger your game files, the longer this download's going to take. Once it's downloaded the game, it then executes the JavaScript and WebAssembly files. The engine initializes, it decompresses and loads the assets into memory. Your first game scene loads, and then all of your initialization code runs, and then your first frame's painted. So everything we can do above that first frame paint will dramatically reduce your load times. So what do we actually do about it? So we kind of split it. Oh, that came in backwards. We split it into three parts. So there's the download, which is the kind of bulk of the waiting time. A lot of the time you'll have a progress bar, but that is going to be the big wait time. Initialization is when your players are stood staring at a black screen and nothing's happening before the first frame paints. And then runtime performance is all of your kind of, while the game's running, there are extra things you can do. I'll touch a little bit on that at the end. But so to improve your download speeds, the big thing is loading the initial content first and then kind of loading things in the background. For initialization, you want to look at engine stripping and then your code and what happens in your code in your kind of start and await methods and init and on ready in Godot. The first thing we do is split out the download. So the main way to do that in Unity is through the addressable asset system. Your game assets are all by default included in the main game files. That is like absolutely everything in the game. So your players seeing the tutorial, but the assets for the end game boss, they're all downloaded at the start. In addressables, you can basically split that into addressable groups, and that basically packages each bit up and you can load them separately. So you might have one for level 1 and level 2, and then like that you can package it in different ways, whatever makes sense to you. And the big thing is loading addressable assets is async. So it doesn't actually block the game. So you can run it in the background and still have things animating on the screen. And for the player, that feels really, really good. It holds their attention a bit more, basically. So I assume if you're using Unity, you know what the package manager is. You install addressables through the package manager. Once you've got it installed, it adds this little checkbox to all of your assets that can be made addressable. And that includes folders. So you can package things, like bundle things up in your game assets window in a way where you can just mark the entire folder as addressable, and then that kind of takes care of that. By default, the text input next to the name there will be just the full path of your the asset, but you can change it to something a bit more memorable. So I've done that here. And then you've got groups, and those groups are what packages it all together. So addressables are a massive, massive subject. I'm not going to have time to run through it all at the minute. Like in this talk, there are a few other resources. I'll send some links, and I'll share some links on the screen for some other resources about that. But this is kind of the bulk of it. You mark your assets as addressable, you put them in groups, and then you load it by this text input that's here in the game, in the asset window. So you can set up addressable asset groups. So you can have as many of these groups as you want. These are the bundles. So like I said, you might have them split by level. So level 1, level 2. I often do some background music as well. So while the player's in the menu or the tutorial or whatever, there's some extra music that I load first. And as soon as that's loaded, you can kind of immediately use it. So that's really useful. You can use labels to organize them as well. So using a label, you could start downloads on multiple groups at once. And then once you've marked them, all of the assets that you want to use as addressables, as addressable in Unity, and you've assigned your groups, set up your labels. Then there's this build option here. The default build script is the one that I just always use. It's really easy. Unity just has that packaged in. That will build everything to a specific folder. Again, I don't really have a huge amount of time to explain this in detail, but that builds it into a separate folder. You can put that in streaming assets, and Unity will load that in. And you can, yeah, it's a very, very simple bit of code. It's quite similar to the resources folder. So resources.load, you actually just have addressables, load scene async and load asset async. And these are tasks as well, so you can do it asynchronously. You can show progress bars, all of that good stuff. And you just load it by that string name, the string path. Like I said, I could do an entire talk on addressables. This is just to kind of get you into the mindset of, okay, I need to split out each part of the game and load them separately. There is a lot to learn with this. It's a big system. It's a cool system. It does some really great things. You can host things externally. You can update content on the fly. It's all included in addressables. I recommend you use the Unity Learn course. That's what's linked here. That's what's in the QR code, and that'll kind of get you up and running. And then for Godot, it's a little bit more involved. The steps are broadly the same, but there isn't a specific single system that does it all. So again, all game assets are packaged into the main PCK bundle. You can split that out into separate PCK bundles. That's similar to the addressable groups in Unity. You basically combine these by stuff that is used together. So you can load one chunk of things and have it run and have it download, and then you can use it immediately. And then you can asynchronously load your PCKs with resource interactive loader, and that won't stop block execution. It won't freeze the game. So again, async stuff is good on the web. So there are three main steps to the Godot resource system. You export as separate PCKs. You then have to manually download and manually mount that to the file system, and then you can load it. So it's a little bit more involved, but it still achieves the same goals. So the first thing you'll do is create a new preset in your export templates. You'll just choose the specific files you want to use. So you can change the export mode to selected resources and dependencies, and then you select which one you want, and then export the PCK, and that will bundle it all up. Then you can host that somewhere yourself. Godot doesn't really have anything similar to streaming assets, so generally you'll be hosting this on your own server. You first have to download it. So if you're using Godot and you're making a web game, you probably know how to download things, but I've included some code here just to illustrate. Once you've downloaded it, you then have to write that to the user's file system, which is an extra step that you wouldn't necessarily have to think about, but you do have to write it to the file system so Godot can then load it in. And then after that, you use the resource interactive loader to load it in. Because if you don't do that, the Godot is going to load your entire bundle in the same frame. It's going to cause the whole game to freeze. You might get a black screen. The game will just pause, whatever. That's not good for a player. They don't tend to like things just freezing. Then the next thing to bring down your build sizes, hopefully using splitting out your assets into different downloads or addressable groups. Hopefully that saved a really big chunk for your initial download. But the next thing you do is compress things with Brotli compression. Brotli tends to be the best. Generally, you get a 15 to 30% reduction in build sizes compared to uncompressed. In Unity, it's just a check mark. It's just a drop-down field. In Godot, again, it's a little bit more involved, but generally Brockley compression is the one you want to aim for. It's a really good standard, and you get really good compression, and the browser handles it. In Godot, like I said, it's a bit more involved, but it is possible. Once you've exported your HTML build, you will you can just use the Brockley in the command line. On Windows, I usually just go through Git. On Unix, it tends to be included in the terminal, so it's already there. So you can just Brockley your build, WASM, and PCK files, and then in the export settings, you also want to uncheck embed PCK so that basically your game assets stay external and you can compress them as well. So that's Brockley compression is good, 15 to 30% reduction in build size. Generally, these two steps combined can take a Unity or Godot game from over 50 megabytes to under 10, which is broadly where I would aim for, is 10 megabytes on your initial build size. Then once you've done that, there are also some just quick fire settings to change. So in Unity, you can override the compression for web and use the ASTC block compression. It's really, really efficient. It will really crunch down your file sizes. It does trade a bit of quality, but there are certain levels. So 8x8 block is smaller but lower quality than 4x4 block. You can you'll need to fiddle with that, see what makes the most impact, see how much you can reduce the quality without it making a noticeable impact in your game, because obviously when you compress things have lower quality. But it is really, really important to compress all of this stuff so you can get your build sizes down as low as possible. For audio, you can force it to mono where possible. Players don't tend to mind where their sound effects are coming from, or if the music has stereo effects. And you want to load in background for all big tracks, because that will, if you don't have that enabled, that will take a second on startup to load that into memory. And then 3D models, there is vertex compression that you can enable. Again, you can play with how aggressively it compresses them. And then you also want to disable read and write on your 3D models. Unless you're actually using that API, this just adds a bit in memory, and it's better to keep it off, basically. There is this setting alone, the Show Unity logo and splash screen. That setting alone saves a megabyte in your final build size. It's a really big texture. I'm not entirely sure why they include it by default now, because in Unity 6 Plus you don't need a pro license to hide the splash screen. There are issues on some versions of Unity where if you just disable show splash screen, this texture is still included in your build. So enable show splash screen, disable show Unity logo, and then disable show splash screen again. That will remove it from the build properly. This is something I fought with for quite a while. But Unity has a build report and project auditor package that will help you figure out where issues are. And then if you're uploading to Crazy Games, we have an optimizer, and within our SDK, that will highlight potential issues and let you apply fixes as well. So we've got some good systems in place for Unity. And in Godot, there are fewer settings to fiddle around with in Godot for this sort of thing. You don't get as much. You have to do it all a bit more manually. But the broad principles apply. Compress your textures, compress your models, use single channel audio, that sort of thing. I don't know if you've ever published a Unity web game, but you'll see this screen for sometimes 5 seconds, and for a player that is really, really frustrating. That's the next kind of step in the process. So once you've actually built it, exported it, the users downloaded it, you then sit on this screen for sometimes up to 5 seconds. This is the step. Well, I'm just going to go back a second. This is the step where Unity, Godot, whatever engine you're using, kind of initializes everything. It starts to run all your code. This is the step between I've started executing and I'm painting the first frame. So the bulk of that is going to be engine initialization. So there are things you can do to strip the modules that are included in the engine. So in Unity, it's very, very simple. There is a strip engine code check mark. You can check that, and you can set the manage stripping level to high. You'll want to play around with this. Sometimes that can get too aggressive, strip out code that's needed. If you're using a dependency injection framework, that they can sometimes struggle, but there's something called a link.xml file. You can specify assemblies and classes that won't be stripped during code stripping. Again, a bit too off topic for the talk, but it's something you can do. It's something that's good to be aware of. Not everybody uses DI frameworks, so it's not super relevant. But if you're finding that you've set your stripping level high and all of your code's gone, this can be why, and this can help. In Godot, it's again a lot more of an involved process. You have to build a custom export template. Godot have some documentation on how to do that. I can't go into it now. I just don't have the time. But this can save 10 megabytes in your initial download. It can save a couple of seconds on your on that grey screen. So it's really important to know, to be aware of. They make it a little bit more helpful because they've got this engine compilation configuration editor. That's a mouthful. I'm impressed that I managed to get that out first time. But this will let you figure out what modules you need to include. Without this, it was an absolute nightmare to actually go through and try and figure out what's being used and what's not. But you have this detect from project button here that will scan your project. It'll see everything that's using each of the different modules, and it'll give you some suggestions for what to enable and disable. That's a much more complicated process, but it really is worth doing. It can save a lot in your startup time. And now we come to runtime performance, and I'm aware that this is quite far into the talk. I'm going to do some quickfire general tips because this is less important, but browser games are still they're largely CPU bound. So there are some things to be aware of. So the main thing you'll want to be doing is taking things out of update loops, running things asynchronously where possible. Like Unity has tasks, Godot has async await. If you're doing things every frame, that will slow things down. And generally, the crux of optimization is just do fewer things. This kind of applies to the initialization step as well. So when the game first runs, all of your code that happens in start, awake, anything that's loaded into singletons when the game first starts in Godot, it's your preload objects, auto load objects. That's the word I'm looking for. All of that sort of thing that happens at the start that can increase that startup time. So do fewer things is the main thing to say here. So sorry, lost my train of thought for a second there. In general, on the web, your CPU bound, so you want to keep the your actual game code as light as possible. There are a few things you can do. General best practicing, pool your entities. So if you're instantiating and destroying, or in Godot, you are creating and freeing. If you're doing that multiple times a frame, that can generally hurt performance. So what you tend to do is load them all, not necessarily at the start of the game because you want the startup time to be quicker, but you can kind of load them all in one bucket towards the start of the game, and then enable and disable objects as you go. You want to reduce your allocations wherever possible. And garbage collection's a weird thing in the browser. It's inconsistent and unpredictable, and it's really frustrating to work with sometimes. My general rule of thumb is I'm not ever going to allocate something in update or I can't remember what the analogy is in Godot. My brain has just completely frozen. But basically every frame I'm not doing any allocations, because the garbage collector can just run and cause a stutter. And even if that stutter is only a couple of milliseconds, players notice, and it can really impact how it works and how they feel about the game. The physics of your game generally, also if you can reduce the physics time step, so the fixed time step in Unity and the physics step in Godot, if you can reduce that to 30 FPS, that'll do wonders as well. You really are CPU bound on the browser. I actually think I've talked really, really quickly and I'm way ahead of schedule, but I'm going to talk a little bit about the future now. So WebGPU is coming. WebGPU is an evolution of WebGL. You get much better access to the GPU from within the browser. So you can do big 3D games like this. On Crazy Games, we've got a couple that are already working. And I think we were the first commercial platform to have web games running and making web GPU games running and making money. But this is a really big thing for performance because being so CPU bound, it's good to offload stuff to the GPU where possible. So in web GPU, you can actually use compute shaders. I use compute shaders for I use compute shaders to run thousands of bullets in the browser. So I got 120,000 bullets on my bullet hell game running at 60 FPS in the browser, which was only possible in web GPU. And that is everything that I have to talk about. I talked really quickly. There's a lot to go through. So actually, it's probably good to have a bit of a longer time for questions. So if anybody has any questions, do let me know. So I'm gonna wrap up there a little bit early.
Hi Dom, thank you for a great presentation there. Lots of good stuff going on in there.
Yeah, a lot to run through.
Yeah, very much so. Just as a reminder to everyone, if they have any questions, please put them in the chat. We've got a bunch of questions for Dom already, but we'd love to hear any more that you've got going on there. The first one I'd like to ask though, because you just mentioned web GPU there.
Yep.
How does all of this, the games in the game engines in the browser, how is it that they actually work? Where does web GPU come into it? Is it WebAssembly? Is it single threaded? You got the garbage collector, so that's going to be like kind of single thread and that kind of stuff. So what engine are they actually using?
So usually it's WebGL, and there's basically you have a WASM bundle, and that's how everything loads. It's very similar for web GPU. It's basically just what it uses to render, and it just gives you a bit more access to the GPU. That's a big question, and I don't quite on the top of my head have all of the answers to that. But it's basically new rendering tech for the browser, and all of the major browsers support it now.
Yeah, cool. So the web GPU stuff then, is that like is that with Godot or Unity or both?
So both of them, and a lot of other engines are supporting it now as well. So Godot introduced experimental support in 4.3, I think it is, and Unity introduced experimental support in Unity 6.1. And they're broadly, by the end of this year, it'll be out of experimental in the game engines, but I've used it in both. It works great. it's
No.
experimental by name only, I think, at this point.
Nice. That's nice to hear, actually. And kind of how is it that you use it? You know, is it special APIs, or is it
So-
just the way it compiles things, or what?
In Unity, you just switch the render target. So there's a checkbox, and there's a checkbox currently. It defaults to auto select rendering framework. You deselect that and add web GPU, and it's a similar process in Godot. I can't quite remember off the top of my head, but it's a similar process there. And then other game engines just use it by default. So Defold, I think they just have it enabled by default because it's so it's so prevalent now. It's actually
I do like a nice simple checkbox. It's got to be said.
Yes, yeah.
We wish more things were just a nice simple checkbox.
Absolutely, yeah. Have we got any more questions?
Yeah, I have some personal questions. Like, I'm not really familiar with, for example, Unity addressable or Godot resources. I wonder if you can split the process of loading the resource into multiple stages. So, for example,
yes,
while you are still in the process of loading the main menu, triggers the load, for example, of the last save game. So for the gold path, you have the shortest loading times, and for the game.
Exactly. Yes, that is exactly right. And Unity will cache them. In Godot, you can set something up again, more manual process. But in Unity, it will cache them as well. So if you've downloaded it before, it'll download again really quickly. And yes, broadly, what you're saying is right. You split them into different groups. You can load them whenever you want in the game. So as you're finishing level 1, you might hit a certain hitbox, and it will start loading the next level in. And then by the time you actually reach the end of the level, you can start that level. But oftentimes, what I do is only do the initial game download. So that's basically a loading screen, and maybe one shader to animate some dots in the background so it moves around. That's all I put in the main game folder, in the main game binary. And then I'll use addressables to load in the menu and the tutorial, and then you can have a progress bar there for that. And that's just that bit of feedback that the player needs.
Right. So pretty much that answers my question. There we have a question from the audience. So when you separate the assets and compress them for Godot, for example, do you also need to manually decompress them after they have been downloaded, or it's handled by the engine?
So that is handled by the browser, actually. So when you download something in the browser, that will then that'll decompress it if you use Blockly or gzip compression. You need to set the content encoding headers on your server for that to work. But it is just handled automatically. Basically, you download a .br file, and once that is finished downloading, the browser then decompresses it and then gives you the data.
Got it.
So how much of it is handled by the browser, and how much of it is handled by WebAssembly and so on?
So it's actually, I'm not 100% familiar with the process, but as I understand it, any download that comes through the browser basically has an extra step at the end, and the browser will decompress the Blockly files or gzip compressed files.
Yeah, and so it just uses the normal browser cache and things like that. Yeah, I always think when you got WebAssembly, it always feels like it's just a completely different world. I never quite realize how well integrated it is, actually.
Yeah.
Yeah. Did you have a particular favorite amongst the different engines with?
I have used Unity for so long. Everything Unity is just second nature to me.
Yeah.
I'm building that familiarity with Godot. I like the way they do some things. I don't like the way they do other things. But that's mostly because I am very Unity brained. My recommendation, if you're starting, is Godot, because basically, it being open source, it's much easier to get started with. It's a 50 megabyte download last I looked. It runs on any hardware whatsoever, where Unity is sat there downloading a 10 gigabyte engine. So it's lean, it's easy to get started with. GDScript is quite fun to use and really easy to get started with. So Godot tends to be my recommendation for newer developers, but I'm Unity through and through.
That's quite interesting. Then sort of saying you're Unity through and through, and yet recommending Godot.
Yeah. I think so. There are a few things with Unity that are more complicated than they really need to be. C# is a more difficult language to get started with than GDScript. There are just a few things like that, and I really value for newer developers the ability to just basically download an engine and have it there running straight away. With Unity, it's such a big download that it's quite a barrier, really.
Okay, yeah, still quite an investment to get started and get going with Unity.
Yes, but it's still entirely doable, and they've got a lot of really good first party tutorials.
Yeah. I mean, that's where Unity started, really, wasn't it? The ease of use and getting going.
Yeah.
I think we've got another question here as well. Is there ever a reason not to compress textures and 3D models in order to keep them at a higher quality?
So that is up to you. If you basically, when you're making a game for the web, you'll have an idea about how quickly you want users to get in. You'll have some threshold for, actually, this is now unacceptable and I need to look at the download size. Obviously, as a game developer, you don't want to compress the hell out of things and have it all look a mess, but it is worth it on the web. Generally, I just default to compressing everything as much as I can and seeing if I can make it look good with those highest settings, those highest compression settings.
That's actually an interesting topic about your expectations and what you are looking for with performance, because I've heard for some of the not game dev related, for example, but I know a story about one massive digital shop that was actually ABA testing, slowing down specifically the web view of their store to figure out when the retention goes for the user, so they know how much of the background do they have the resources to add new features and utilize more resources before they will start to lose the user.
That's a nice idea. Figure out what your budget is.
Yes, exactly. Yeah.
I guess a bit of a follow-on from that actually is what about testing and ensuring that you are kind of fitting in within these boundaries and guidelines that you're after?
So largely my process is build it and see. That can be a long process for some game engines. Unity web builds can take 30 minutes or more. If you enable all of the compression settings and things, it can be up to 90 minutes. I've had it in some builds, but that's the best from my experience. The best way to see how big your build's going to be and how quickly your game runs is to actually just get it built and running.
Is this the kind of... Sorry, Karen.
I was just going to say you have profilers in both Unity and Godot and in Chrome itself, and you'll be able to see what's kind of taking time. You can profile each individual bit, and when you build in Unity, I'm not sure about Godot, but when you build in Unity, you get a build report, which is like a log file in your projects in your directory. And that log file has, it's called build report. It tells you what's taking up the most room in your build. So if you've got a 30 megabyte texture in your build, then that will flag it at the top and say, hey, what are you doing?
Yeah. But it's still up to you to actually check that build log.
Exactly, yes. So in Unity, you have the project auditor, and at Crazy Games, we have an SDK optimizer, which kind of slots into that. And they will flag things before you've even built it. And they provide buttons to quick fix things. So the tooling is improving, and in Godot things are I can't really say too much because I'm working on some of it, but things are moving in that direction. So,
yeah, well, it's always nice to be able to commit back into the project.
Exactly.
So,
yes.
But we're also big fans of inspections and quick fixes. It's
yes,
it's a good way of working, I think.
Yeah, and I like nice pie charts, and so you can actually visualize what's where and what's taking things up. What's taking space up.
We don't do too well on the pie charts. It's got to be said. At least not in the IDEs. We've got some server side stuff.
Yeah. Yeah.
Have we had another couple of questions drop in there?
Yes, we actually do. One of the questions is, how do the download process is handled in Godot? So for individual packages, should it be done manually or?
Yes. So you basically, Godot will build a PCK file. You upload that to your server. There is some Godot code to basically download that manually. Let me see if I can go back a little further. So I've on the slides. There you go. So you manually download it with the HTTP request API. And then once you've done that, you have to write it to the file system. It's a whole process. Again, this is improving, but for now, this is the way you have to do it.
Well, nice. It gives you the flexibility to do that.
Yes. Yeah. Mm-hmm. So largely, you can just do everything in Godot, but there are a lot of things that are quite manual.
Mm-hmm. Yeah, I think we had a bit of a follow-on question in a way as well. So asking, how about vector graphics? How about vector graphics for textures where possible? Does that help reduce the asset size? And
it does, yes. I had a full Unity game without using addressables that was under 10 megabytes because basically all of the graphics were vector graphics. So okay. that is a really good way of doing it. Yeah. So if you have that ability, then yes, vector graphics are great for reducing your build sizes.
What about the disadvantages to that?
It can be more difficult to animate in Unity in particular. The vector graphic importer is not great. It's experimental still, and I don't think they've worked on it for a year or more. So it's you can there are some trade-offs there. I actually use an asset called Shapes by Freya Holmer. It's not true SVGs, but it's a vector graphic library. So there are no textures.
Mm-hmm. Yeah, I've seen that. There's some pretty impressive results you can get out of that library, actually.
Yes.
That's pretty cool.
Yeah.
Mm-hmm. Awesome. Alex, do you have any other questions?
I guess the last one from me personally. Back in my day, we had to focus on actually packing the order of the memory layout for loading the game to be able to sequentially load it from the CD or the hard disk. Can you actually specify the memory layout for loading packages for Unity and Godot resources?
That is a very good question. Not to my knowledge. In Godot, I would be surprised if there wasn't a way to do it, but I don't suspect it'll be an easy process. In Unity, beyond just using a bunch of addressable asset groups and kind of loading them in manually, you can then also free things in there. So I don't think so is the answer to your question, but yeah, it's a good question and something that I'd actually be interested in now you've mentioned it.
I mean, it not might be related anyway to our days because everything is SSD now.
Yeah.
I think we've had one last question pop in there as well. Someone's asking, what's your philosophy when it comes to lighting in WebGL or web builds?
Yeah, so lighting, generally you want hard shadows, not soft shadows. You want to bake it because you're really limited in performance on the browser. So you can do it. You have to really be very intentional about where you use it and how your dynamic lighting's working. Now we've got WebGPU. Again, that improves things because a lot of that can be done on the GPU side. So there are improvements there, but typically like hard shadows, stylized lighting is what's going to work best on web. I don't actually make that many 3D games, but so I'm mostly 2D. But that lighting can be tricky. It's quite intensive, but Web GPU goes some way to fixing it.
All right, cool. Right, I think we're all finished with the questions, unless you've got anything, Alex.
No, there was just the last one just popped up. So is there something similar to vector graphics, but for audio to help with the asset size? And I think it will be the last one because we are like a little out of time.
Not to my knowledge. Not to my knowledge. Yeah.
Yeah. There we go. Nice and easy.
Cool.
So no, we're still stuck with the usual audio files then.
Yeah.
Yeah. Okay, well, Dom, thank you very much for a great session there. Again, packed full of some fantastic hints and tips and useful information there. And thank you for your time. And I think we'll say goodbye for now.
Cool. Bye.
Thanks,
Thank you. Bye.
Cheers.
And now I think it's time for a bit of a break, which is rather nice, isn't it? We have a little less than 30 minutes. We've got about 25 minutes break. Everyone can go and grab a fresh cuppa or a wee sandwich or something, a bit of sustenance, and we'll be back in about 25 minutes. I'm hungry. You're not the only one. That's all I'm going to say. We'll see you back in about 25 minutes at 10 minutes past the hour, and we've got another great set of sessions for you still to come.
That's for sure. See you folks in a minute.
See you soon.
Okay, bye.
Hello, we're back, I think.
Yay!
Problems today, honestly, my headphones weren't working. Wi-Fi broke. Oh, jeez. At least I got the sandwich, so I'm happy about that.
I had to.
Well done. Welcome back, everyone. We've had a good start to our Game Dev Day this year. Some brilliant sessions there, lots of useful information, handy tips, and all that kind of stuff. I don't think we're gonna hang around too much, and I think we should just bring in our next speaker. What do you think, Alex?
Sure. Yeah, let's bring it on. And I also wanted to mention that I'll need to ask our producers about the music that was playing because this was a banger. Hey, Johannes.
Hey, Johannes.
Hey,
how you doing?
Good to see you. Thanks for having me today.
No, it's a pleasure. It's a pleasure, and I hope you enjoyed the music too.
I was gonna say yes, I loved it as well. Indeed, good choice.
Awesome. Right. Well, if you're ready to start, I think we'll just get your slides on the screen, and yeah, there we are. We can see them, and if you're happy, we'll leave you to it, I think.
Yeah, I'm as ready as I can be, I suppose.
Well,
all right. Good. Then thank you very much for the introduction. My name is Johannes Ebner. I am the founder and solution architect of Structure.me. That is my freelance business. I am talking about building a cross-platform in-game store with Godot and PlayFab today. However, most of that talk will be interesting to non-Godot users alike, right? So keep your eyes peeled and follow me along. So a little bit on my credentials. Apologies, need to switch to the proper slideshow. I work a day job as a senior production partner manager at Xbox. I used to work in Azure Gaming as well. I'm the co-founder of Godot Fest, or one of the co-founders, and I am, as I said, the founder of my own freelance business that does consulting around game development. My past experience is almost 20 years of game dev experience, where I have been mostly a programmer, but I've also been in sales and producing roles. I'm a C# developer by trade, but really embraced GDScript when I found out about Godot like 3 years ago. I've always been a huge Ride and JetBrains fan, and worked as a gaming solution architect in Azure Gaming, and that kind of was when I worked a lot with PlayFab and Azure. A few success stories and references, so you know my background, right? Why I'm qualified to talk about this. I have worked on Valheim, for example, on building the cross-platform multiplayer integration together with Pictive and Coffee Stain. I have done a GDC talk on that, not really on stage for GDC, but during GDC in the Microsoft Xbox game developers channels. And I am working on my own Godot PlayFab open source SDK. It's an integration for the Godot engine to use PlayFab. It's highly opinionated and manually written, but I'll be talking a little bit about this more. Dome Keeper is the biggest game I have that is using that. I've also recently worked in my consultancy on Warhammer 40k Speed Freaks with Caged Element, published by Playon, and worked primarily on multiplayer and architecture stuff. That was an Unreal Engine game though. I've helped co-host the GodotCon 23 here in Munich, where I live. Was mainly responsible for the location and also general orga. And I'm now doing on November 11th and 12th the Godot Fest together with my colleagues who have been doing GodotCon 23 with me. So check it out. Get a ticket if you want. All right, let's get started with the talk itself. So building a cross-platform in-game store with Godot and PlayFab. All right, first, I wanted to give a little bit of an introduction on why this is a good idea, right? And I'll start way back, right? Because game dev is challenging, as you know. We have a massive market, right? We are talking about, I think, 3 billion players is the total addressable market right now. So quite a lot of players to cater to. And at the same time, game development has become extremely accessible. when I started back in the day, like 20 years ago, it was very hard to get into game development. There was basically ID Tech and Unreal as big engines, and they each cost like 250,000 euros to get a license for, right? And then I think even revenue share on top of that. So this was not at all accessible. The best thing you could do at that time was the XNA framework. That was a C# library. It lives on now as Monogame and FNA. But that was basically the best or the most accessible thing that you could do. And since then, Unity has come across, Godot has done its fair share to it. And there are a multitude of other little engines that really help democratize and make game development accessible. And because of this, game development has also become extremely competitive, right? We on one side have this huge market of players, but there's also so many games that come out every day, right? And to be fair, most of them are concentrating on Steam. Now, in order to be successful, you really need to stand out, and to stand out in this sea of other games, right? You need to be unique. You need to have unique features, for example, and you also need to optimize your return on investment, because you've been working on this game a year, 2, 3, 4, 5, maybe, right? And specifically as an indie, these investments are proportionally high that you put into that game, right? So what you really want to do is expand your total addressable market for your game. And that means adding multiple platforms, potentially from the get-go. I'm a huge fan of that. And because many developers say, oh, I'm doing Steam first, and then if I'm successful, then I go and add another platform, right? And I personally think if you can afford to add another platform right away, you should totally do that, because that creates a lot more opportunity for you. And when you add multiple platforms, I also think cross-platform integrations or enabling cross-platform play is extremely important and valuable, right? You can see this when you look at Minecraft, for example. Minecraft is available on pretty much every platform, whether that's Xbox, that's Steam, no, not Steam, but their own launcher. It's available on Android. I think it's available on iOS. It's available on the Switch. It's, I think, also available now on PlayStation. I'm not sure, right? But so many platforms, and everywhere I can log in with my Microsoft or my Xbox account and play with the same things across those platforms. And on top of that, if you multiplayer a game, I mean, it's absolutely clear you need to have cross-platform play, because if you silo your players into one platform, then you will never have the critical mass to create a good community. So essentially, what you also want to do in order to increase your return of investment then is make your game, and I know many people don't like to hear this, but essentially create a game as a service, right? Where you continuously add value for your customers, for your players, engage them, support them, and do events, do community building around that, right? And with that, and that also costs money, of course, right? I think there's also a need to monetize after the initial sale, right? Whether you're a premium game at first, or a free-to-play game, I think there's always something that you should and need to be selling to your community, and that's not just to increase your return of investment, but also the player base usually asks for more content, right? And what easy is to add on to an existing game rather than creating a completely new game, right? So an in-game shop to the rescue, right? Because it allows you, next to DLC and whatnot, and even that you want to sell within the game if possible, because it is the shortest way to success, or to payment success, so to say, to monetization success, is in-game, right? You want to provide immediate value to your players, to your customers. You want to monetize players, so your return of investment actually makes sense and increases over time. And if you do it right, you can even have free players monetized via your paying customers. So adding value is the core part here. So in order to engage players longer and really bind them to your game, that needs engagement, and engagement needs value add. And one of the things that is not a value add is removing annoyances, right? So when I was starting my career in game development, I started in browser games. And in browser games back in the day, it was super common to create artificial blockers in a way, and then have payment options to remove them. For example, building a specific building would take like 10 hours or so, but if you pay, you could insta finish them. And that is obviously not something that is great, right? Because it creates rather an annoyance or a feel of pay to win. There's one thing I would consider that may help. Oh, I'm sorry, I need to break. I think my headphones turned off. Can you say something?
Hey, Johannes, everything seems fine from our side. Hello?
Okay. Yeah,
You're doing
my
great.
headphones turned off. Okay,
we can still hear you.
Okay, good. Where was I? Yeah, the only exception to that, I think, is removing ads in mobile games, right? Because that is a very common and accepted approach to monetizing mobile game, for example, right? And I wouldn't let my kids play an ad-riddled game, right? But I would try it with ads and then maybe buy the ad removal. So generally, you should aim to add value rather than remove annoyances. Always be positive about that. And that also means that you should never try to extract money from unhappy customers, because doing that just will make them unhappier. They will talk about it, others will follow, and eventually you're going to destroy your own games community with that. Another core pillar of adding value, so to say, is to avoid regret, right? So if you imagine like the loot crates that Counter-Strike has, if you're adding something like that, and you put in like a gun that you could also buy for 50 cents in your store individually, but the loot crate is like €2, but you have this chance of getting this super uber weapon, but you then redeem this crate, and there is the 50-cent weapon that you could have purchased, and so you have now overspent €1.50. That really creates massive regret, right? And that will make players really unhappy. Virtual currency can also be negative because it obfuscates pricing, but it can also be, or the real value, right? But it can also be positive because different value of currencies in different countries are then merged into the same value within your game's economy, right? And I'm saying this also because the virtual currency is kind of like an easy gateway to creating or help it to create a cross-platform store, and that's what we're going to do today. Also want to dive a little bit more into why cross-platform, right? Because players really want to play anywhere. And I'm personally one of those people. I play a lot on my PC, and I play a lot on my Xbox Ally. I play on mobile, and I play on console, and I play the same games there, right? And so I really like this ability. I also have a Switch, right, where I like to play my games, right? So I'm I'm a prime customer for that, right? And I want to also carry my purchases across these platforms. And so I want to also be able to purchase on every platform. And so this manageability is the or one of the things you need to watch out for here is to make this very, very manageable for you to maintain, right? Because one thing that you don't want to do is create like a big list of items that you can purchase on every single store, right? Because that creates massive work on your end to always maintain prices and so forth. So what we're going to do instead is sell a virtual currency or virtual currency packs on every one of these stores, which then can be redeemed in a central store where you can then maintain all the items and the actual economy that you want to maintain instead of copying it over on all of these platforms. But we'll get a little bit more in depth about that. But how does this work in a nutshell? So first, you have your game client here, and that game client, when someone clicks buy an item, it will go to the respective platform, right? And that respective platform then essentially opens or those backend services go back to your game and say, okay, open the overlay for this, open the store, and present the purchase option for the client, and then eventually the player completes the purchase here and sends this back to Steam, and Steam, for example, will then send a receipt ID back, and that receipt ID needs to be validated over a central store, right? And that central store in our example will be PlayFab. I'll talk about what PlayFab is exactly in a bit, but that will validate that transaction ID against Steam and says, oh, is this actually valid? And if Steam or Xbox says, yes, this is actually valid, it will then redeem the items within your central backend that PlayFab is, and then tells the game about it and says, hey, please refresh your inventory. As I said, we're going to be selling virtual currency only in the platform stores, which once it's purchased, we redeem this to virtual currency within PlayFab, and that currency can then be redeemed by the player to purchase items within your own economy. So let's dive a little bit deeper on what components you need. First, you will need the integration with platform stores. Here, as I said, I would only create a couple of virtual currency packs, right? So maybe add some value progress, so a small bundle then has like, I don't know, 24 coins, right? At, I don't know, €1. Then the next step is a bigger bundle with a little bit of discount and so forth, right? I mean, you can figure that out. There's a whole lot of content on the interwebs on how to structure pricing, and you should totally think about this yourself, right? Then you also need a central backend, and in our case, that will be PlayFab. And with that, you also need a way to execute code in the backend, because PlayFab is more of a store and an interactive backend. It does not directly include scripting, script hosting anymore, but it is now attached to Azure, where you can use Azure functions. So you need both of that. And this is where you would then redeem the items, the item packs that you've purchased on the platform, like Steam or Xbox or PlayStation, and convert those tokens into an actual in-game currency that you can then, as a player, use to purchase items. Now let's talk a little bit about PlayFab and what it is. PlayFab is a backend as a service, that is always there, right? So it has a 99.9% uptime, right? And nothing really can be up forever, as we have seen yesterday very impressively with the massive outage of AWS. And every major cloud provider and every major system has that, right? You can never make it fully foolproof, right? As we all know as developers. PlayFab is free until you're successful. That's what I always say. It's up to 100,000 users. Only the multiplayer systems are not included, but even there are free versions of that. It can do cross-platform accounts and linking, and it has strong analytics and data features. We'll be showing this in a minute, but one concept I really wanted to show, because it is very important in the context of this talk and building cross-platform stores, because you can have within the PlayFab web interface, you can have, or the structure of PlayFab, you can have multiple studios, and within the studio you can have multiple titles, and these titles can have the individual title accounts. So these are the player accounts, but these player accounts always have a master player account attached. And if you have multiple titles in the same studio, they can be linked to the same master player account. And that happens automatically if these sign in with the platform accounts that PlayFab has an integration with, right? And that is really cool, because I can just use my Steam login or my Xbox login or PlayStation login to log into PlayFab and have this all set up for me automatically, more or less, right? So there's not a huge ton of work to do to make this happen. But to better understand this, let's look at PlayFab individually. I'm going to switch my camera over so you can look me in the eye. All right. Okay. So let's go to the main page. So this is what happens when you log in. You have an overview of your studios. I have the various studios here, and this is the title I will be working off. The title ID is always very important, because you need to reference that. If you want to add a credit card, you can do this with billing summary here. Let's go in there, right? So you can already see that I have been using this a bit. So you can directly see which API calls are being used, right? How many users you have and so forth. So you have like an analytics dashboard already at the beginning here. There's a lot more analytics stuff down here, which I don't want to go in right now. You have players that you can see and maintain. So for example, my Steam player here. And you have like inventories, you have friends and whatnot, right? You have a transaction history, you can see monetization stats, you can even see real time what they are doing if something would be happening, right? You have some multiplayer features like multiplayer servers or peer-to-peer, automation features where you can hook up, cloud script functions, so essentially Azure functions. You have your economy here, and some data features and progression features like leaderboards. And content is kind of nice because you have title data where you can store, for example, balancing variables. Okay, this is just as a quick overview, so you've seen what we're going to talk about. Let's go back to the presentation. So, quick recap here. This is, as I said, it's really free to start, and only if you're successful, you can go into pay as you go or pay for extra support if you like to. Okay, now let's look at the process of how we implement a cross-platform store. So here's the overview. No, I'm just kidding. This is the full sequence diagram. You can look at this, but we're actually doing this a little bit simpler. So let's look at the purchase flow and how a little bit more in depth as what I described earlier by using Steam. I've integrated Steam as a first solution as an example, so it is easier for you to understand. And actually, as I said, most people are working with Steam in their day-to-day life first. So first, the player clicks purchase in Godot, whatever game client you're using. Then the client actually calls an Azure function, so the remote scripting backend, so to say. And like you call that function create Steam order, for example. And this function then calls the Steam web API with init transaction init txn. You should also save the order ID in the backend that you're creating, and then Steam returns order details, including a transaction ID, which you can then return to the client. But the Steam service has a real-time connection to the running Steam client, and the Steam overlay then opens for the payment to be done by the player. The player completes the payment, so authorize the payment in Steam, maybe tops up in the wallet, and then once this is complete, the Steam backend again sends a callback to the game client, and the game client needs to react to that, and again sends out a request to your scripting backend to finalize the Steam purchase, and this script then goes again to Steam and calls the finalize transaction method with the transaction ID or with the receipt ID to verify that the user has actually completed the transaction. And once this happens, the Azure function can grant items or currency, in our case, in PlayFab, and return back to the game client and force it to update the inventory. Now let's look more into the implementation with Steam. A quick disclaimer: I do show NDA content in the coming slides, and Steamworks very graciously approved the use of the screenshots for this talk. In fact, GIFs. And if there's a lawyer watching this, here's the ticket ID, so you can check this out. So first, and here I forgot to submit the screenshot to Valve, so you just get the icon here. First, you need to create a web API key. That is a shared secret that you can use in your backend, for example, in PlayFab, to authenticate against the Steamworks API. So that's something that you need for any transaction and finalized transaction, for example. But you also needed to enable the inventory service. And that's actually the next thing. So you go to your title in the Steam partner portal. Go down and edit Steamworks settings. Go to community and select inventory service. And here you can just enable the inventory service. And as you can see, you first need to publish those changes to essentially the retail environment. You can also first see all the pending changes and potentially revert them if that's not something you wanted to do. But now we're going to do prepare for publishing and also do publishing light, because we don't want to push the images, because that would take longer. And also provide a reason what you're doing here. So if someone on your team later sees this and wants to find out what you've done, that would be great. And really publish that. Okay, so that's that. And as a next step, now that you've published this, you need to add Steam item definitions, which you do on the same page, but this is how this looks. So you essentially have a JSON object with your app ID, and then also you have a list of items, an array of items. And each of them has an item definition ID that is always an integer. You can choose yourself. And then you can define it, what kind of item it, or what type it is, name, and so forth. Specify icons, and whether it's tradable, marketable, or whether it should be stacking. Now you can create this item definition JSON, add all the items you want, and when you're done, you need to upload this. And as I said, it's the same page as enabling the inventory service. Just need to scroll a little bit down to the very bottom and choose the file to upload. Yes, I have a typo in there. And once it's uploaded, you can see the uploads. I'm sorry, I didn't pause the GIF there, but you can see that I've now these 3 items added. Okay, and then last but not least, you need to set the Steam asset server key that allows then to connect external systems to that. And we just use the web API key that we have created earlier. Now the next step is to set up the Steam add-on or the economy in PlayFab. So what first, you also need to enable the Steam add-on or whatever other platform you're using, whether that's PlayStation, Xbox, Nintendo, Google. There's plenty of those, and here you just need to add your Steam application ID or whatever identified is for the other platforms, and then a web API key. You can also enable the sandbox endpoint here, and once that's done, you're good to go. You also need to enable economy v2. That in fact requires a credit card, but it's still free for 150,000 requests, so that's quite a lot. But how to enable that is a little bit hard because the economy, it's a very fresh feature, and there was a new UI glitch right now where the economy tab is empty, so you don't see it immediately. As I said in the earlier demo, you would need to go to the studios, click here, and add billing summary. This is where you can add it then. Okay, now let's look live at the economy setup. Where are we here? Okay, let's go to the economy. So as you can see, first on the top, there was a legacy part of that. We're not using that, and I would encourage you to not use it, but use the economy v2. And so you can define items, currencies, UGC stuff, bundles. You can create actually multiple stores, and you can also create subscriptions. So what we're going to do first is we create a currency. I've obviously pre-created that, so nothing happens here. So we just go in here, and you can, what I'm doing here is enter draft item, but it would be the same experience when you create a new item. Demo mode, great. I'm just imagining you laughing. I hope that's true. Let's try this again. Yeah, here we go. Okay, so you can see there's already quite a bit of stuff that you can add, right? So let's get through this a little bit. So the item ID is automatically assigned GUID by PlayFab. Then you could select what the entity type is. That is usually either title, which means it's game level and can only be edited by admins, basically. Or it could be a player, where you could allow players to create their own items if you want in one of the stores that you've defined. But we're doing this on a title level. The creator entity ID is in that case the title ID. Otherwise, it would be the player and the master player ID or the title player ID. You can give it a friendly ID like currency _ Godot or whatever. Then you can give it a title, and as you can see, this is JSON. So this means that you can already add localized titles in here, which is kind of neat if you want to do this. You can do the same with description. or you actually have to do. So there's always a neutral one if you don't, so that needs to be set. You can also do a lot of other customizations with creating your custom content types. You can add display properties as JSON. You can add versions and tagging and so forth, right? You can also make it hidden. You can also make them available only between certain timeframes. So that is very, very cool if you do some promotions. You can even add files to them, right? Like actual supplements or higher definition textures, or I don't know what, or sounds. And then images. We're talking about platform and prices when we actually do the bundles. So I'm just editing this again so I can show you one more thing, because you can save items or currencies or whatever in a draft state and also in a published state. And you can so prepare stuff in a draft mode and later publish them. Yeah, so this is really demo mode. Oh, by the way, some of the pieces of PlayFab, I think, are hosted on AWS, so that's maybe why. All right, now we have the currency. We create bundles for it. And the bundles are actually what we're going to sell on Steam or on the other platforms. So let's set this up as well. Here, so I've set up the GoBug 25 thing. So that's a 25 pieces bundle. Oh yeah, I love this. The demo gods are not with me. Yeah, great. I did say nothing is up forever. Well, cool. Let's try this on another tab with currencies. Maybe I can at least show you something. Yeah, because it's got this cached. So, come on. Well, so we essentially do the same thing for the bundles, right? But the bundles also include this currency. So the bundle would have 25, an amount of 25 of this currency. And we would also have a platform integration where we say Steam, and then we enter the Steam ID and its price on Steam to make it able to reference that, right? Because when you initiate the purchase with a platform, you not only need to provide their ID, but also their price as a kind of like a verification that you're doing the right thing. Okay, I'll try it one more time and then I'll skip it. Yeah, that's not looking good. Okay, let's go back. So let's carry on. I hope the other live demo then works. Anyways, so you might have been wondering where Godot is, right? So here's a quick intro in what I did. So for this talk specific, over the last couple of years, I wanted to build my own game, as so many Godot developers do this. It was just a hobby project. I also wanted to add some things with PlayFab, right? And then I became a tool developer because I really enjoyed building tools, and I decided to make a proper Godot PlayFab integration. And here I am today talking to you about the integration of PlayFab and PlayFab economy to build a cross-platform store. So Godot PlayFab is, in contrast to the official SDKs, is a handcrafted, very opinionated version of the SDK. And I don't have the full feature set covered. I mean, I have methods for you to use the full REST API of PlayFab, but I have created opinionated implementations of all these pieces. So for example, the authentication, you can use username and password registration, you can use anonymous logins, you can use platform logins. Steam is the only one that is currently implemented, but I'm working on the others soon. I have events integrated, telemetry just for pure data collection for analytics, but also PlayStream, which allows you to almost real-time react to stuff players do. I've integrated title data, which is essentially balancing. You can do title news and whatever. I've done the Steam integration with Godot Steam by Grams. And now for this talk, I have added Economy V2 support. And so let's look into how that actually works. So I've, by the way, built this with using Rider, which is absolutely great because they have been adding Godot 4.1 GDScript 4.5 support, and that is really great because it helps you a lot with typing here. So I've already started the Godot editor, but I don't need it. I just need it as a runtime. The cool thing about Godot PlayFab that I have is not only the SDK integration, but also I provide ready-to-use reference implementation. So you can just that are very simple. So you can essentially either use that as a starter or just copy and paste some of the code into your project, right? And understand how it works. Now let's use the Steam login right away. So you can see, I mean, it looks boring, but it is here to show you the functionality and not clutter everything with, additional stuff. So this is what you get upon login. All this data, that's already pretty useful. But you can also get, title data, balancing for your game or whatever. You can get do data writing, like telemetry events that is just purely for data, or you can also use PlayStream, so you can act in almost real time to what players are doing, right? So if I send a PlayStream event, you will see this coming up here, which is pretty neat because you can inspect that right away, and there's also quite some data sent with that. So that's really neat. And going back, you can also then I've implemented now the economy features where you can display the catalog, so all the defined items and currencies, and also have your inventory here. So I have 5 Godot Fest charts. I don't have a currency, so let's go and give me some currency so I can actually buy something. Do I have the player open here? So, all right. So here we have the inventory for the player. You can see I have that. So now I want to add some currency. Add a currency. And I want to add, let's say 100 of those Godots, add them. So I can go back, refresh my inventory, and now I have my currency here. So I only have a shirt. I also want to have a hat. So I go to the catalog and let's buy a Godot Fast hat for 15 Godots. Let's go. And I've purchased that, and now if I look in my inventory, I obviously have the hat. Oh, it was already refreshed, and the currency has been deducted. And of course, we want to do this also with Steam. I have a very limited demo here for that. So I have the Godot Bug 25 thing. I do the purchase with Steam. I will click on this, and then I need to move the client on the side because otherwise Steam will spoil my home address to everyone. So bear with me. Also, I have a little bug right now. So this is not fully production ready just yet, but it will be in the coming weeks where I have like a little bit of delay. I don't know where this is coming from. So bear with me for a second. So you can see a little bit of that aside. In the meantime, we can maybe look at the code a little bit. It just, as I said, initiating this in the client. So once we've started that, purchase button started. So we send the purchase item request here with the item ID, how much, and the price. And then go and send the request data to the Steam backend or to our Azure function, which actually runs over here. Let's start from the top. That is C# code here, where we just like parse the request, pack it in the request object that Steam is doing. That is still a proof of concept. So we want to do client validation here as well, and then send the Steam transaction in it to Steam, and then parse that and send it back to the client. And once this is received by the client, then we can go ahead and send this back. I'm sorry, and send this back to the client, and that will initiate because Steam will send the signal back. Will initiate the purchase flow. Can I please? I cannot move. This is stupid. I cannot move. What's going on? You'd be kidding me. Here we go. So now I have this this item pop up. I paid a $25. I authorize the payment, and when we do this, you will see here the output. Where's the output window? Oh, come on. Authorize this. And again, I have this weird delay in there. I can't figure out, or couldn't figure out. I got a few curveballs thrown at me with this integration, but it eventually worked out. There's a particular problem with the Steam overlay that I could not figure out for the life of me. Just before the talk, today I figured it out. And so here we go. This is the purchase has been completed. I've just received an email, and we're good to go. I need to go back to the presentation because we're running out of time, and I also wanted to talk a little bit about security. So security, when purchasing stuff or when selling stuff, extremely important, right? Because you can lose a lot of money, obviously, and you can maybe even get a bad reputation out of that. So first, the most important thing is zero trust, right? So never trust the user, or particularly not the game client, because the game client can be manipulated and can even be manipulated potentially without the knowledge of the user. So always verify that. And that's also why this payment process that you've seen and that I've described is a little bit involved, right? And it takes all the control away from the client, essentially, right? Just this user interaction in the Steam client that is really controlled by Valve, and that is the same on console, right? Or on the Xbox app on PC or whatever. that is a controlled real estate of the platform provider, and they make a lot of effort to secure that. And that's also why you just get back this transaction ID that you send then again to your game's backend to validate against the platform. The other thing is fraud prevention. And the fraud prevention starts very early on. That even starts before the purchase. So fraud not only hurts you financially, but can also destroy the game's economy. And so this is why it's so important to start as early as possible with that, right? Always keep that in mind. And as I said, it starts even before initiating the purchase, because a new user, a new player to your game is not gonna buy something for 200 euros, full stop. They're not, and they shouldn't, right? If they're in for 10 minutes, there should be no reason for them to spend another big lump sum, right? Maybe you can allow them to spend 1 or 2 euros, right? So the damage, if that gets a chargeback, is not high. So always use the knowledge of your players to not allow unrealistic actions, right? Do not allow them to buy stuff for excess value, right? That is nonsensical in the scope of your game. And also, and that is a two-edged sword, do not allow transfers to other accounts, at least not, virtual currency. That is a big no-no in my opinion. Trade, on the other hand, can be a really good positive thing for you to do in your economy and to do player satisfactory stuff. Specifically when you monetize, when you want to monetize free players over the paying players, right? So that would be the basic suggestions here. Then also every platform has a clawback service, to my knowledge, and that clawback service is something that kicks in when there is a chargeback, for example. So as you know, every payment provider provides usually the ability to cancel or revoke a payment. That recently happened to me in that fraud scenario, and to AWS, right? I got two Visa charges for $1,000 each, and that was for AWS. So somebody obviously used my credit card to pay the AWS bill. I don't have AWS estate, right? So I immediately called Visa and said, these are fraudulent charges, please revoke. Here's also the police report. Then I have filed this, and they did a chargeback immediately. So now AWS is the one who is out of $2,000, right? Because they have allowed this payment to be accepted, essentially, and they have settled the bill. But now they need to claw back that what they have provided in value to that user. So they are probably going to claw back the credits they have been giving to this user. And the same is true for when you do a clawback, so or a rollback happens. So Steam or whatever platform tells you, hey, there is a chargeback. We try to claw back that. So they will probably do this automatic already if it is still the first party. So if they have purchased the currency and have not transferred it, then they will just remove it from the inventory of the player. If that's if they have already transferred it, then they will notify you as a backend, essentially, right? And your backend needs to figure out how to resolve that. And that can be very complicated. Particularly if you have a cross-platform store where you can only buy currency on the platform. All right, I think that's it. A few resources here on microtransactions, on Steamworks, a link to Azure PlayFab, and then, of course, a link to Godot PlayFab as well. I'm not sure if JetBrains is making this available later on, but I'm sure we can make it happen. All right. Otherwise, you can reach out to me over my email, or I'm structured everywhere except on LinkedIn, where I go by my real name. All right. Thank you so much. I'm pretty much on time, I think, with 59 minutes. Okay.
Yep, works for me. That's good. It's the usual thing, isn't it? You've got your nickname everywhere apart from LinkedIn, where you have to be sensible and grown up.
Yes.
Yeah.
But I've also created my personal brand about that structured thing, so I better use that.
Well, exactly. This is back in the day when the internet was all about nicknames and things. Anyway,
Yeah.
and I'm digressing. Firstly, yes, we are going to be making the videos available. So obviously this stream is going to stay up and people can link directly to the section, but we'll also be splitting the videos down and making them available separately, so we can make this video available. And we will be sharing those links with everybody who has registered, so we'll email to let you all know.
Awesome.
So yeah, firstly, thank you very much for a great talk there. It looks like a fantastic service to use for helping you with inventory and currency and everything like that. Unfortunately, we're all being hit by the demo gods today, I think, isn't it? I think we're all feeling the after effects of the AWS quake that's happened.
It happened. It worked earlier today, so I'm particularly bummed.
You don't need to tell me these things. I'm having a lot of fun back here trying to make sure everything I'm doing is working well. The other thing to say as well is that chat like your shirt. So that's clearly, yeah.
That is the Godot Con 23 shirt. So maybe we have some in stock left. I don't know.
I see. Well, if you need a shirt, then hit Johannes up. This is a good one. Where are we? So, Alex, do you have any questions you want to fire off?
Sure. I think it was from the audience. Like, why would you create like multiple stores? Economy v2 tab allows for creating multiple.
Yeah. So that is particularly useful if you have a store-heavy game. Like, look at Diablo, right? So Diablo has many sellers in the game, because those stores you can not only use for real money, but you can obviously use them also for in-game content. So if you have Deckard Cain sell stuff to you, and then there is other vendors there, you can actually separate them out, and that is really cool to manage the content there.
Do you have to do anything different sort of on the client side to make that happen, or is it sort of automatic? Do you have to know to be calling the right store?
Yes. So basically what you can do is you can fetch the inventory and say either give me all of it, and then all items have like a store name in them in a result, or you can also search by store, right? So I only want to have Deckard Cain, basically, right? You could say that.
Okay. And if you're like if you're doing some kind of game where you go to different actual stores in the game, would you treat that as a different store in the back end as well, or would you handle that differently?
Yeah, I would handle it. I would give it a real money store and then like an in-game store, right? So in the real money store, I would just handle those currency packs that I'm actually selling on the platform stores, and then have the separate in-game store where I can then only pay with the virtual currency that I've redeemed.
Oh, Alex looked like he was about to follow up on that one.
No, I was just like trying to wrap my head around. Like, this is the hot topic. Like, every game almost, especially RPGs, has the like multiple stores, and especially the more mobile wild world you go, the more currencies the stores you have. Like, sometimes you would have like 8 stores in a single tab, one for like because you have multiple currencies, and each currencies are like can be transferred, and they paying for different stuff. They convert differently for the real money. So yeah, this is like
the Gathering Arena is a prime example of that. You have a couple of stores there.
The mobile world is notorious for these like dark marketing tendencies with multiple how to say currencies that actually made to like puzzle you.
Yeah, I actually wanted to reference. I did this in my rehearsals. the Dungeon Keeper mobile game. I'm not sure if everyone here is old enough to know that game, but it was, back in the day, it was an absolute fiasco because they drove it so hard with the these annoying features that you needed to remove with payment, and it was absolutely atrocious, specifically for the fans of the Dungeon Keeper games back in the day, right? Now getting this mobile game that is nothing like it, right? And just riddled with in-game purchases, so you can actually play it, right? I mean, you needed to pay so much money in-game that you would actually be able to play something.
Right. I mean, in my world, the mobile version has never been released.
Like the additional Matrix films. I hear that.
This could go off on a completely different thing now.
Yeah,
we could have spent the rest of the afternoon discussing
Don't dive
all
into
the
that.
movies that haven't been released. Yeah. So I was going to ask a question then about the fraud prevention. You were mentioning that you wouldn't allow people to transfer balances. I wonder if you could dive into sort of why you give that advice.
Yeah, because it's very quick to move that and kind of like hide that, because so this is a way to escape those clawback mechanisms usually, because you buy this virtual currency and then immediately redeem that and transfer it to another account, and potentially multiple ones. So that is an extremely common attack vector on these purchases. So I would not allow transfer of virtual currencies because of that. So you need to buy something with it in order to be able to then trade that item, right? Which makes it a little bit harder for these for fraudsters, and even makes it harder for services that help you gain in-game money or whatever, right? Because that's another thing you actually don't want to have, right? The WoW gold farmers or whatever, right? I mean, Blizzard has been at war with them for, I don't know, 20 years now. So yeah, that's one way of doing that. But the solutions are always very, very bespoke to your game, I would say, right? I mean, one solution never fits them all.
Yeah, that's interesting. There's a whole bunch of stuff that you don't necessarily think about, or that you need to think about to sort of see how people are gaming this kind of thing.
Yeah. On the value of trading and general value, I think there's a great talk by Valve from way in the back in the day that is linked on this microtransactions page that I find very interesting on this whole thing of value, providing value to your players. You should give that a try.
Mm-hmm. Mm-hmm. We've got a question from chat which is asking how one would implement limited time or discounted bundles.
Yeah, so this is as I showed, when you create items, then you can create essentially set a start and an end time, right? And within that you could set various prices, for example. So what I've also done is you can create staggered prices. In my demo, you might have seen one of the items that had 2 buy buttons below that. So for the amount of you buy one, I might actually be able to show that. Do I still show? Can you show my screen to the audience?
Yep, you're back on the screen.
Okay. So when we're here in the catalog, I have this setup, for example. So you can buy one piece for 20 Godots or 2 pieces for 30 Godots. And that is a very easy setup here when you look in the economy.
I like that it's called an economy, by the way. That's just kind of nicely wraps everything up.
Yeah. Wow. No items. That's great. Now I can blame everything on AWS. That's cool.
Oh, we did notice that everything stopped working when you reported your card as being scammed.
Yeah.
It's like somebody's still trying to pay for AWS with your card, and it's no longer working.
Well, I'd love to show you, but I've defined for this item. I've defined 2 prices. So one is the default one amount price, and then you can have like a discount price if you buy multiple of one. Yeah, that's that.
Yeah. Another question then, I guess. Are there any best practices on handling different real currencies?
Yeah. So as you know, there is always a lot of price fluctuation in the world, right? First, we have countries with wildly different values of their countries, right? And so you pay more in the European Union than you would pay in Vietnam or somewhere in Africa, right? Or in Brazil. So you need to alleviate that. And usually, these first-party platforms, they do this value conversion for you as well. So what you often do is you just create a US dollar equivalent, and that will then be converted into that local currency, right? And also they fluctuate a lot because of inflation. So for example, Argentina has an extremely high inflation, same Turkey, right? So these need to be actually adapted multiple times a day. So it's often clever to use the platform's conversion mechanisms to do that. So that's why I would recommend, for example, to specify US dollar values within PlayFab. And then, as you might have seen in the demo, I specified 25 US dollar cents. And when the purchase dialog actually comes up in the game client, it converts this back into euros, right? So my local currency, and so I can then buy that. But with every store, if you want to adapt to the local pricing, you can also do local currency equivalents directly.
Right.
But I would always recommend the US dollar equivalent so you can have the same value everywhere.
Mm-hmm. Okay. Next question, I think, would be what's the biggest technical challenge in setting up a cross-platform store?
Yeah, integrating those first parties, right, and actually getting the abstraction right. And that is, in fact, I have to say, a big problem in Godot, because we don't have preprocessor statements there just yet in GD script. If someone's listening and wants to contribute, please do that. So it's
preprocessor
really
things are horrible. Don't add them. Never add preprocessor things into a language.
Or another way of removing cross-platform stuff, right?
Thank you.
Because that is, it is hard to currently to remove the platform dependent SDKs, right, without completely forking the project. So this is a problem, and then the abstraction of those platforms, right? Because while the general principle is always the same, they all work a little different, right, and need a little different workflows and a little bit of different data. So that's challenging. And in this particular case, I think with Godot and Godot Steam was actually the Steam UI actually showing up. That was the biggest curveball. It only works if you export the game, or within the editor you need to set it to the compatibility layer renderer to make it work in the debug window. It's weird. Something to do with drivers. I don't know. And how Steam injects it.
Yeah, no idea. And that's where you do hit those sort of technical blocks, isn't it? Where it's just like, okay.
And you spend you spend the majority of the time on this like little crappy things, right? That are actually not really something you wanted to do.
Yeah. The smallest features always take up the biggest amount of time. Do you find it useful that Godot itself is open source? You mentioned suggest. Sorry, I missed that. I talked over you.
No, it is absolutely fantastic. I think it gives a lot more flexibility to people, right? I also like the extension system that helps you hook into that, and it also explodes in the ecosystem in a way that so many things, because the base engine is MIT open source, so many add-ons are MIT open source, and that influences the whole community in general, right? So it is very cool to find stuff that you can actually work with, that you can help maintain, right, and actually adapt when it's not working. Because I've been working a lot with Unity in my professional career, and what I've seen often is like, there's this great plugin, but it's outdated, but I really need that one, right? And there's no other alternative, and I'd be happy to fix it, but it wasn't open source, so I couldn't find the maintainer, and you lost there.
Yeah.
Right.
Yeah. The Godot PlayFab stuff is open source, isn't it?
Yeah, it is. Yeah. So it is. That was influenced by the same thought, right? And right now, I'm actually looking for people to help me expand that ecosystem, because I want to really reach all the other platforms. I work for Xbox, so this is probably next, or Google, because mobile developers have asked for it. But I would very much appreciate if somebody's interested to helping out introducing new platforms.
We shall have to share the link in the chat then, and see if anybody would like to join in. This is good. Just before we wrap up, one last quick question from chat there is how about subscriptions? So items that only have one instance can be had at once, and after a while they run out.
So technically that's supported in Godot in PlayFab. So you can use this in Godot PlayFab as well. I have not played with it, to be very honest, but yeah, I think that's exactly that.
Okay, well, it's nice to know it's supported. I think, unless Alex has got anything else, we could wrap it up there.
No, it's good for me.
Oh, that's cool. Great. Well, Johannes, thank you again for a great talk. Lots of useful things there. Send us the link and we'll put it in the chat, and hopefully somebody will help to join in. And
I will. All right.
And help
Thank you
out
so much. Thank you so much for having me. It's been an absolute pleasure.
And we shall see you at Godot Fest.
We will. Good to see you there.
Bye-bye now.
Bye.
Bye.
So, Alex, on with the show?
Oh, yes, of course. Always.
Right, well, let's get always. Let's get our next speaker on then. I think we've talked over a little bit of his time there. Sorry, Ilya.
Yeah.
Hello, good to see you.
Hi, everybody. Nice to see you.
Yeah, thank you for joining us. If you're ready, we'll share your screens and get straight on with it. There we go. We can see your slides, and we will leave you to it. Thank you, Ilya.
Yeah. Okay. Let's start. This time the theme will be very different. It will be very, very technical, and it will be about one very certain area of development, of the game development. We will talk about CI/CD processes, continuous integration and continuous delivery process. And we talk about how AI infrastructure, how new technologies based on AI progress can help us to improve CI/CD for mobile game development. So let's start. But let's talk a little bit about Playrix, because my experience and what I will describe later is based on what we have done in Playrix in developing, in changing how development has been done and how CI/CD process has been organized in Playrix. Playrix is one of the leading mobile game developers in the Europe and maybe also in the world. We have a very large number of developers which develop our games, and our active DAO can be active MAU is up to 100 millions. So yes, we have rather popular games, and we have a lot of developers who help us to make these games one of the best at the market. So what about inside of the Playrix, what happens inside, what happens in development. So we have more than 10 different games, different projects, and we have more than 500 developers who works on these games. All of the games, almost all of the games are using our own C++ based game engine. Both game engine itself and game logic using mostly C++, and it is up to 2 million lines of code for each of the game. So it's quite a large project. And we built the game for different target platforms, of course, including all mobile platforms like iOS or Android, but also for Windows and macOS. Not only for developers' purposes, because our developers develop the game and test them on these platforms, these top platforms, but also we have gamers, we have end users who use these desktop platforms to play our games. And we release a new version of our games, usually once per 6 weeks, but we sometimes have mid-releases, in between releases, once per 3 weeks. So this is a little bit about Playrix and about what we are working on and why do we need some improvement in our CI/CD processes and why do we need the help of AI to get all of this working better. Okay, but let's start from CI/CD with the general terms. So let's discuss about what do we want from CI/CD, what is a good CI/CD, and how it can be improved, and what are the areas of improvement that and where AI can help us. So if we talk about CI/CD, why do we need it? What do we need from CI/CD? From one side, we have the developers who create the new features. We have technical designers, we have artists, we have narrative designers, we have a lot of people who make some changes, who create some new interesting features in the game. And we would like to build this and make all these features possible to play with to our end users. And our end users mostly uses their mobile phones. So we need to get these changes and move through whole pipeline to deliver it to the mobile devices of our end users, of our gamers. And what also do we need during this pipeline? We would like to ensure the quality. We would like our game to be the fast and smooth as possible. And we would like to check and eliminate all of the bugs during this pipeline to be sure that our end users receives the best experience as possible. And also we would like to automate these processes as much as possible, because if you try to do these things manually, it will require much more time and much more resources to fulfill. Okay, this is what about the CI/CD overall, what is it and why do we need this CI/CD process at all? Let's dive in mobile applications and game CI/CD. It has some differences and it has some additional problems, and maybe it's a little bit more complex, a little bit more harder than other types of CI/CD. First of all, there is a very high cost of any issues that appears in production. Why? First of all, because we cannot just deploy our game to production and make it available to our users. In most of the cases, we need to go through review by store, like App Store if we deploy to iOS or Google Play Store if we deploy it to Android. And it can take from several hours or 1 day, or in worst cases, up to 1 week to go through this review. And even when we pass this review, if everything goes wrong, we cannot just roll back to the previous version. What we can is just to apply new version and wait again for the review. And only when we pass this review, we can deploy and distribute the new version with the bug fix. So this makes the cost of any errors much, much higher than in any other types of deployment like front-end services or back-end services. Of course, there are some additional ways about how to make it a little bit easier, like live ops, like feature flags, etc. But there are a lot of cases where you cannot use it and you require to upload the new build. So we need to be sure that everything is as smooth and as good as possible on this way. The second problem with mobile CI/CD is that we have a lot of different platforms and a lot of different configuration that we need to check and that we need to build for. For example, if we talk about Android, it's not just one store, it's a lot of different stores. Google Play, Huawei App Gallery, Samsung Galaxy Store, Amazon, etc., etc., etc. So we have a lot of different configurations to check and to build with, and it makes everything much more complex and requires much more additional resources. The third problem is the speed of building. In our case, because of the size of our project and because of the C++ as a language, if we use a clean build without any additional instruments, any additional tooling to make it faster, it can take up to several hours to build the app. Of course, we have a lot of additional tools to make it faster. We use batching compilation, we use distribution building, we use distributed caches. But even when we use as much additional tools as possible, we can decrease this time in average up down to half an hour. But usually it takes a lot of time. So we need to take it into account. Also, the problem is with the testing itself, because to test that everything is working correctly, you need the test that should be run on real devices, because there are a lot of cases that requires a real device possibilities to perform the test. And of course, testing on real devices, in some of the cases, we can replace these devices with simulators or emulators. But in any case, we have a lot, it's not as fast as testing, as unit testing or as integration testing. Even if you use simulators and emulators, it takes a lot of time. And if you require real device testing, it requires much more time. So I hope that you understand now, even if you have not experience with working on development of mobile games, that CI/CD in mobile games development is hard. So we need any help with any additional instruments as possible to make it easier and to make it faster. So how do we define that our CD is working well or needs some additional improvements? First of all, is the quality of the end product. We would like the end product, in our case, a mobile game, to be the best quality as possible, without any functional problems, without any performance issues, without any freezes. So we need to to check as much as possible during this pipeline. The second metrics will be the speed of pipeline. We will talk about this a little bit later, but usually we require a lot of additional loops during the development. So it's not just changing something and deploying it to our end users. It requires additional loops. Okay, that's almost okay, but we need some small changes and one more changes and one more changes. So the speed is very crucial to make as much loops as possible in a shorter period of time. And the third metric will be the cost because of number of builds, because of the time. We need a lot of build hours, we need a lot of resources, and it can cost a lot of money. And in our case, CI/CD is have quite a lot of cost, and we spend a lot of time in FinOps to improve it and to make it cost lesser. Okay, so this how can we define how can we decide whether our CI/CD is good enough or do we need some additional improvements? And let's talk about additional problems. Why it's not perfect? Why do we have the problems with the quality, problems with the speed, and problems with the cost? And one of the main problem is humans. Because in these CI/CD pipelines, we need human in the loop. We have a lot of points that requires direct attention of developers or some other engineers. And why human is a problem? Why human in the loop is a problem? Human in the loop gives us the problems in all of these metrics, can decrease all of these metrics. In terms of quality, errare humanum est, developers can make mistakes. Any human can make mistakes. So if human make some decisions during the CI/CD process, it can make sometimes wrong decision. In terms of speed, usually engineers are the slowest part of the system. And also the problem is with asynchronous async type of interacting with humans. So we can ask engineer to make some changes, but we cannot be sure that it will implement it right now or implement it in next hour, because he can have some other issues. He can be absent from the work. So there can be a lot of reasons why he will not do it right now or in the closest time frame. And also the cost. Human is rather not the cheapest part of our system. Engineers' times cost money. He can spend it on creating some new features that will bring us new users and additional revenue, or he can spend it on fixing some problems in CI/CD, which is required, but maybe will not get us additional users and additional revenue. So what can we do with the human in the loop? Of course, the best way will be to remove the engineers, remove the human from this pipeline at all, and to automate it as much as possible. Some companies in some areas almost, maybe mostly achieve this, but there are a lot of cases where it can be achieved. So when we cannot achieve it, so when we cannot replace the engineers as a whole, we can, what can we do? We can amplify the engineers. We can, by increasing their productivity, we can make the overall pipeline work better and work faster and cost us less money. So we try to do the both. We try to replace engineers in places where we do not need them, where we can work without them, and where we cannot do without them, cannot work without them. We try to increase their productivity. So let's talk a little bit again about the productivity, because if you want to increase the developer productivity, we need to understand how can we affect it. What are the areas that we should focus on if we're talking about increasing the developer productivity? One of the scheme about how to work with the developer productivity, the most favorite, my favorite one, is the feedback loops, cognitive load, and flow state. Feedback loops is these loops where developers receive some additional feedback, which requires him for do some additional changes. For example, builds failed at the pull request, some tests failed at the pull request, and he need to make the fixes to pass this test. This is a feedback loop. He received some bug report from the QA. This is a feedback loop. The producer asks to improve some animation. This is the feedback loops. So all of this, everything, almost everything that developers works with after it creates the change itself is the additional feedback loops about what should be changed later. The cognitive load, this is about how much efforts requires from developer to implement these changes that required from him. And the flow state is about are the developers in the state of the optimal performance or not? Why he not always in the state of optimal performance? We will talk. We will discuss in the next slides. Maybe it has been a little bit complex framework from the first point of view. So let's try to use a simpler analogy to understand what all of these areas are about. So let's, for example, imagine the situation that we need to get a lot of different packages from point A to point B by some van or some truck. So feedback loops is our roads. We can have straight roads from A to B, or we have a lot of complex roads with a lot of detours. Of course, the straight and simpler roads are better. And also, if we cannot get all the packages in one drive from A to B, we needed to have a lot of additional drives. And of course, the lesser number of these drives is better than the more number of the greater number of these additional drives to getting additional packages. The cognitive load is like a quality of the road. If the quality of the road is good, we can drive at the more faster speed. If it's bad, we cannot get the best speed, and we need to move slowly. And of course, it will get us more time to get the packages from A to B. And the flow state is about some additional problems during this driving. If there are a lot of traffic lights, if there are a lot of traffic jams, of course, it will take a lot of additional time. It will also decrease the overall performance, the overall productivity of our delivery. So I hope that this simpler analogy will help you to understand better these areas of developer productivity. So let's try to use this framework for human in the loop in our CI/CD. How this framework is work with CI/CD processes. Is implemented in CI/CD processes. Feedback loop is, as we have described previously, is our additional checks that can be passed or failed. And if this check has been failed, it requires developer to make additional changes during this to get passed through this check. So one of the most so in different companies, the number of these checks can differ a little bit, but I think most of the companies has the checks like code review. So you need to get through code review by some other developers to get into the main branches. The additional checks on the pull request level before merging your changes to the main branches. In some companies, there are additional requirements for some regular builds, for example, nightly builds, etc., etc., etc. So this is feedback loops in our CI/CD pipeline. What about cognitive load in CI/CD? When some check fails, the developer, the engineer, requires to understand why has it failed and what he needs to do to fix it. So if if it's complex, if he needs additional time to understand what happens and why the error appears, why the test has been failed, it will be harder for them. So the cognitive load is about to understand why the check has not been passed and what he needs to be able to pass it. This is the cognitive load in CI/CD. And what about flow state? Why the developer is not always at the optimal performance state? According to different researchers, people, engineers, any type of professions that requires creativity cannot just switch from one task to another. Switching from task to task breaks their productivity and requires additional time to return to the optimal productivity. And even if you do not switch the whole task, but have some interruptions during this task, it's also the same process. If you have been interrupted during your work, you need additional time to get to this optimal state. And research shows that in most of the cases, it requires up to from 15 minutes up to 30 minutes to return to the optimal state. And our CI/CD, if it requires human attention, engineer's attention, it creates such an interruption. Developer works on something new, working on the next tasks, but the checks during the CI/CD creates the interruption, says, wow, you cannot go further. You need to return to your previous task because the test has been failed, because the reviewer asks for some additional changes. It is an interruption. Engineer requires to switch his attention. It breaks his flow state, and it requires additional time to get into the state of optimal performance. So how can we improve the whole process, and where are the areas where AI can help us with? So we described the areas that can be affected. That can be on what areas should we work to improve the developer productivities. So AI can help us to speed up feedback loops, to make them faster and shorter. AI can help us to decrease cognitive load. And if it will be able to minimize the number of interruptions, the whole process will work better and the developer productivity will also be better. For the scope of this presentation, I will minimize the number of feedback loops which we will talk about, because we will not be able to talk about every of them, but let's focus on so-called maybe classic CI/CD. Let's talk about code review, about checks on the pull request level, and about regular checks like nightly builds. So first of all, let's talk about how AI can help us with the code review. There are a lot of solutions at the market. It's one of the hottest theme right now in working with AI to improve the developer productivities. So maybe we are at the state where we can fully remove the human from the code review and replace it with AI. Let's discuss it. From my point of view, we are close enough to this point, but currently we are not at this point. Maybe at some companies and at some projects, it can be already achieved. But if we talk about the game development, about the mobile game development, about large game projects, from my point of view, it is not achievable right now. And let's discuss why. So if we talk about issues of medium complexity or easy complexity, yes, current LLMs can easily detect them and suggest the right way about how to fix it. And we have seen it on our pull requests and in our projects. If we talk about harder problems and more complex problems, this is not ready yet in our experience. For example, we have some cases where AI suggested using different C++ containers that we have used right now and said that it's high priority. You should replace this container because you're using the wrong container. But the problem is that, yes, in the general situation, what AI has been suggested is the best approach. But in our case, because of how we will use this container in runtime, how we will read it, how we will write it, how we will replace elements in it, the advice of AI will be very, very bad decision and will decrease the performance. Why AI suggested it? Because it has an additional context about how we will use it later in runtime. But engineers, the experienced engineers, the engineers that works on this project can have such a context. So for some hard and complex issues, AI may be not the best solution right now. Maybe in the next years, it will be able to work with these complex issues too, but right now, it's not ready yet. Also, code review is a very good way to transfer knowledge from one engineer to another, from maybe more experienced engineers in the project to engineers with less experience in the project. If we fully remove engineers and people from the code review, we will break this process. We will not be able to use code review to transfer the knowledge. Maybe we will be able to create some additional ways of sharing this knowledge, but currently, if we just replace, we will break this process, and it is not very good in terms of adoption of engineers and to creating the overall culture on the project, overall developing culture of the projects. And also, it can give the problems with co-ownership and bus factor. Because if nobody except the developer itself who creates the changes and the AI understands what and why has been changed and introduced, the new developers, the other developers will require a lot of additional time, a lot of additional cognitive load, cognitive efforts to understand if what happens there, if it will require to make some additional changes. So if we remove the people at all the wall from the code review, we can also break this co-ownership and we'll create the bus factors in some part of our system. So this is the point why we haven't replaced the engineers from the code review wall, but we can help them to make it faster and to make it better and to require lesser efforts from the developers. So how can we help AI? What AI need to make the code review properly, to make it the best as possible? First of all, it needs to understand what's going on in our projects, how we are working with our code, what are the rules, what are the good way of doing things, and what are the bad way of doing things. The second one, it needs additional info about the task, about what the developers want to achieve, about some additional restrictions and constraints in our project. And also, we need some iterative process to be able to gradually improve the quality, because to understand what should be, does we have enough context, does we have enough rules, does we have the right prompts, we need to have the feedback, to be able to incorporate the feedback from engineers about whether AI have succeeded in finding the issues or it have failed. And if we have such information, we can interact, we can gradually, incrementally change these prompts, change this additional context management, and improves. If we have not such a feedback, we will not be able to improve. So this is what we need from the good system, the ability to manage all of these things. We need them to improve the quality of the AI code review. So usually all the companies have to choose between two ways, whether to buy some SaaS solution which are already at the market, or to create their own custom solution and to fine-tune it to their own needs. Of course, SaaS solution is much easier in integrating, in adopting, and into setup. And now there are a lot of different companies that provide such SaaS solution, from Copilot and Cursor Bugbot to Godot, Code and etc., and Dev and OpenAI. But sometimes these types of the system have not enough points of customizability and of improving. And for example, in our case, we have not been able to get the quality of code reviews that we would like to have using all of the system. We have the benchmarks, we have some internal benchmark based on the pull requests that we have, and they showed us that the quality is not good enough because we cannot provide additional context. We have not additional customizability in terms of rules, so we have implemented our own solution. So let's describe what do you need and how can you create such a solution. You need some runner. So this is where this check will be run. For example, you can take GitHub Actions as a runner. You need some tools that can interact with the LLM. For example, you can use any command line interface tooling like Gemini, Codex, like a Cursor agent, or for our example, we have used the Cloud Code. You need to monitor the user feedback. So you need the mechanism to collect the user feedback about whether code review goes right or wrong. We have collected all this information and gather them in our metric system. In our case, it's amplitude. And also, of course, you need additional monitoring about how AI has been worked to be able to control the cost and control the time and control some situation where everything goes wrong. For example, Sentry has a rather good instrument where you can collect all the data regarding the working of AI agent. So this is one of the examples of how this architecture of custom code review solution can looks like, and this is how we have organized it and implemented in our company. A little bit about tips and tricks. Use as much sub-agents as possible. This helps you to decompose the more complex tasks on more simpler tasks. For example, you can use a sub-agent for security analysis, for functional analysis, for performance analysis. Each of them will have their own context, so it will help you with the problem of large and unfocused context. So each of them will have their own focused context. There are a lot of different command line tools that you can use for the code review. For our case, the Claude Code with the Claude 4.5 Sonnet is our favorite choice, but we can easily experiment with other one. And also, to make the adoption as easier as possible, use a dry run to understand how it works, compare it with your benchmarks, and then you can, after you receive the good results on the dry run, you can incrementally adopt it on the wall level and introduce it to the user. Okay, let's go next. The next part will be the checks on the pull request levels, the pull request builds. Why it is a problem in our case? As we have described previously, the CI/CD for mobile development requires a lot of different builds because we deploy our application to different target platforms, and also because of C++ and because of a lot of additional assets, it requires a lot of time to run these checks. So how can AI can help us with these complex and large builds? So first of all, why the long builds are bad? Of course, it costs us more time and more money to run through these complex builds and to understand through a lot of build logs what's happened and what have failed. So how can we introduce AI to this system? When we have some failed builds, usually we have an agent where it happens. And our way about how to improve this process is to introduce AI CLI tool directly to this agent. So we do not run some additional checks, some additional agent. This agent is run directly on the same agent that has built and that has some failed logs. Why it's important? Because we can incrementally rebuild this build to test any fixes. In our case, the incremental build, if you have everything already built, takes just several minutes. You can compare it with half an hour or maybe up to 1 hour and more if we talk about the new build on the new agent. And this agent, you can make it just in several minutes. And it allows us to make some iterations and try to fix it. And if we have been able to find the patch that have help us to pass through the compilation problem, through test problem, you can just introduce this change to the user. So this can help us a lot to not require the human to get into the system to understand from build logs what has been happened and why it fails, to understand what has been changed. We can just do it by AI and just introduce the change to the user, to the engineer, and said, something has been failed. We suggest this is the problem that has been arised, and this is the fix that we suggested. Press apply to fix everything. Of course, it's not so easy to implement, so I have additional tips and tricks for you. And first of all, if you will not be able to achieve it in a small number of iterations, usually the problems is more complex and maybe not achievable by AI. So we constrain it only by 3 iterations to try to fix the builds. If we haven't been able to do it in three tries, it means that it requires human attention because something is too complex for our AI instrument. Okay, the regular builds. What is different? Why have we check everything at the pull request level? Again, because of the number of the target platforms, the complexity of the checks, the time of the build makes us we haven't been able to run all of them on the pull request level. It will, if we try to do it, it will require several hours for each pull request and a lot of additional resources. So we have to decide it and to move some checks from the pull request level to the regular level, for example, nightly builds level. Okay, so what are the main problems with regular builds? You have a lot of pull requests during the day. In our cases, it can be 100 pull requests per day for each of the projects or more. If something fails during the day, you have just the result at the end of the day that you have a lot of changes, up to 100 pull requests, and something doesn't work. And to understand what have not worked and why it have, and what exact pull request has broken the whole check, it's very hard to understand and to get. We use a bisect. Bisect is a binary search where we divide everything by 2 halves, understand whether the middle of our search is green, so pass the check, or red, so doesn't pass the check, and decide whether we go right or left in terms of timeline. So bisect can drastically decrease the time of finding such a build, the pull requests that have broken the whole check. And if we talk about 100 pull requests per day, for bisect, we need only 7 checks. Compare it with trying to check everything. It gives us speed up to 14 times. So how we use it in our CI/CD? We use bisect to find the exact pull request that have broke the check, and then use the same AI system that we have discussed previously to try to fix it. The same system, because of the incremental ability to incrementally run the build on the agent, it can take just several minutes for each try to fix. And one more, what additionally can be achieved by using the AI fixes during the bisect and during the regular builds, it can help us, and this is the single way about how to do it, to find the multiple issues. So if during the day there has been the several pull requests that has broke your check, it is very hard to find all of them, because in some of the point you have several problems that has been that has broke the build. But if you have the ability to fix and to create the patch, you can apply it and use bisect one more with this patch to find the next issue. Then create the new patch, create the cumulative patch, and run again. And this will allow us to create to find the multiple issues and to fix them and to create the cumulative patch, even if there has been several issues during the day. It's a very, very important and can save us a lot of additional money and time. Also, you can apply the same idea to the working with the test. But with the test, there are additional problem, the flakiness. Usually, if we talk about the test on devices, working with the end-to-end test, both on simulators, and devices, if they are flaky, if they can pass or fail with some possibility, it will break all the bisect problem. Because if you fail on some point, and this is not because of a real problem, but because of the flakiness, it will break the bisect. Of course, there are some ways about how you can overcome it. For example, you can rerun, you can measure the flakiness, you can ignore the flakiness test, but it is the problem. It is an additional problem. So working with the test is more complex for bisect and for fixing the regular builds. And what we are doing now, we are improving the ICD using the techniques that I have described before. And also we are trying now to use these building blocks to create more standalone pipelines where user just started and then everything goes automatically through these pipelines. But this is the future, and I will I hope that I will be able to talk about it a little bit later, maybe on the next game dev conference. So that's all for now. Thank you very much for attention, and I will be happy to answer your questions if you have one.
Hi, Ilya. Thank you very much for a very interesting talk there. That's quite a system you've got set up there to help you with your builds. Do you find that basically, is it helping? Is it working?
Yep. Yeah, we are not fully implemented and fully adopted all of these parts, but the results that we have achieved during the both code review and creating the after patches are very, very interesting for us, and we continue the adoption and continue the improvement. Also, as I have described before, this is one of the very important points of this whole process, to be able to incrementally improve. If you create the systems that can be incrementally improved, you will not be able to achieve the good quality. One of our main approach is to create the system that can be achieved, that can be improved. So we get, each time we gather the feedback from our users, from our engineers, and use this feedback to improve it a little bit. And what we see that we can improve. So maybe the quality right now is not what we would like to have. We would like to have much better quality, but we see that we able to incrementally increase it. And this is the main point, because if we can create the trend and we can reach this point of the quality that we needed.
I was actually going to ask about feedback and how you take that feedback and use it, because you did mention you'd want the AI to sort of learn and understand and extend its context. So when you say you collect feedback and sort of iterate on that, what do you do with that feedback?
Yeah,
how do you do that?
The simplest example is about code review. So what signal can we get from the pull request? First of all, we introduce reactions. So each developer can just use thumbs up, thumbs down, or confused emoji just to express his reaction to what the AI suggested. So this is one type of the feedback that we can gather. Of course, usually developers is a little bit lazy and they do not want to use the reactions. We ask them, but of course we collect some feedback, but of course not at all. And the second important signal is how much issues that has been displayed by the AI code review has been fixed. Because if it's important, if it's really important, the user will fix it, and we will be able to check that it disappears from the pull request before the merge, when they merge it. But if it does not, it has not been checked, it has not been fixed. This is a very, very powerful signal that it's not important, because if we showed it and developers decide to do nothing with it, it's not important. So we can use this signal too and use it to improve our system. And then, of course, we have examples where we have been good and where we have been bad, and we can try to incrementally change and see understand what are the common problem in the situation that has been disliked by users, and try to fix it by using additional context or using additional rules, additional knowledge about this. So the problem can be that there is no enough knowledge for the system, enough rules for the system, or it has no enough context. So because we have customizable solution, our own solution, we can provide the both.
Right, yeah, so I was curious then as to whether it was sort of adding extra rules, adding extra context, and then kind of the next iteration would then hopefully have more information to be able to work with it.
Yep.
Yeah. So I guess then when the AI does fix something, which is hopefully the goal, what do you do with that build then? Do you automatically check it in? Do you kind of have to have human in the loop again to verify it and accept it?
Currently, at the current state, we try to verify it additionally with human, because it's adoption state and we are not sure enough to be able to just push it to the branch. But I hope that in the future we will be able to do it automatically. There is a very interesting research paper from Meta engineers. They have used their own system. Of course, they created their own system for AI code review, and they compare that the best way to introduce such changes will be to show them only to author of the pull request. Because if you show them to the reviewers or to the additional human reviewers, it will require for them to additional times to recheck it. And usually it's not improve the time of the pull request review, but decrease. Not decrease, but increase the time.
Yeah.
So they find that the best configuration will be to show it directly to the author, and he will decide just to apply it or not apply it.
Yeah, that kind of makes sense, I guess. Alex,
But will it be biased by the author of the PR and the changes provided by the AI? Like, we are not only talking about the speed of the review, but on the quality as well.
Of course, he will be biased. Yeah, you need to work with it. So this is one of the problems with all the AI. If the human who worked with it does not trust it, it cannot work. The system will not work because he needs to trust it. So we need to educate. We need to help them understand how it works. We need to show them the results. That is really helpful. So only through this additional approaches, so you need to spend a lot of resources and time to do it, because yes, of course, the biasing is a problem.
Mm-hmm. Yeah, I think trust is very important in this kind of a loop of the feedback. Last question, I think, to finish things off there. You were talking about tests and everything. Do you find that tests are very important for this kind of a process?
Evals are very important. Evals means the benchmarks for everything that you have implemented.
But you're also mentioning end-to-end testing for your actual builds.
If you talk about end-to-end testing, yes, end-to-end testing is a very important part of our pipeline, because we cannot just check everything on the unit test level or integration test level. We need to see how it's work from the end to end, from the overall pipeline. Yeah. So yes, and this is in many cases the most complex problem with AI or without AI. They has flakiness. They requires much more time than any other types of the test. They are very hard to understand why it has been broken, because if you have a compilation error, you can just see in most cases, you can see, okay, I have a compilation error on this line and I need to fix it. But end to end, everything just not working. The application just not started. Why? Or the animation does not play. Why? Nobody knows. So for end-to-end tests, it's very, very important to find the exact changes, to find the exact pull request that has broken it. Because when you just have 100 pull request changes during the day and something does not work at the end-to-end level, it's very hard to debug this kind of problem. But if you can minimize, if you can, using BSEC, if you can find the exact pull request, it's much easier, both for the human and both for the AI, because if you introduce to the AI the result and the simpler problem, it can be much easier for it to use the same iterations to try to fix it. Okay, try to understand what's happened, try to make the fixes, rerun the single test that has been broken, and to see what is the result. If the flakiness will be low enough, it will work. But one of the main problems with all mobile end-to-end testing is the flakiness.
Well, yeah, game development isn't known for its rigorous automated testing, is it?
Yeah.
Yeah. I'm going to leave it there before I insult anybody else with the testing comments. But thank you very much. It's a very interesting topic. It'd be really interesting to know how this evolves over time, and hopefully it'll provide great value to your builds and to your engineers.
You're welcome. You're welcome. Thank you, everybody, for the attention and for the questions. Bye. Bye.
Bye now.
So, what do we have next, Matt?
Well, I think I need a big build-up and an introduction. What do you
Some
reckon?
more juicy topics upcoming on our stream today. So let me introduce our. Oh wait, I'm completely off the hook. I thought that the introduction to the netcode will be next one, or
Oh,
we
no,
have a.
No.
No.
You're jumping ahead there. It's
Sorry,
honestly,
my
look
bad.
what time it is. It's me. That's what we're getting at. It's me.
Oh, for sure.
I'm going to talk to you for a while.
Let
This
me introduce our next big speaker, like the one and only, the best of the best, Matt Ellis from JetBrains, showing guys some cool stuff coming from JetBrains. Hey, what to you, man?
Yeah, thank you. I think you kind of just about brought it back with that one there. It was good.
Always a pleasure.
Yeah, so I'm going to spend some time now talking to you all about how things are looking at JetBrains for game development. If you're new to JetBrains and game dev, or if you know a few things, we'll have a look at what the offerings are, what's new, what are some cool, interesting things, and so on. Also interested in any questions you got. So, I'm happy to answer sort of any questions you fancy throwing in the chat. I'll see what I can do about that. We can always drag Alex back on stage to answer a few more questions as well with regard to the C++ and Unreal support. But in the meantime, we've got about 20, what have we got now? Yeah, just a little under 20 minutes now to sort of talk about a number of things which are related to game dev and Rider. So first of all, I'm just going to do the little bit of an intro. If you're not already familiar with what we do for game development, our main product really is Rider, which is an IDE for working with game development. It works with Unity, Unreal, and Godot. And in fact, let's switch over and ignore the slides for a bit and actually have a look at something that we've got here. One thing you might notice as well is look at this. Look at this. We're in the nice shiny islands UI. It's all just sort of looking a little bit nicer there. Some nice coloring on the background, and those tool windows and everything got rounded corners. It's a little bit of a visual refresh that we've just done in the 2025.2 release in the last week or two, and in the 2025.3 release that's coming soon that we're currently in the early access preview for. So a little bit of a visual refresh, and it's really nice. I like it. This is good. So this is Rider. This is Rider with a Unity application. You can see on the left here, we've got our Unity tool window, and you can see the files pretty much as you would do in the Unity project view itself. You've also got, the assets folder. You've got your packages folder. Oh, let's zoom out a little bit there. Packages, so you can look and see what the different packages are and navigate around your code like that. I can see in my different folders here what's going on. And so on, but we can do a whole lot better than that. We can search for things as well. We are indexing everything when we open up your project, and so we can very quickly navigate around and go and find something. Let's go and find was it Spawn Manager? I think is something Spawn Instruction. Okay. I forget where I'm. Tower Defense main menu. That's always a good one. TDMM. You don't have to type the whole thing. You can very quickly type the initials of something, and we'll match that against classes, against files, against symbols as well. So you can very quickly navigate around and find your code. This isn't just about Unity either. It's also the same in Unreal. So I've got an Unreal project open here, just a Lyra sample application, and again, we've kind of opened up, we've got the source, we've got the editor, the game itself, we've got plugins loaded in here, and a whole load of other things too. So we can navigate around and see all the files, or we can just use Shift, and we can go to, I'm already at camera mode, let's go to, is it player controller? And so you can very quickly see that we've indexed everything. We can go and find a whole load of things. We can find symbols and usages. We can hit tab and go and find classes. And it was a player controller. That's what I should have gone for. I always forget the prefix. Hit tab again and go and find files. And then obviously we've got more symbols there too. And so we can very quickly navigate around and jump to your code. So let's go back to camera mode. See, it's found the file there, but I could always move over and find camera mode as a class. So we've got a great way of sort of navigating around. Once we're in a file, then we've got a whole load of inspections and quick fixes. Let's just jump back to Unity for a sec. This one here, the Tower Defense main menu, has got an inspection here saying we've got some virtual members but no inheritors. We don't need to have that. We can quickly clean those up. If I scroll down, we can see we've got virtual members there, unnecessary. Oh, sorry. So I can just do Alt-Enter, and this is then our sort of second main thing. Shift is all about searching and finding something. Alt-Enter going to go and find and fix things. And here I can just make we've got a suggestion that I can make the class sealed. And if I kind of go down now, you can see my virtual items have gone, and it's cleaned up the code for me. We've got a whole heap of inspections and quick fixes for loads of different things. Things from naming standards. So if I was in Unreal and I'd named my class wrong with the wrong prefix, it would tell me, it would give me a hint to say it should be a player controller or whatever. It might be using a new C# language feature instead of an older syntax. It might be a newer, more concise way of doing it. It's a great way to learn the language and use things. Or it could just be sort of syntax. What am I trying to say? The layout of your code, the syntax and how that looks too. So there's loads of things there. There's additional inspections for language features. For the engine features as well. So if I go to, let's go to my null objects item here. We've got various items here to give me a highlight to say that something interesting is happening there. Let me just zoom in on that a little bit. I'm comparing a Unity object against null. We've got a highlight to show that something extra is happening there. We're doing an additional check there to make sure that the underlying Unity object exists and is still active. If I jump to, let's have a look at which one. Yeah, invalid method signature here. Unity's got a whole load of inspections like runtime initialize unload method attribute, and that's got the wrong method signature. So I can very quickly use Alt-Enter again and fix up my code. So lots of great features in the box to help you work with Unity, with Unreal and Godot. But the things which are really kind of interesting is that it's not just the files that we index, but also the blueprints and the assets and the serialized data as well there. So switching back to my Unreal project here, Lyra, I can see I've got my Lyra camera mode item, and above it, just at the top here, let me just zoom in so you can definitely see that. We've got this link here saying that there are 4 derived blueprint classes. And if I click that, you can actually see what those classes are. And in fact, if I click on those, because I've got the engine running, the editor running, sorry, then it'll bring up the editor for that particular blueprint, which is very useful and a great way of being able to quickly see where your code is being used and see how your designers are using it and find all of that. It's not just the classes that are being used either. We also understand what the values are too. So here I've got this blend time property here. That's being changed in 2 different blueprints here. We've got a value of 4 in this particular blueprint and then 0.22 in there. Let me just go and change this one. If I go and find blend, where is it? 0.22. Let's change that to 3.4. And if I just do save now and swap back, you can see now you might have just caught that flash there as everything updated. And if I click that now, we can also see that it's updated and we've got 3.4 for our blueprints. Really great way of understanding how your code's being used, how you're inside the editor itself, brings that sort of serialized data into the editor. And we do the same thing for Unreal too. Sorry, for Unity, those two. This is where I'm bouncing between the two. I'm going to say the wrong names for sure. If I go to my wobbling homing projectile, I can see this being used inside this prefab. And if I clicked on that, it would open it up in the Unity editor as well. Is that going to work? There it is. And so it highlights that, and then I can then start working with it. And again, I'm seeing the values that are being used there. This turning time, for example, has got a value of 1. And my wobble direction change speed's got a value of 8. So again, you just bring all that information closer to where you're working so you get to see what's going on. Other useful integrations we've got are things like bringing in logs. So we've got the Unity log here, and you can see all the errors for my dodgy code and exceptions that are going on there. It's much better when it runs, and I've got some runtime exceptions going on. We've got a similar thing with the with Unreal, and so you can see the Unreal editor log there. You can look at messages, warnings, and errors. I haven't got any errors in that one, which is a good thing. And so you can filter by the verbosity and also by the trace level as well. So there's a lot of great sort of interaction and interactivity you've got with that. So tons more things that I could show you about Rider and Unity and Unreal, but I want to kind of move on and show a few other things and talk about some of the newer things, really. So if you're already familiar with what I've just shown you, then we've got some new things as well. So in the last release or two, then we've been working on a number of things for the different engines, and I'll go through these through the different engines there. Firstly, with Unity, we've made a bunch of fixes for the debugger. There's been a number of problems where the debugger could get into a really awkward situation based on how different your code was, what type of code was being debugged, in what order things would happen, when things would get breakpoints would get hit, the debugger could get into a state where it stopped working. And so we've had some fantastic help from the community to help us understand what's going on there, understand the logs, and have a deep dive into what's going on. And there's been a number of fixes there to work with the debugger. We've also got support for mixed mode debugging, which is really quite useful if you are doing both C++ and C#. You can step between the two. That is just a checkbox in the run configuration, and you can then sort of start debugging C++ as well. And then two nice new features are the frame viewer shader debugger and the Unity profiler integration. Now, if I just jump back over to my Windows machine here, we'll have a quick look at the frame viewer debugger. I've got a Windows, I've got a Unity application running here, and what I want to do is I want to understand what's going on when I'm actually rendering a frame and how things are working. So the first thing I need to do is go up to these three dots here, and why is that not showing me what I want it to show? Okay, maybe because I've already done it. What I really want is this little icon here. What this needs to do is give us a button and an action which can capture the current view in RenderDoc. So you need to have RenderDoc installed for this. It's got integration with Unity already. You can capture a frame in RenderDoc and then do some work with it. And if that's not available, there is a option in these three buttons here to say load RenderDoc and find it. So let's just very quickly get this up and running. I'm going to start playing this game a little bit. So we'll do that, kick off a wave like that, and we can see that something's happening. And I'm going to click my button here to capture a frame. Let's just come out of play mode here. And if I jump into RenderDoc, we can see there's my frame. And if I save this, let's just call it TD for now. If I save that, I can actually switch back into Rider, and now I can open this. I can open up the frame viewer itself. Sorry, the frame view of this particular item. And you get to see all the different steps that are going on here. We can change the way we want to look at it and have a look at all events, and you get to see everything. And so you could dive through all the different calls that have been going on there, or we can narrow it down to the shaders with sources that are part of my Unity project here. You can see the texture that's being referenced here, rendered there. You can see well, once I've selected something, you can see the vertices involved and so on. And so we can select those, and then you can actually, there you go, you can see different items. We can zoom out and have a look at that. And if you wanted to zoom in on a particular thing, area, you can do. And also you can have a look to sort of see the values of each pixel. I'm going to choose this particular pixel. Let's have one of those over there. And you can see we've got a debug button here. I can click debug, and we can actually then start debugging this particular pixel with this shader. You can see I'm actually using the ambient occlusion shader there, and we've got the values that are available to me here. And I can start to step through that, and I can actually see the values being set there. P0, for example, is being set. And as we go, we can step through and work with the code that we've got. If I just step one more time, I've got a function here, get back normal. I can actually step into that, and so we can sort of debug on that. In fact, we've got a breakpoint set there, so I could have just run this, carried on running it, and it would hit the breakpoint and start to debug at that point. I can stop the debugger, I can switch to vertices, I could select a vertex there, and I can do the same thing here for my vertices too. So shader debugging is really nifty piece of integration. How are we doing for time? We're good. Very, very quickly, let's have a look at profiler integration. I've got another game here. It's the same game, but on Mac. I've done some deep profiling. I can select a frame here, and if I have a look in my list of items, we can see that this target updater is taking 87% of the time here. And so if I double click on that, it should take me back to here, but let's just jump here anyway. If I go to targeter, because I know it's there, I've got a button in the top here, which is telling me that there is a new snapshot ready to fetch. I can load this manually. I can have it automatically refresh. I've got it configured here so that I have to do it manually. That should load it, and it's all loaded. And you can see now we've got a whole load of useful information here telling us how long these particular calls took. And we can go down as far as our aim turret here to say that this one took 62 milliseconds. And if I step into that, we can then see further. And then you can see, if I scroll down far enough, you can actually see the horrible bit of loop in there that I put to make it work. And when you swap frames, then you can actually sort of see other more useful stuff. Now we've got a bunch of good stuff in Godot as well. Lots of new features for GD script. We've actually brought in the GD script plugin from the community. That's now maintained by JetBrains, and that gives us completion of code, Godot nodes, resources, doc tooltips, parameter hints, and so on. And if I find the page with that's on. So yeah, we've got a GD script here. For example, now we can do see our navigation to our files there. I can control click and go to the file. You can see that there are inspections going on here so that the item could be given a type, so we can actually validate the type there. And we also get a scene preview tool window as well. So we've got like a view very much like you get in the Godot editor itself to look at how your scene is looking. So zoom back over here. Far too many screens and windows. Other useful things. Actually, I wanted to just quickly show that with this here. If with this here, I can do find usages to see where pair scene is being used, and again, you get to see our normal sort of find usages, and we can also do a rename, and that will update where it was defined and the name there as well. So we've got renames as well as find usages. There's also file templates, and we've also added UID file support as well. So UIDs, very much like Unity's meta files, allows you to identify a resource by an ID rather than a name. Whenever we refactor something, rename a file, will also update the UID file that goes with it. Just quickly now, looking at some Unreal Engine stuff. These are a little harder to demo for some things. So I've got the release notes that we've been working with because these are most useful. A lot of really, really useful things for native debugging. So working with a native debugger, one thing which is really good is the suppressing low-level exceptions. So if Unreal wants to use the int3 instruction, for example, to just signal that something should stop, which can be used in asserts, for example, then quite often that can be a complete pain and it just stops you working. It continually stops. What happens now, and if I just jump over to this blog post here is really useful, by the way. It gives you more details as to what's going on. If you hit one of these low-level exceptions, the code will stop and you get a little sort of exception marker in the gutter of the editor there, and you can click on that and you've got the ability to suppress it. It's like the opposite of a breakpoint, essentially. It's like the code is going to stop here and we'll add a breakpoint that you can then disable so that it will actually skip it. So you can skip this particular exception globally at this line or this particular address. And there are a few other useful things with that there as well. Let me just jump back over here. Other nice things that have been added are step filters, so you don't have to step in. If you're just hitting step into, you don't going to want to step into the standard C++ library and so on. You can pause all the processes, and we've also, when you hit a debugger, we automatically attach the child processes. We'll pause those when you hit a breakpoint and so on. Lots more useful features in native debugging there as well. Lots of speed ups as well. Lots of work on NatVis type stuff. Just want to shout out that we've got support for consoles as well. So you've got support for PlayStation 5 and Xbox. You obviously have to sign up with your developer things for that. And we're good to go with that. We can't do anything without talking about AI. And there's some really nice new features which have got AI support for Rider. We've got AI Pro. The AI Pro license is included in your .ultimate and all products pack. And there are some nice new features as part of AI Assistant itself. So if I just call up AI Assistant, a number of new things. We've got new models in there as well. So you've got the latest models there just from having your JetBrains subscription. You've got access to Claude 4.5, for example, GPT-5 here. We've got different modes available to you as well. So we've got the chat mode that you know and loved for just asking questions and understanding what's going on with APIs. Quick Edit Agent, and also we've got support for Claude Agent there as well. We brought Claude into our AI assistant, so you can use Claude code essentially as an agent through the chat window. But we also have support for Junie, which is our own agent. And if I can find the right one here, then there's a number of useful things you can do with Junie. The first one you can do is click here to generate project-specific guidelines, which is a great way of giving Junie a lot of information about your project and a lot of your code, and make it work with how you want it to work. You can then add those files continually. These live in this guidelines.md file here, for example. And then once you've got Junie working, you can give it a task and you can get it to do something for you. If I go to my final page here, for example, here I asked Junie to shake the camera whenever whenever the character is hurt, is damaged, takes damage. And so it has built me a C++ class here to shake the camera. It understands how the camera shakes, how you have to attach that together, and how you wire that up then with a particular character when they take damage. And I think I'm just about out of time. Very quickly wanted to mention Team City. We've got native Perforce support. We've got support for Unreal and working with the build graph engine there. Unity as well. We can do automatic license activation and deactivation. Lots of fun things on the roadmap. More support for GD script with updated parsing and updated debugging. We're actually pushing a lot of things back to Godot itself to try and improve the work there with debugging and so on. There'll be a nice inspection there for leading white space as well for anybody who wants to copy and paste code in while retaining the significant white space. Mobile development is going to be a bit of a thing for Unity and Unreal. We've got more improvements for the profiler integration and the frame viewer. Unreal's getting more support for NatVis and, again, performance with indexing blueprints and so on, and also code completion and highlighting in inactive preprocessor branches. So that is essentially a quick tour of where we're at. I actually ran out of time without answering any questions, but I'll jump into the chat now and go for it. Alex, I don't know if there's one or two questions to answer before we bring on our next speaker, who's already waiting in the room.
Sure thing. I have just one little question. So I've noticed there was a mention of Unity profile integration. And what about the real game engines like Unreal? Do we plan to integrate the profiling system into that?
Do we? I don't know. Let me just ask our resident Unreal Engine expert here, Alex. Do we have any intentions to integrate Unreal Profiler?
God dang it! Yes, we have, but that's a long story. Like the first iteration, we mostly target right now is to make support and mobile support, and hopefully one day we'll actually have the profile integration. And one little question just before the next one. What about the console support?
Console support. So console support for Unity, for example, is in the box with Unity itself. So we don't have to do anything. That just works. But for Unreal and native, then we've got a couple of plugins which you can download. So that would be on the website. If you just go and search for Rider for consoles, then you get to a web page where you can register with your proper developer credentials for Sony or Microsoft, and then you'll be able to download the appropriate plugin, which will allow you to then sort of debug, deploy, and work with both PlayStation 5 and Xbox.
Cool.
How's
That's nice
that?
to know.
There we go. Always a good one. Okay, I think it's. I've talked over Johnny's time long enough now. I'll answer some more questions in the chat. If anybody has any more questions, throw them over. But also pay attention to Johnny's talk because Johnny's got some good things to say. Should we bring Johnny on stage? Hello, Johnny. Sorry for making you 4 minutes late. I do apologize.
Oh, you're great. I was enjoying your talk. So,
but don't get me started on these things. I can talk all day about them in the end. Johnny, thank you very much. You're going to be talking to us today about Netcode for entities, is it?
This is correct, yeah.
Fantastic. Looking forward to it. If you're ready, we'll bring your slides on and leave you to it.
Sounds great. Yeah,
Thank you.
I'm all good to go. All right. Hello, everybody. So I'm Johnny, and I'm going to be doing my talk today on an introduction to Netcode for entities. So just a quick introduction on myself. My name is Johnny Thompson. I'm a Unity developer. I work independently doing contracting, consulting, things of that nature. I also do content creation. So you may have come across the Turbo Makes Games YouTube channel. If you've looked into anything about Unity Dots or ECS, you may have came across my channel. So yeah, a whole bunch of tutorials on there, some fun live streams, a lot of good stuff over there. And earlier this year, I actually released a Steam game called Dots Survivors. It's available for free over on Steam. And also over on the Unity Asset Store, I have available for purchase just a whole bunch of learning resources where you get kind of all the project files for this game, Dots Survivors, and access to a whole big website for kind of like learning about creating a full game with Dots. So I'm super proud of that. But that's what this talk is not about. To talk about is an introduction to Netcode for entities. So I just want to give a little bit of an overview about what Netcode for entities is. I'm not here to say, Netcode for entities is the best and it should be used for every single multiplayer project under the sun. But I do want to talk about some of its strengths and weaknesses, and to help give you an idea about, what things that it kind of does well. And so if you're making a game that can kind of take advantage of some of these features, then, just kind of want to, give you some exposure to this and kind of, maybe hope you consider it, because I think it is a pretty good Netcode solution. So just kind of starting things out, I want to talk about, a couple of the different Netcode solutions that are available through Unity. So Unity provides a couple different Netcode solutions. So there's two, kind of high-level APIs. So there's Netcode for game objects and Netcode for entities. And they also have a low-level API where you can actually access, what's called the transport layer, where you can get, if you want to make your own kind of custom Netcode solution, Unity kind of like offers you access to some of that lower-level API. If you don't necessarily want to use some of the higher-level stuff with Netcode for game objects and Netcode for entities. Of course, there are some other third-party solutions like Photon, Fishnet. You can create your own custom Netcode solution, of course. But just to kind of like anchor this talk, I want to do just a quick comparison between Netcode for game objects and Netcode for entities, just to kind of go over the two higher-level APIs that Unity provides. So starting with Netcode for game objects. As the name suggests, it's kind of built off of Unity's traditional game objects. And so, things are, kind of all managed through regular mono behaviors. So if you look at this image here, here's kind of some examples about, kind of how you would define, say, a networked object and a network transform. And you have some options about, what kind of data that you want to synchronize and everything. So this is all, again, done through regular Unity game objects and mono behaviors. Now, when we're talking about Netcode for game objects, there's two different kind of like network topologies that you can use. So there's server authority and distributed authority. So server authority is where the server has the final say of what happens in a networked game. There's two different ways that you can typically set up a server authority. So one of them would be a dedicated server where you have, a server typically running on like a cloud machine that people connect to. And the other main option would be a client hosted option where one of the clients who are actually playing the game, they're also running the server, and you kind of do some peer-to-peer connections where, you know, all the different players are kind of connected to that one host client. So there are kind of some pros and cons with these different approaches. You know, if you have like a dedicated server, that's going to kind of reduce the possibility of cheating, because, you know, that server is kind of running on hardware that you as the developer control, versus, you know, it's running on hardware that the client is controlling. And so maybe they can kind of hack into it and do some different things on there. You're typically going to get the best performance from running a dedicated server, because, you know, again, you as the developer, you can choose what hardware that your server is actually running the game on. And then there's also like no clients have to actually simulate the whole server. So, you know, the clients are only running their client side code, server is only running the server side code. So you're kind of going to get the best performance on there. However, it can be expensive to run dedicated servers, because, you know, you typically have to pay for, you know, the time that these servers are up and running. And of course, there is some latency involved. And, you know, especially if, you know, maybe you only have servers in one region of the world, and, you know, people from all over the world are connecting to that server. Well, you know, depending on your geographic location to that server, there is going to be, you know, more or less network latency. You know, again, another option, like I mentioned, is setting up in like a host mode where you have, you know, the client who is also running the server. In this case, you know, maybe the host can kind of hack into the server and kind of cheat a little bit on there. But it's also going to take more simulation resources to run the host PC, because, again, they have to run the client and the server on there. And the kind of remote clients, so the client who's running the server, obviously they're going to have no latency, network latency, communicating with the server because it's on the same machine. However, the remote clients are going to have some latency, again, kind of depending on the geographic location from the remote people to the client running the server. Distributed authority is a little bit of an interesting thing that Netcode for Game Objects offers, where the kind of authority for different things in the world is distributed across all the different clients. So this kind of reduces the possibility of cheating, because there's not like one central point of simulation. You know, again, it's kind of like separated across like many different clients. It also is a little bit of a performance optimization, because, you know, there's not one client who has to run the full server simulation. Just everyone is running a part of that simulation. So another feature of Netcode for Game Objects is that it has support for interpolation and anticipation. Interpolation is just kind of a way to smooth out data between network updates. And anticipation is just kind of like a simple guess of what the values are going to be at the current network tick, you know, kind of factoring in some latency of data being received from the server and all that. So it's not like a full client prediction with simulated rollback and everything, which we're going to be talking about a little bit later. But it still, you know, has the ability to do just kind of like a simple guess of where things are going to be in the future, and kind of has the ability to fix some of those incorrect anticipations. So when should you use Netcode for Game Objects? So one reason would be if you want to use traditional game objects. You know, when we talk about Netcode for entities, you know, you have to use Unity ECS. So, you know, if you're still really comfortable with using Unity game objects, and you know, maybe you already have a game built out with game objects that you want to make multiplayer, then, you know, that would be, you know, something that you would want to look into Netcode for Game Objects for. You know, if you're not necessarily super comfortable with Unity ECS yet, yeah, maybe I would still kind of encourage you to look into a little bit, because I think ECS is really cool and just like a great way to make games in general. But, you know, if you're really set on using game objects, then Netcode for Game Objects is going to be kind of the way that you go for that. It is typically geared more towards casual and cooperative games. These games, you don't necessarily need any like really amazing full client prediction or anything like that. Or maybe cheating isn't as big of an issue in these types of casual and cooperative games. And the kind of performance of these games might be a little bit easier to run, so that makes it better if you're kind of doing like a host mode type setup where the one of the clients is also simulating the server, where it's not going to be like as demanding on that system to run both the client and the server. Or if you want to use kind of that distributed authority option, then Netcode for game objects is what you're going to have to use. So now let's talk a little bit about Netcode for entities, what this talk is about. I'm just going to start with like a high level overview, and then some of these things I'm going to be going into depth on a little bit later. So if I kind of go over something quickly, just wait a sec. I have a little bit more information later in this talk. So Netcode for entities, as the name suggests on this one, is built off of Unity's entity component system. So this synchronizes Unity ECS entities, and all the data that is being synchronized are stored in Unity ECS components. Now, Netcode for entities is a client-server architecture only, so you don't have the ability to do that kind of distributed authority thing that Netcode for game objects offers. But you still can run this in two different modes where you have, a dedicated server running in the cloud, or maybe a server that you kind of own and maintain, or you're doing a host mode where you're doing more peer-to-peer connections, and one of the clients is actually simulating the full server on their machine. So Netcode for entities also does support interpolation. However, it does have a full client prediction with simulated rollback. We'll be getting into a lot more details on this later on, but this full client prediction is just a lot more accurate, and it's a better kind of prediction engine than the basic anticipation that you get with Netcode for game objects. Netcode for entities can also support much higher player counts. So there actually isn't like any, a hard cap on how many players can be in a game with Netcode for entities. But I did actually see a tech demo online where somebody made a 700 concurrent users connected into a Netcode for entities simulation, which was pretty impressive. And they were basically just saying at that point they were really just bottlenecked by the network traffic. So pretty cool that it can kind of support up to that. Again, in a very specific tech demo case. So don't expect that to happen with every type of game. So when to use Netcode for entities? So the kind of one of the primary reasons would be because you would want to use Unity ECS and data-oriented design. Again, it's my opinion that I just really like making games with ECS and data-oriented design. I think it's just kind of like a better way to make games. So if you are interested in using ECS and data-oriented design, Netcode for entities just fits right into using Unity ECS. It is also geared a lot more towards competitive games where you kind of want some level of fairness, where you have this simulation running on the server and you want to have this better client prediction and everything like that. That's just suited a lot more towards competitive games, maybe like fighting games, MOBAs, first-person shooters, those types of things. Also, it can be used kind of if you want to make more ambitious games. Unity likes to use this verbiage for using dots and ECS to help you create more ambitious games where you're kind of pushing the boundaries of what game objects has to offer. So you want to create games with more players, more enemies, larger worlds. Just really when you start to get to the limits of Unity game objects, then that's when you want to start looking into using entities just in general. And then if you're making a multiplayer game, it makes sense to just use Netcode for entities in that case. So I do want to briefly mention a couple of games that are made with Netcode for entities. So one of them that I do want to call out is this Mega City Metro game. This is a publicly available demo created by Unity, and all the source code is available on GitHub. So you can actually play this game on desktop and mobile phones. You can connect over 100 players into this world at once. And it is just this kind of like large world that you can fly around and shoot the other people who are flying around. So it's a fun little thing, and it really just kind of shows some of these larger, more ambitious games that you can create with Unity ECS. So this one is made from the ground up with Unity ECS, and I think it's a great example project to show what you can do with ECS, and also what you can do with Netcode for entities. Another one that I do want to call out is Survival Kids. So Survival Kids is a game that was internally developed by Unity. It's actually published by Konami and is a Nintendo Switch 2 launch title. Interestingly enough, this game is made with regular Unity game objects, but they created a full custom setup where each of the game objects kind of has like an additional entity counterpart associated with it. And that's kind of, my understanding of it is that that's what kind of does this synchronization across the netcode for entities, is what they're using for the network API. So a little bit of an interesting setup, but really cool to see that the, full published Unity title Survival Kids is built off of netcode for entities. All right, so let's talk a little bit about some of the getting into like some of the more specifics about things. So we'll start with entities. So entities is also kind of known as the entity component system, and the entity component system is kind of a representation of separating entities, components, and systems. It's kind of built off of these data-oriented design principles where you're kind of separating your data from your simulation logic. So, we have these structs, which are kind of data components that store the data associated with entities. And then we have separate systems to modify that entity data to make things actually happen in the game. Now, I probably could do many talks on, what the entity component system is and all the features of it. And in fact, I have done many talks on just that. And actually at the past 2 JetBrains GameDev Day conferences, I've done a talk on an introduction into data-oriented design and Unity. And then the one last year I did is called Why Dots is Unity's Silver Bullet, and just kind of went into, just kind of much more in depth about what ECS is and kind of how it interacts with this broader thing called DOTS, which is Unity's data-oriented technology stack. So if you are kind of interested, I think that would be a good place to start to kind of just get a little bit more knowledge about, kind of what you get with Unity ECS. So, kind of going with the entity component system, that separation of data and transformations, I really do think that it lends itself well to networking. This is because data is kind of easily synchronized, because data is often stored in kind of these like simple types, which are serialized pretty easily, and we can send these across the network, pretty easily. And again, they are kind of, just data. There's no kind of like methods or anything associated with them. So, we're really just synchronizing data across the network. And then we have these systems that kind of operate independently on that data. And we can kind of specify where we want these systems to run. So we can say, this system should only run on the client. This system should only run on the server. So, for example, the client is going to be handling just running, say, the input and user interface systems, where the server is kind of running, more of the game logic and kind of like, processing some of the server side networking things. Actually, typically we also want the clients to run the game logic as well to kind of predict the server behavior. But we'll be talking a little bit more about that when we get into client prediction there. So the entity component system, this kind of just enables us to have more players, more enemies, just more dynamic things. Like I mentioned, it's great for making kind of more ambitious games. We can have faster simulation times. We can also easily use the job system and burst compiler, which are great features of the Unity game engine. Now, you still can use jobs and burst with regular Unity game objects, But when you use ECS, it's extremely easy to use jobs in burst, because it's just kind of, just adding in a couple extra things. Like everything that you need is already right there for you. One other thing that I do want to mention is, Unity has kind of announced this whole initiative of ECS for all, which is coming to the Unity game engine, where, basically if you have just a regular project created with Unity game objects, that each game object is going to have kind of an entity associated with it. And this is going to make it really easy for, if you were building out a game objects project and you wanted to add in some of these, cool ECS features, you can have, you can write some ECS systems that kind of, process these things for, if you have some, particularly heavy logic, those are some good use cases for that type of thing. And, this is a little bit of a speculation, but, it seems like that when this kind of ECS for all initiative is in place, then it's going to, make integrating Netcode for entities in just a regular Unity game object project a little bit easier, because there are kind of already those entities available for you. It seems like it's almost something like, kind of what that Survival Kids game did, where, it's built with game objects, but they kind of have some ECS entities that are kind of doing that network synchronization. So going into another topic here, just about the kind of server authoritative nature of Netcode for entities. So again, this server authority is where the server has the final say of what happens in the game. This is to greatly reduce the possibility of cheating, where the client can't hack into the client code or their network traffic, because the server is the thing that's actually processing all that data and saying if something can happen in the game and all that. So again, it is kind of important for competitive games where fairness is essential. Now, with this server authority, there still is going to be a delay between the client and the server. That's just kind of due to physics realities of sending data across the network. So it is going to take some time for, if you're running the game on your computer, to actually send that out to some server somewhere. That server has to take some time to process that, and then it gets sent back to you and all the other clients. So there is going to be a fair bit of delay, and unfortunately, it's not uncommon for some data to be outdated by a few hundred milliseconds by the time it actually reaches an end client. And of course, as we're talking about competitive games, this is really going to be a big issue because we want this simulation accuracy to be as on point as possible. So let's talk about some of these solutions to latency. So one of them is interpolation. Now, interpolation is basically just a way to kind of smooth out the data received from the server. So it's going to kind of have some previous data and some current data, and it's just going to interpolate that data from one point to the next. This is really important for smoothing out movement in games, because often games are going to be running at a higher frame rate than the server tick rate. So, for example, with Netcode for entities, the typical default server rate is 60 ticks per second. You can increase that or decrease that as needed, but I think 60 is a pretty good one to start with. But however, let's say that the clients are running the game at 120 frames per second. So that ends up being a little bit of an issue, because your game is running at double the rate that your server tick rate is. So if you're only updating the, say, positions of things on the, when it's actually received from the server, then, they're going to appear to be running at that lower, 60 frames per second in that case. Whereas, if your game's running at a higher frame rate, you want it to be much smoother. So what this does is it, just kind of smooths that out, across that full network tick. So, you kind of get some of those in-between values there. One of the consequences of this, though, is that the data is going to be outdated. It actually ends up being a few ticks behind because there, of course, is some network latency. It takes time for that data to come from the server to the clients. And it's typically also going to be buffered by a couple network ticks because you don't always want your data to be running up to the current network tick. Because if there happens to be some case where there's some little hitch in the network where there might be some packet loss, then your movement's going to be kind of jittery again of those remote clients because they're going to kind of like go up to the latest data point that they have, and they're going to try to continue to interpolate again, but they're like, okay, well, I haven't received any new data recently, so I just kind of freeze here essentially. So it ends up getting buffered by a couple ticks, and that's just so that movement can continue to be nice and smooth, even if there is a couple ticks of packet loss. It kind of has that buffered data. So there are kind of some issues with interpolation, but it is something that you still want to use, and you do want to use it pretty frequently. Netcode for entities can take advantage of interpolation, and this is often most used for less relevant network objects. So maybe these are things that are further away, or maybe they don't have a critical impact on gameplay. We actually kind of want to have probably more things be interpolated than predicted. We'll be talking about prediction in a moment, but prediction can be quite expensive. So, if we can get away with doing some interpolation for something, it's better to do that. But again, this data can be outdated. So the kind of other solution to latency that is kind of often created for some of these networked type games is client prediction. And client prediction essentially runs a local simulation of the game on each client. And what the client is going to do is it's going to guess what the server is going to do based off of the previous input data and kind of like the trajectory of that data. So it actually, the way that this works is it runs the same code on the client and the server. And that's so, the client knows kind of what the server is going to do, but the client is still kind of making guesses about what's going to happen, because, anything can kind of happen in a multiplayer game. So it's really just like, the client is kind of like doing its best guess as to like, what this remote client was previously doing, how can we kind of like continue doing that? But, ultimately the server is still going to have the final say of what happened. And we kind of need to handle some of these mispredictions as well. So a couple cases where we do want to use client prediction is, anything that the player controls, we always want that to be client predicted. Because let's say, we didn't have client predicted and, we pressed, say, like the jump button to make a player jump. Well, we have to send that data up to the server saying, hey, I want to jump. And then the server basically, processes that data and says like, okay, yes, you can jump. And then it has to send that back to the client. And then, the client receives that and then, they actually jump. That takes quite a long time. So what we, end up doing with client prediction is as soon as we hit the jump button, we just run the jump logic, assuming that the server is going to say, yes, we can jump. Because again, we're running that same code on the client. We have these same kind of constraints and parameters. And so the client should know if they can jump or not, right? So we want to just make the character jump as soon as possible. And then the server is, kind of says, hey, okay, this client is jumping, let's run this simulation, if it were to jump. Now, let's say that the, client predicted that the player just kind of jumps straight up and lands back down in the same place. But the server says, okay, the client jumped, that's fine. But, maybe someone actually like threw some like barrel or something and it like hit the player in midair and it kind of like knocked them over to the side a little bit. So then now the client kind of needs to like fix that behavior and then say like, oh, okay, I should actually be, over in this position. But so yeah, again, we just kind of want the player to immediately respond to input actions, even if it's not the thing that ultimately ends up sticking, but we still do want that, give that like immediate feedback to our players. So client prediction can also be used to predict the behavior of remote clients. So, based off of the previous data of remote clients, then we're going to continue simulating that data into the future. The idea behind this is that we want to be predicting, the network time that we're predicting should be like the same physical time that the server is simulating any given network tick. So this is kind of like a way to kind of try and mitigate some of these latency delays where we're, again, we kind of have some previous data from the server, but we're, predicting a little bit into the future about what these remote clients are going to be doing. And so kind of along these lines, we have this thing called simulated rollback. Now, data is actually received from the server in a bit of a buffer. This has a couple purposes. One of them is to kind of avoid packet loss, where, if there is some packet loss, then, we kind of have the last couple data points, and that kind of allows us to kind of like run this simulation back with all the different data points. And so, yeah, we can just kind of like re-simulate this data as needed. There are some problems with simulated rollback. It can be fairly expensive because essentially what is happening is you're basically running like multiple you're simulating multiple frames of the game within one single frame, which can end up being expensive in some certain cases. So, let's say your frame rate starts to dip down, maybe some network ticks are missed, and, we're kind of running this simulated rollback logic. And, if we have to run this simulated rollback logic and that ends up being expensive, that can cause our frame rate to drop even more. And then it kind of spirals out of control where your frame rate can kind of like really just crash down. So that's why I say it's really important to, only predict the things that absolutely need to be predicted. So, maybe enemies that are close by, or, other really important things. Whereas, enemies that are, kind of further away, out of sight, whatever, maybe we can get away with having those set to interpolated, just so it doesn't take up these resources of simulating this rollback. I will say that this is quite important for dynamic physics objects. That's one thing that I've seen is resimulating the physics systems multiple times per frame can get extremely expensive. So we don't want to be predicting like a large amount of dynamic physics objects. I also will give a shout out to the Unity documentation because they do showcase a bunch of really good examples and edge cases for client prediction and simulated rollback. So there's a lot of good things in there. Now, again, there are still going to be some differences between what the client predicts and what the server actually says happens. So, as a minimum, you might notice kind of some like jumping around. Say, for example, if one of the remote clients was running straight forward down a hallway, the client prediction would say, let's continue predicting that client to move straight forward. But then, the player makes like an abrupt turn to the left. Then, the client is still going to continue predicting that as going forward into the future, because there's no way that they can guess exactly when a remote client is going to change their direction of input. But once that's processed by the server, sent back to the client, then the client can correct that by essentially kind of re-simulating that behavior, and then now they're kind of like moving over to the left. So that's kind of like, the minimum. You might see a little bit of jumping around, but unfortunately, it still can lead to some bad situations for, maybe the client predicts that they did something good, but then the server says, no, that didn't actually happen. Maybe, for example, like the player kicked a ball into a goal, and then on their end, they see the ball go into the goal, and like they thought they scored and everything. But then the server says, oh, no, actually, there was another player who came in and blocked that. And so that like actually didn't happen. Well, that can be quite frustrating because, you see the ball go in the goal, but then, a second later, it's just like, bounces off to the other side. So that's where, things get frustrating and immersion breaking. But it's just, really, again, the kind of unfortunate reality of doing client prediction, especially when there is some network latency involved there. So now I want to kind of dive into a little bit more of the tech that we get with Netcode for Entities. So one of them that I do want to talk about is worlds. Now, a world is a concept of Unity ECS. And a world is basically a complete simulation with entities, data components, and systems. And if we have multiple worlds running in one game instance, entities in different worlds cannot interact with each other. Now, in a typical single-player game, just one default world is created. And then say anytime that we create an entity, it's going to be associated with that default world. Anytime that we create a system, an instance is going to be created for that single world. And then that system is going to be running on, again, data components just in that specific world to make things happen in the game. Now with Netcode for Entities, multiple worlds are created. So one's going to be created for the server and one is going to be created for each of the clients. Now, if you're running this in, say, dedicated server mode, this again is pretty similar to like a single player setup where just your dedicated server is just simulating the server world, and then each client is just simulating their own client world. Now, if you're running this in host mode, where one of the clients is also simulating the server, then they're going to be running both the server world and the client world. So they kind of have two instances of this game running. Again, it's not like the exact same thing because some things are just running on the server, some things are just running on the client. But for the most part, when we're doing like predictive systems, a lot of that logic is going to be run on both the client and the server. And then so again, keep in mind that for every entity, component, and system that is kind of part of our game, one copy of that is going to be in this server world and one in the client world. So, there are kind of like two instances of every system running. For every entity, there's two instances of that on that computer. So again, you're kind of just like, running the game twice. I will say having these split worlds is really nice to have because we can easily just say, hey, run this system in the server world, run this system in the client world. We don't need to have like a bunch of split logic all over the place where we're saying, if server do this, if client do this. You still can have that, but it seems to just be a little bit cleaner when we're just kind of, specifying systems running in different worlds. So RPCs, they're kind of pretty common in multiplayer developments. Typically are used for kind of one-off updates between the client and the server. So, they're kind of like for, say, significant events like requesting to join a game or, telling all the clients to move to a new scene. They're not typically used for gameplay things. It's more kind of like the, higher level, things like, again, joining a game, changing scenes and all that. So just to kind of show you about how these RPCs are actually structured in Unity ECS, it is a little bit interesting how we do that. In this case, I have an example RPC of, if a player wants to join a specific team, then we can create this data component. And you see this is called the MOBA team request. and it implements this IRPC command. So that's kind of to specify, this is like an RPC that we're going to be sending across the network. And so we can associate some data with this. So this is, say, hey, the data that we actually want. So this would be the team type. So maybe if the player wanted to join the blue team, we could assign the blue team as some data in there that gets sent up to the server. So how is this actually done? Well, we actually create an entity, and that entity kind of sends that RPC request. So you see kind of in this middle image here, we're creating an entity. We're adding this MOBA team request data component to it. We're assigning the value of the current requested team. And then the way that we actually send this RPC is we add another component, which is the send RPC command request. And then we can set the target connection. So for the target connection, we actually need to specify the entity that we're sending it to. In this case, this pending network ID, it's going to be the server. So this would be like an example of, again, the client saying, hey, I want to join the blue team. Let's send this up to the server. And then on the server side, this is kind of how we interpret that data. So we can create a query which looks for any entities with a specific set of components. So in this case, we're looking for entities that have this MOBA team request, but also we're looking for ones that have the receive RPC command request. So when the RPC is sent, you can almost think of this like, when it gets sent, this send RPC command request almost changes into a receive RPC command request. Again, it doesn't really change on the entity because it's going between a client world and a server world. But when this RPC entity is kind of created on the server side, it has this receive RPC command request. And so that has some information about, who sent this RPC. So we can actually, handle this request in a system and then, send back to, either just that specific client or all the other clients that, that connection went through. So again, these RPCs can go, from client to the server, from server to one specific client or all the specific clients. It's just kind of like a way to kind of broadcast messages between, again, client and server. Another interesting thing that is kind of available to us is command data. This is most often used to send player input up to the server, but it can be used for other things. It's actually set up as a ring buffer to kind of aid with resimulation and some packet loss issues. So you can actually kind of like go back in time. This would be especially important for input data, where if just on one frame, if a player presses a button and then that gets sent to the server, or they try to send it to the server, but there is kind of some network packet loss, and then the server never actually receives that hey, I pressed the jump button, then that's of course an issue. So we kind of want to buffer this data a little bit, so we kind of have are actually sending like the last couple ticks of input, so we can see hey, if there was some packet loss, we can actually see if a couple frames ago that the player actually tried to send the jump button. So we kind of have that. Here's kind of a little bit about how this command data looks. So the one on this top, I'm kind of like setting some cooldown target ticks. So I'm kind of using some network ticks to say, this is when a particular ability should go off cooldown. Typically, we want to use network ticks for timers like this, just because it's a little bit easier to kind of like synchronize that data across the network. So you can see that this is set up as an iCommand data. With this iCommand data interface, one thing you do have to implement is this first line here, which is the public network tick called tick, which has a getter and setter. And then, so anytime we're kind of like assigning data to this, we kind of need to like set the, the tick number that we're setting this data for. So we can say, hey, on this particular tick, we're setting the rest of the data components. In this case, it's the AOE ability and skill shot ability. And then so the server, when it receives that, it can look at a particular tick to see what that data was. And again, by default, this is kind of stored in a ring buffer, which I believe is 64 elements by default. And one thing that Unity kind of did is, because again, this command data is typically used for input data. It's like, having a nice stream of input data. They also created this input component data. And this one acts a little bit more like a regular data component, where we can just kind of set the data value on it. And it's kind of like a wrapper for this command data, where it actually kind of implicitly sets this tick value, so that we don't have to worry about that for input for input data, which is nice. But again, we still do have the ability to do some things a little bit more manually with the command data there. So another great feature with Netcode for Entities are ghosts. And ghosts are basically entities that are replicating data from the server. And so ghosts can either be predicted or interpolated. Again, we kind of talked a little bit about interpolation versus prediction. And so you can see when we're kind of doing our authoring, which was we're setting kind of like our initial values, we can set a default ghost mode. So this can be interpolated, predicted, or owner predicted. And again, we can kind of change these on the fly. So, maybe something by default is set to be predicted, but then, once they're actually in the game, we can kind of determine, hey, this thing is, actually a little bit further away than we wanted. So, maybe we'll make this an interpreted one. You can see there's also some other things that we can set on here, such as importance. So this is kind of gives the simulation a little bit of a hint about how important something is. Something with a greater importance value is more likely to send more frequent updates. So, maybe we can have something that is set to predicted, but maybe it's not as gameplay critical as like some other players in the game. So we can set it to be like a lower importance value. So, it's still receiving updates from the server, but maybe not as frequently. That's just kind of like a way for, the network traffic to be kind of metered. So we're not like, sending too much at one time. And there are also a whole bunch of, other additional options that we can set. We can get real granular about, how data is being synchronized. But anyways, the whole idea with ghosts is that, again, the server is kind of simulating these ghosts, and then that data gets sent down to the clients. And then, whatever data that we're kind of specifying as ghost data is just going to get overwritten by what's ever received from the server. So how does this practically work? So we have these things called ghost components. And you can see that in this case, we have this like ghost component attribute that's going over this damage buffer element. And we can kind of specify some options on here. So this is set to a prefab type of ghost prefab type dot all predicted. Now, what this means is that this component is only going to be on entities that are considered predicted entities. This is kind of like a performance optimization, because maybe in this case there are some particular systems and components that we only really want to run on things that we're doing predicted data for. So this, the way that I've kind of set up this little combat system is that we have these like damage buffer elements, and if something gets damaged in a particular frame, then we kind of add to this damage buffer, and then like kind of towards the end of the frame, we accumulate all this damage in this damage buffer, and then use that to set the current health of an entity. And this is something that we really only care about predicted entities for, because we want, if we're predicting an entity, we want its damage, to be updated immediately on the client side. Whereas if we're interpolating something, then all we really care about is updates to the current health that we're receiving from the server. So we don't necessarily need to worry about predicting its health in the same exact nature. So what this, again, attribute does is this will add this component to any entity that is predicted. Not any entity, but like any entity that we specify. But if it turns to an interpolated entity, then this component actually gets removed. And then the way that Unity ECS works is if an entity doesn't have a component, then it doesn't participate in those systems. So again, it's a little bit of a performance optimization because it's just not participating in those systems, which is kind of nice. And then you'll see the other kind of attribute that we can have in this lower image here is the ghost field attribute. And this essentially means that anything that is stored in this field is being kind of like received by the server. So if you have this ghost field, you can't really set any data on it, like on the client side, because once the server receives that data, it's just going to overwrite that data. So yeah, again, these ghosts are really just kind of like replicating what they're receiving from the server. So to talk a little bit about the different systems that we have. So this would be like, how we can specify where we want systems to run. So in this case, we have, say, like a movement system, this champ move system. And we want this to be a predicted system because, of course, if we have, a player, we want our player to immediately move as soon as we, press any move input. And also for any remote clients, we want them to be, moving right away as soon as we get any movement from them. And we do want to, continue to predict their movement as well. So the way that we specify to make a predicted system is we just tell it to update in the group, which is this type of predicted simulation system group. Now, if we don't like specify if we want this to run the client or the server or what have you, by default, it's just going to run on all worlds that we created. So, client worlds, server worlds, anything else like that. And so again, these predicted systems, we want these to run on both the client and the server. So they're running the exact same logic. So then, the two images below is how we specify if we want a system to run in the client world or in the server world. So you can see the health bar system, because this is, it's just something like UI related system. We only want this to run on the client. So we just kind of add this attribute above the system where we say world system filter, and then we can pass in the world system filter flags that we want. In this case, it's going to be the client simulation. So this is only going to run on client builds, or in client worlds rather. And then for, say, something that we only want to run on this server, like the server process game entry request system. So it's kind of, processing the, says like, hey, like a client says, hey, I want to enter the game world. The server should, kind of process that and allow them to enter the world. Well, this is a server only system. The client doesn't need to run this at all. So, we can do the same thing, but we also have a world system filter flags for the server simulation. Another cool thing that we can do with Netcode for entities is have thin clients. Now, thin clients is just kind of a way to test network traffic and behavior, where we are kind of like create simulated clients to run around in the game world. Typically, in most cases, you're just going to want to have these like join into the game world and enter random inputs and just kind of have them move around to test network traffic. Of course, if you want, you can get more complex and like actually have some like maybe AI behavior that's kind of controlling these to, act as if they were a real person and kind of like making certain decisions. But really, it's just like a great way to test what your like how your network traffic is going to react with like a full lobby of players, because say you make some major changes to your game and you want to see what the network traffic is going to be like, how things are going to react. You don't want to have to like gather up a group of 10 people every single time that you do that to test it all out. So on your computer, you can kind of simulate these thin clients to kind of get an idea about how the different client predicted systems are going to work and all that. So I think they're a really great feature to have and test with. So when you're creating builds of your game, you have a whole bunch of options. You can create dedicated server builds, dedicated client builds. You can create host builds, which have both the server and client on them. If you want your server build to be a headless Linux build, you can do that. And then your clients, they can be whatever platform they want. There's just a whole lot of options for them. And so you can use Unity has some services available that allow for hosting the game, peer-to-peer relay, matchmaking. But you're not locked into using Unity services. You can use any services and host it on AWS or Azure, and create your own server network infrastructure. You really have a whole lot of options, so you're not locked into using one thing or another. So I do want to talk about some of the tools that are available with Netcode for Entities, because I think there's some really cool tools available. One of them is multiplayer play mode, where you can essentially run multiple instances of the game on the same PC. So you really can just say like, hey, I want to run the game with 4 instances of the game, and so you can easily just configure that, hit the play button, and then all the windows pop open, and you can click into each window, control each one, and so you can see how the game is going to react when you have multiple remote clients and everything like that. So you can test out what client prediction is going to look like, and if there are any issues for running on like remote clients versus like a hosted mode. So yeah. And you can get individual log messages for each of the connected clients. So it's just real nice for debugging. Like if you're running into something where like only on connected clients you're seeing some issue, you can kind of have some debug log statements in there to start to look into what the issue is. Some other tools available are the play modes tools window. This one's really cool because you can kind of specify if you're running the game in client mode, server mode, client and server mode, and it gives you, here's where you set how many thin clients should be spawned into the game, and that's a whole lot of options for testing different network latencies and just kind of like network issues you might experience. You can kind of like set all these, have some lag spikes, and just kind of be able to test your game and see how it reacts to all these different network scenarios which you're going to experience in the real world. So I do want to talk about a couple of different learning resources, some things that I've kind of created here. So, if you're completely new to ECS, I would recommend checking out my Survivors-like tutorial, where I created this with, simple little Survivors-like game using dots and ECS. I think it's a good introduction to ECS, kind of like go over some of the theory, as well as, just kind of showing you how to set up a simple little game. And so, yeah, definitely check that out if you're brand new to ECS and just kind of want to figure out how to create a simple little project. After that, if you want to do any Netcode for Entities specific things, I did create another full tutorial about how to create a multiplayer game with dots and ECS. By the way, both these videos are available just on my YouTube channel, Turbo Makes Games. And so this one, it kind of assumes that you have a little bit of ECS knowledge, but I go into, how to, set up like all the Netcode for Entities specific things like, handling input, doing client prediction, running things, server, client, all that. So definitely a fun video, and recommend checking that out. And if you do want to get a little bit more into some of the intermediate ECS things, I did mention that earlier this year, I published this game .survivors, which is available for free. You can download it, play it around if you want. And, it performs great. I think it's a real great showcase of creating a game with dots and ECS. Running in the game on a Steam Deck, it's a locked 60 frames per second the whole time, even with a lot of enemies on the screen. So I'm really happy with the performance that I was able to get out of it. And then also over on the Unity Asset Store, I have for sale basically all the project files from the full shipped Steam game that you can purchase through there. And then I have this like big documentation site set up where it shows all the things about creating a full game with dots and ECS. So if you want to learn a little bit past like just a simple little tutorial, and you want to see all the considerations you need to make for a full Steam game, I would recommend checking that out over on the Unity Asset Store. So anyways, that's my talk on an introduction to Netcode for Entities. I hope you enjoyed it, and I think we're going to get into some questions and answers now.
Yeah, fantastic session. Thank you. There's a lot going on in that Netcode stuff, isn't there?
Oh, absolutely.
Yeah. It's my head's buzzing a bit with all the differences between interpolation, the prediction, and so on.
Yeah.
I'm going to jump in with it's a question for me actually.
Okay.
The ghost components, I didn't quite get what they were for. Would you be able to sort of give an example, perhaps?
Yeah. So that would be for basically if you had say like a health component on like a remote client, then and the server kind of says, okay, the health actually like decreased at this time, then that data gets sent down to the clients, and then whatever data is received from that is kind of overwritten on what it had on its like local copy of it. So that's just kind of like the fields of it. But then the ghost components would be for if something is interpolated versus predicted, you could have that component on an entity or remove it depending on just kind of the performance optimizations that you want to do.
So it's basically just to say, I'm going to work on this, locally because I'm going to try and figure out what it is, but actually it's not an authoritative thing. Someone's going to tell me what the actual values are.
Right. Yeah.
With you. Got it. Yeah. Alex, do you have any questions?
Sure. I am kind of far away from Unity and whole stuff. I will always when I hear about the dots and CI system in Unity, I know that it's been around for so long time, but do you know what the adoption rate? Does it studios usually use it for the production?
So yeah, as far as percentages, I obviously I have no idea, but I do know there are some big name studios that have been creating games with dots and ECS. Unity has kind of promoted some of them. But actually, if you go on SteamDB, which is a great website to get a lot of information about Steam games, if you go to a game page, there's a metadata section. And so you can see if a game has the entities package installed. I mean, obviously it doesn't tell you if the whole game is made off of entities, but it can show you if that package was installed. And so you can actually search by, you can filter by, all the games that have that package installed. And I think there's over 500 Steam games now that have it on there. So it's been used for a fair number of projects.
Mm-hmm. So you could say it's fairly stable these days, not perhaps no longer experimental.
Yeah. And that's one of the things that I wanted to really test out with my .survivors game is could I make a full, shipped Steam game, and what's that experience like?
Mm-hmm. That does look like a great set of resources actually for understanding how this thing can work in action.
Yeah, I'm
That's
really
true.
happy with it.
I mean, 500 games is like an hour of Steam. Like every hour, 500 games are being released.
True.
Matt, do you have a question?
Yeah. I was going to ask. I think you perhaps kind of covered it a little bit with the Island Kids or
Survival Kids.
Survival Kids. There it is. Because as I understand it, dots, ECS, and game objects can be used in the same scene quite happily. So what happens with game objects that need to have some kind of network stuff?
Yeah, that's a good question because and even with the Dot Survivors game that I created, there was a whole bunch of things that I still had to do with regular game objects because ECS doesn't have like an ECS version of everything. Mm-hmm. Typically UI, audio sources, these are kind of like some of the more notable things that don't have their ECS equivalent yet. So we kind of have to like create a little bit of a bridge between the ECS side and the game object side to kind of like trigger things to happen on the game object side and kind of vice versa. And then as far as like any network synchronization goes, again, all the entity stuff is what's being synchronized. So as long as you have some like systems that are kind of like interpreting those changes on the ECS side to trigger things that happen locally on the game object side, then that's kind of how you would approach that.
Okay. Yeah, that doesn't sound too painful at all, really. It's just a bit of wiring up.
Exactly, yeah.
Mm-hmm. Mm-hmm. Cool. Did we just get a message in the chat there?
Yeah, actually. So the question is about the input latency. So you can easily simulate the instant inputs on the client side, but what about like a remote client that is, I don't know, like doing like a thin client doing actions, and it takes forever for the like a thick client to process it.
Yeah. I mean, again, there's always going to be some type of network latency. And actually a fun little exercise that you can do, which is like kind of a good way, I think, to start wrapping your head around, how client prediction works and everything in Unity ECS, is to just like create a simple little scene where you kind of have, just like some little objects that, kind of move around and like react to your input, just kind of like going side to side type thing. And if you add in some network latency with these tools, you'll see that, for your local client, as soon as you press the movement button, it'll start immediately going. But then if you have like a separate window where it's kind of like your local client is that remote client, and you kind of have that latency in there, you'll see that the player that's kind of representing the one that you're moving will just stay still until that network catches up. And then it'll kind of jump ahead to like not where it was received, but where it's like predicting to be now. So it should effectively be in line with, what your client is. But then you'll also see that as soon as you stop moving, that client is going to continue on for a second, but then snap back to where it should stop.
I think sorry, Alex, go.
No. I hope we've answered the question.
Yeah, I think so. I think the tools are really useful there as well. Actually, that panel with the being able to simulate latency and stuff looks like it's going to be really useful. And as you say, can be a good way to get your head around what's going on.
Yeah, I found it very helpful.
Yeah, I'm going to give a shout out to Ryder as well, because I know that Ryder supports listing the different editors in the debug window, so you can actually choose which one you want to debug. So just have to,
Yeah.
Do a small shout out.
I think I know the tools that supports ECS system out of the bat.
Hey. Right, I think we've just about run out of time there. So thank you again, Johnny, for a great session, and lots of great resources there, I think, in your talk as well. So thank you very much, and we'll see you soon.
Sounds great. Yeah, thanks again for having me, and enjoy the rest of the conference.
Thank you.
Thanks, man. Will do. See ya.
Yep. And speaking of which, I think looking at the time, we should move swiftly on and invite our next speaker on, who I believe is Sheena. Hello, Sheena. How are you? Oh, you're muted. Sorry, we can't hear you just now.
Sorry, little technical difficulty. Hi, thank you so much
Hi.
for having me.
Hello.
No problem. Is glad to have you here. Are you? I think looking at the time, as I say, we'll bring the slides up, and if you're good to go, we'll leave it to it. There we go. We can see your slides. So take it away, please.
Sounds good. Hello, everyone. Hope you're enjoying the conference so far. So mine's going to be not as technical. My talk will be power up your team's soft skills that level up in game development collaboration. When it comes to developing games and putting yourself out there, it does take some confidence to create the best game ever. So great games aren't just coded, they're crafted through connection. So why does this talk matter? Show how technical focus often overshadows human factors, but the latter determine project success. So most teams focus on tools, tech, and pipelines, yet burnout, miscommunication, and rework often stem from people issues. Soft skills prevent costly breakdowns and crunch. The better we communicate, the better we collaborate, create, and deliver. So it's not always just about the technical skills, it's also about the people skills, because in the end, it's people who will use the games, and our ideas is what brings to life the games that we have today. So every studio has incredible technical talent, but great games are made by know-how to work together. Oh, by people who know how that work together. Sorry, the little slide part is kind of covering it. All right, so soft skill, the hidden XP in game development, soft skills increase the effectiveness of all technical skills. So communication would lead to fewer misunderstandings, smoother production, trust equals faster problem solving and less micromanagement. Empathy is less friction across roles. Self-leadership equals better energy, management, and focus. Psychological safety equals more creative risk-taking. These are your team synergy stats, the difference between chaos and cohesion. I think this is so important, especially because I read a report somewhere that they mentioned only 9% of the workforce live up to their full potential. So that means there's over 91 people in the workforce that have confidence issues that don't work up to their full potential. And if we all had the confidence to create different things, create different games, have the teamwork, everybody wins. So this is why it's so important to incorporate this. So it's not just only about the technical skills, it's about the people skills, the human skills that contribute to have the games that we have today. So here's some common game dev pitfalls. Identify real world team challenges everyone has faced. So misaligned communication, such as assumptions instead of clarity. So I don't know if any of you have gone through that. Feedback that triggers defensiveness instead of growth. Crunch that leads to burnout. Siloed teams, designers, coders, artists not in sync. Lack of clarity on ownership and deliverables. So if you've ever gone through that, I'm sure this is something that you've probably dealt with before, and this is some of the pitfalls why things don't work out the way they do. So most of these issues aren't because of skill gaps, they're people and process gaps. So in the end, it's the people, the team that you're with, having good communication is so important, being able to have feedback is so important. And working together is also very important, and being clear, why are you creating this game? What is the goal? Why do you want to do what you do? So here's the visible framework. This is something that I created based on my own journey, just being able to put myself out there, being visible, because I believe being visible is how we create the opportunities, right? If you have a game out there that's popular, everyone wants to play it, right? Like my nephews, they love playing Roblox, which almost every other kid likes playing. And so it's also important when it comes to teamwork, game development, and just your personal journey. So the visible framework is the 7 soft skill pillars that help teams collaborate consciously and sustainably. And so each letter stands for something. So V is for voice, which is speak clearly, assertively, and respectfully. Number 2 is I for identity, know who you are and what you bring. S is spotlight, celebrate and recognize others. I is inner work, build emotional resilience and self-awareness. Belief, cultivate trust in yourself and the team. Leverage is use influence to enable other success. And elevation, grow others as you grow yourself. So this framework helps you become visible, not just a contributor, but as a collaborator. And I'll go through each letter a little bit deeper as we go through the slides. So voice. Communicate with confidence. Effective communication prevents misunderstandings, strengthens relationships, and drives alignments. So speak from ownership, such as I notice or I need instead of blame. Summarize meeting outcomes to confirm alignment. Replace reactive responses with clarifying questions. Practice feedback models like SBI, situation, behavior, and impact. I think it's so important to be okay to share your voice, to share your ideas, to share your opinions, because that's how we can have new ideas, new innovations. I know there's a lot of people out there who still get scared, right? Scared to share their ideas, scared to speak up. I've spoken to a lot of people where they want to share something in a meeting and are too afraid, and they don't realize the person beside them has said the same idea and was praised for it. So I want you to be able to communicate with confidence, share your ideas. If you have any questions, be okay to ask them. There's no such thing as a stupid question. So when the build wasn't updated, it delayed QA, and then let's clarify the update with rhythm. So that's an example. So start voicing, communicate with confidence. Identity, own your role. Clarity on your own identity strengthens teamwork by reducing confusion and overextension. So know your creative superpowers and blind spots. Define your boundaries early, such as hours, focus blocks, communication norms. Document ownership clearly. Avoid everyone thought someone else was doing it. Advocate for your expertise respectfully in cross-discipline meetings. I think, sometimes we're so afraid to share who we are, what we're good at, what we're not good at. But I think it's important to identify our skills and talents that we can bring to the table, so that we can learn to work our expertise to create the best product ever, to create the best game ever. I mean, for so long, I was afraid of my own identity. I didn't feel like I was good enough to be on stage, to speak, to write books, to have a platform. But the more I embraced my identity, the more I was able to stand out and share this type of information in different industries, not just in game development. And so when you know who you are, you reduce chaos and help others trust your part of the process. So spotlight, celebrate collaboration. Recognition fuels engagement and encourages creative contributions. So highlight team and cross disciplines wins regularly. Use retrospectives to reflect positively before addressing problems. Be specific in praise. Connect it to impact. Your lighting work set the tone perfectly for the story beat. Create rituals of gratitude, such as Friday shoutouts, demo days, and kudos. So I think it's important to celebrate every win that you have, right? Sometimes we think we can only celebrate it when we hit that big goal, but it's really important to celebrate each and every one of them. So maybe just coming up with the idea in the beginning, that's important. Having a celebration Fridays is important. Doing this as a routine helps us be seen, helps us realize what we have achieved, whether it's alone or as a team. So when you give credit, you multiply motivation. So for me, I've learned to just start creating little wins here and there. I'll have a book that I have writing all my wins, because for me, it's so important to look back at it when I have days where I don't feel great, when I'm not as confident. And so it's really important to share that. And I know sometimes we think the little things that we do don't mean much, but actually those mean more than the big wins, because it's all those little spotlights that you have that help you get to the level that you want to be in. So inner work, manage human stuff, right? Game development is high stress. Soft skills begin with inner stability. So recognize your stress signals and regulate before reacting. Reflect instead of react during creative conflicts. Use breathing or pause techniques during the crunch. Journal learnings after setbacks to build emotional stamina. A lot of the things that we go through starts from our inner self, right? And this is probably not something that's typical to talk about in game development, but it is important to work through this, right? A lot of the things that we do comes from the way we think, how we see ourselves, our mindset. So it is really important to take care of yourself. Have days where you can this is something where we could, find 5 minutes of our time to just de-stress or decompress, or just set time for yourself. Even if you need to go to the bathroom to shout, just do it, right? Because especially when you're in a high stress work environment, you're going to need time to just have some time for yourself, some self-care routine. So whatever that looks like for you, it can be just watching a YouTube video, it can be taking a walk, it can be talking to someone. This inner work is really important to do, because in order to create the best product out there, to create the best games, to be the most innovative, it has to come from within. Sometimes, there's things in our life that still haunts us still today when we don't work through it properly. So especially if trauma is something you've never worked through, it can linger onto our adult life. So something that I usually share with the audience is that in kindergarten in the Philippines, I failed kindergarten for coloring outside the lines of a photo. And that actually went on to my adult life. So for so long, I always thought anything I touch was an instant failure because of that one moment in time where I failed kindergarten for coloring outside the lines of a photo. Like the teacher failed me. I had to redo kindergarten, move to another school and redo kindergarten all over again. And so that really affected me into my mid-30s. And I realized that I wasn't a failure. I was just always meant to work outside the lines, color outside the lines, do something different. And so this inner work is important. It's something that you have to work on every single day. And so inner work isn't selfish, it's leadership from the inside out. So whatever that inner work looks for you, just start, whether it's reading a book, listening to podcasts, attending talks like this, talking to somebody, having a coach, having an accountability partner, have it, because it's so important. Next is belief. Belief is so important, right? Building psychological safety. People innovate best when they feel safe to fail, ask, and experiment. So model vulnerability, share your mistakes first, reward effort and learning, not just outcomes, encourage respectful disagreement, diversity of ideas drives innovation, create norms for curiosity. So can you tell me more about your reasoning? I think belief is so important, especially in the work that you're doing, right? You're trying to come up with something innovative, something different, something that people would love to try and play. And sometimes, we want to share that idea, but we feel like that idea might not be good enough because of how we see ourselves. We don't believe in our capabilities. We don't believe in our talents when we are more than capable. And especially when you're in the game dev development, working as a team, you're going to go through more failures than success, right? You're going to try something, it doesn't work, you move on to the next. I mean, most people who created something successful, especially in tech, had a lot of failures before hitting that success part. And so seeing failure as something good instead of something bad is really important. Being vulnerable, being able to say, hey, I made a mistake, I screwed up, because we're all human. We're all going to make mistakes. It's not the end of the world. We can always pivot as you go. Like even in my book, which I talk about, my latest book, I talk about the importance of ready, fire, aim. So, you just take action, start before you're ready, take action and course correct as you go. That's how we can get results. And, I think it's important to build this belief. It's not only in ourselves, but also our team, right? Because if you don't build that belief in the team, they're not going to feel motivated to create something new, to come up with a new idea. Having that safe space where they can make mistakes, where they can fail forward is so important, because nothing works the first time you do something, right? It's very rare. And so this is really important as well, because without this belief, nothing happens. And so it is important to build that belief in yourself, belief in your team, belief in others, so that you can come up with the best game, the best product out there. So when people feel safe, they'll bring you their best, not just their safest ideas. Leverage, use your influence well, right? Every team member can shape culture and outcomes. So share documentation and insights openly, encourage inclusivity, invite quieter voices to speak, model healthy work habits. Others will mirror them. Use your credibility to protect team health and clarity, right? a lot of us think we have to do this alone, but having a team is so important, and utilizing that to have the best experience is so important. Also, having diverse voices is also important because, I mean, I live in Toronto, which is one of the most diverse cities in the world. We have everybody from different cultures. We have different food festivals in the summer where we can try literally any cuisine from every country. And it's what I love about being in Toronto, that we can all live cohesively together, even though we come from different cultures. And so, of course, you want to create something that, of course, we're not going to be able to please every single person, but if it helps majority of it, it's great, right? And having different voices, different ideas is how we can create different solutions. And so, yeah, sometimes there's a person beside you who you probably think, something is wrong with them because they don't want to speak up. But really, sometimes they're just really shy to speak up. So maybe you just kind of need to give them a helping hand to say, hey, I'd love to learn what your input is on this, right? Sometimes you might have to make the first move to get that input so they feel a little bit better in speaking up and sharing ideas. And so, be able to create that space. So leverage isn't power for others, it's power for the team. Elevation, level up together. When everyone grows, team evolve faster and deliver better work. Offer feedback, focus on development, not criticism. Mentor across disciplines, fresh perspectives, cross-pollinate ideas. Celebrate progress, recognize iteration, not just launch. Build systems that lift others, such as peer coaching, shared learning. I think this is so important, the celebrating progress, because a lot of us just want to celebrate the end result, not realizing it's the journey, the process, the progress that matters the most, because you go from one idea and then all these little different stages in the development process, and we don't realize that it's because of these small steps that yield to the end result. So it's really important to celebrate each and every progress, because it also builds the team up, it motivates them, it makes them want to work on it even more. I mean, these little things make a huge difference, right? And for me, I've seen that where when teams are often celebrated, it's just a better work environment and there's better production. And of course, when you have better production in companies, there's more money for everybody. And so find different ways to start elevating together, right? Whether it's celebrating process, building systems, having a safe space where people can chat or people can share their ideas. I think it's so important. So elevation is how we turn collaboration into legacy. This is not just about a team, it's about what you're leaving in this world, right? Maybe you've created the best game in the world and you could be part of that success, right? So it goes beyond just building teams and collaboration. It's about building legacy, leaving a footprint, showing others what's possible when you level up together. So applying this in the studio, translate visible principles into daily studio practices. So communication loops, improve stand-ups, retros, and cross-discipline syncs. Self-leadership, create personal systems to manage focus and stress. Psychological safety, adopt norms that encourage often feedback and curiosity. Cultural rituals, build small but consistent teams, habits for connection. So these are, I think, all very important. Communication is very important, especially when you're working together as a team. I think constant communication is important so that nothing gets left behind or there's no miscommunication. So, create that, whether it's through a Slack chat or whatever tool that your work uses, or even just having your own group chat, something like that, or an email thread. Self-leadership, just don't be afraid to make that first move, right? I know sometimes we're really afraid, but, when we can share our ideas, put ourselves out there, it helps other people as well. Psychological safety, of course, having safe workspaces is so important. Like I mentioned, it can be a high stress environment. And so you want to be able to work in a place where you can de-stress, you can take the stress away, you can reset and recharge so you can show up even better, right? Because if you're working 10 to 15 hours straight a day, you just get super exhausted and it demotivates you. So having these safe spaces is important, where you can also have open feedback and curiosity, and building rituals, right? Building good habits to create the best product ever, right? So like I mentioned, creating progress habits, celebrating wins, building, belief in your team. These are all important. So this is not just about one big change. It's about the tiny, consistent power-ups, right? I always say the big results happen when you take those small, actionable daily steps. And I always tell people Rome wasn't built in a day, so don't expect yourself to do the same, right? It just takes one step to start that. So here's some of the big takeaways. Soft skills are the new meta in game development. So soft doesn't mean secondary, they're essential, especially with in the world of AI, as AI is getting bigger and just this new updates all the time. These once we're known as soft skills, are needed now more than ever. So having confidence, having leadership, emotional intelligence, resilience, these are all needed because, in the end, we're all human and we're going to need this more now than ever. This is something that we're going to focus on. So don't be afraid to start utilizing that, right? Learning more on how to build your confidence, your leadership, your resilience. Stronger communication means stronger collaboration and stronger games, right? All these steps are important to create the best game ever. So when you have better communication, you have better collaboration with your team. And when you can work together in a happy environment, you have better results. And human skills future-proof your team against burnout and turnover. So like I mentioned, like using the framework, build those human skills so that it can help your teams from burnout and high stress and misalignment and miscommunication. And so the best studios know building stronger games start with building stronger teams. So in the end, it's people that build this. We have the tech to create it, but it's up to us to build it and put it out into the world. And so here's a call to action, empower attendees to apply. Let's empower each other to apply the visible framework in your daily work. So here's some questions I'm going to ask you. How can you use your voice today to bring clarity? How can your belief lift your team this week? How can your studio become more visible together? And, just choose one letter from visible and start applying it today. So I hope that you've been able to enjoy this, have a little bit of learn something new to help you start your journey or keep going, or utilize this framework to help you create the best games ever, create the best teams ever, and collaborations. And if anyone would like a copy of this presentation, I can also send it out to you. Just go to sheenayapchan.com/presentations. You can fill out the information and we'll send it straight into your inbox. And so here's a quote that I want to leave with you. Power up your people and you power up your game. And so that's the end of the presentation. You can also connect with me on this barcode that has all my social media, my books, my websites, and other resources to help you in your confidence journey, and also a visible framework toolkit that you can use as well. So if anybody has some questions, I know we have a couple of minutes left. I wanted to make sure that we were on time so that there's no delays. But yeah, if there's any questions, they can share it in the chat, or I could ask the co-hosts.
Yeah, thanks, Sheena. That was great. I really do appreciate the message that comes across from this. I think soft skills are very much important. For all the reasons you've just been listing there, it's a very important part of working in a group and in a team, I think. I was just wondering if you have any advice on how you could build a team that follows these kind of ideas. I think there's one thing for it to come from yourself, but if you've got to want to have it as a bit of a team culture, what would you suggest?
I mean, I think having like a toolkit is important. So I've created like a framework, like a visible framework toolkit that people can use. It's free that they can download, but I think having open conversations is important, saying, hey, we're going to try this out. We're going to see what works, what doesn't work. We can tweak it to our liking, because each and everyone in the team is not the same, right? They're all different. This is just a framework. It's not like the end of all ends. This is something that we can work towards and kind of interchange it to our benefit. So picking the things, maybe you want to pick one letter that you want to work on with. So let's say like inner work, right? Let's start with that. Like, let's work on what's stopping us from stepping into our greatness, right? Maybe there's something in our lifetime that really was traumatic. And now people don't realize when something traumatic happens, our brain protects us, right? So let's like me, like I failed kindergarten for coloring outside the lines. Like every time I do something, my brain is basically telling me, listen, I don't want you doing this because remember when you were 5 years old and you failed kindergarten for coloring outside the lines? Well, that's what I'm stopping you from. But we have to also like basically tell our brain like what happened when I was 5 is not happening 20 years from now. So maybe it's just starting with one letter that everyone like majority agrees to work on and kind of go from there, but they can always tweak it to their liking.
No, I like that. I think that's very powerful. We've had a comment in the chat as well. Someone's asking about the identity section. You're mentioning advocating for your own expertise, but how would you avoid sounding like you're exaggerating?
I mean, that's a great question. I think sometimes we tend to overthink a lot of things. I know because I was like that, but also showing proof is important, right? So that you're not exaggerating. It's like, look, because of what I suggested, sales have gone up 20%. So that shows that you are an expert at it because you were able to grow the company's revenue or have better productivity or better work culture, right? I think adding proof to it is important because you're going to be like, hey, I'm good at this. It's like, okay, people want, okay, like that's it, right? People will be like, okay, you're great at it. That's great. But if you say, hey, this is my expertise and this is my proof, here's the charts, here's what happened 2 months before I applied it and 2 months after I applied it and see the increase, then people can see that, right? You got to talk in results. People need to see, unfortunately, for some people, they need to see it for it to work and see like, yes, you are the person for this. You are the person who is an expert in this topic or in this skill.
Sorry, we've just lost Alex for a minute there. Sorry, technical difficulty. We were having too many technical difficulties. To follow up on that, I think what was the point I was going to say? Confidence. I think it's it's very valid to have confidence in your own abilities when you have that kind of thing to back it up. It's right and it's good to be confident in the things that you know that you have and you have proved that you can do as well.
Yeah. So like for me, like if people ask like what makes you such an expert on confidence, it's like, well, I have a podcast where I've interviewed over 800 women on the topic of confidence. I've written 2 books on confidence and I've spoken at many industries talking about confidence. So there's all that proof. So now, I'm just not lying. I'm showing them, hey, this is all the things that I've done. So I hope that helps out with the question who was asking if it's exaggerated. And sometimes we just overthink everything. So we just had to like silence the noise so that we just keep moving forward.
Just another.
And so another question. So if you scan my barcode, I do have a visible framework toolkit that you can use to help cultivate in yourself. So it's a free tool.
There we go. I think that helps answer the questions in the chat there. I also kind of wanted to ask about external pressures because it feel that toolkit felt very much like about you kind of growing your own skills and your own confidence and everything. But obviously, external pressures can have they can sometimes have a very negative effect on you. So like the game dev industry, for example, is known for crunch in many places. So how can you kind of work around this while also dealing with these negative external pressures?
Yeah, I think this is why it's so important to work on yourself. Like that inner work is really important because I mean, yes, we can be easily swayed by external pressures, right? External forces. Like social media can be a huge like mind manipulation, right? We see like people who like, oh, they're so successful, they were able to make money in 30 days and here I am still trying to make $1 on day 88. So this is why it's so important to work on yourself, to know to work through those issues, and also have setting boundaries. I know it's easier said than done, but it is important to set those boundaries, right? And we have to look at these timelines realistically too. I know it's easier said than done. I totally get it. I'm not in the game development industry, but we look at this deadline. Does this make sense? Will it help us and the client, or will it be worse. So sometimes we also have to look at that, and maybe if we need to just delay it a little bit to help everybody, not just the people creating it, but also, maybe not everyone's waiting for it yet. Maybe we need to add something else to have a better launch or something, right? That's one. No, two, working on yourself is important. Having personal development every single day so it helps you calm yourself. And then setting aside some self-care, right? I know that's probably not like typical in game development, but even if it's 5 minutes, like not even like 5 minutes of your time, I think everyone can spare, right? Whether it's just looking at something on your phone or just taking a walk or just even like taking a breather, right? Just
Or
start really small.
playing a
Like,
game.
yeah, play a game, right?
Yeah, I'm not sure entirely that's going to help, but
Yeah.
yes, exactly. I also wanted to ask, you did the section you had on sort of applying this kind of thing with cultural rituals. I wonder if you could you could give us a couple of examples of what kind of cultural rituals you could do to, to try and sort of cement this and help this kind of framework grow.
Yeah, I mean, like I mentioned, right? Like having like maybe winning Wednesdays, sharing one win that you have, I think is so important because a lot of us don't share our wins enough. We only share it when we have the end goal, right? Like
Yeah.
when we've created the game, but not the in between. And the in between is way more I believe the in between is way more important than the end game because if it wasn't for the in between parts, you wouldn't have a game developed today. So even having that, shouting out, having spotlights, having circles where people can talk about, just what they're struggling with. Especially when you're in game development, sometimes you're working on something and you're so frustrated because you're trying to get something to work and then it's not working. And sometimes you just need like a circle to talk about it. And there's maybe someone else in the team that can say, hey, you know what? I can help you with that. Right. So, because a lot of us feel like even though we're in a team, we still feel alone. So really creating that team ritual, even like just let's have a coffee session. Like you just go have coffee with each other and just talk to each other because it just builds that relationship with your team members and it helps the collaboration become better, right? Because in the end, we're all human. We're not robots. We have things that we go through outside the work, right? And sometimes we don't even know that they're going through something. So yeah.
No, I think that's a good idea. We do actually have within JetBrains, we've got a random donut session, which people can sign up to, and you kind of then just say, right, I'm going to have a break and a donut, and you end up just having essentially a coffee break with somebody, and it could be anybody, which is quite fun because you can then might be somebody who you'd never normally speak to, and you end up having a 10 or 15 minute chat with them, and you get to meet them, you get to know them perhaps a little, and it helps to talk to someone new, to listen to someone, what else they might be doing, and so on. So yeah, I think these kind of cultural things are important as well.
Yeah. So
Yeah.
I hope that
Okay.
helps
Well, thank you very much for your session there. I do think that the soft skills are very important in this kind of an industry, well, in all industries, to be fair, and very much appreciated what you had to say there. So
Thank you so much. Yeah, thanks everyone. Hope you have a great day.
Thank you.
Thanks a lot. Bye now.
Bye.
So Alex, we have a couple of minutes before the next session.
All right. So what you got on my mind?
What have I got on my mind? How about a little quiz? Game of the year. We've got a few games. I want you to see. I want to see how well you know your games. We've got a whole lot of years, and I want to know if you can name the game of the year. So, give me a year. We've got goes all the way back to 1983, which please don't say was before you were born, because this is the oldest award I could find, and it was after I was born. I know who the winner was for that one.
Nah, I'm a little bit younger than the list goes on. I am from 1989, but I don't know anything from that year. So let's go to something more modern. Let's go 2014.
2014. And look at this, we've got lots of different choices. You can go for BAFTAs if you're feeling a bit classy and British. Edge magazine, that's Game Developers Choice, DICE, South by Southwest, Golden Joystick. We can mix things up with the whole Game of the Year thing.
I mean, I am too dumb and too the redneck for the BAFTA awards. I'm a simple guy.
I would say
So let's go with I don't know, Game Developers Choice Awards.
okay. There we go. 2014. Who won Game of the Year for the Game Developers Choice? Middle-earth Shadow of Mordor, Destiny, Alien Isolation, or Bayonetta 2? I don't even know what Bayonetta 2 is. That's me showing.
Oh
my-
wow. Well, I mean, you don't need to play that personally. You can just go through the play it on the YouTube and see all the beautiful cutscenes from the game. I mean, the Bayonetta series is notorious for its very colorful animations. I would say that.
Okay, there we go.
It is surprising to
Was
see
it
this
Game
kind
of
of
the
games
Year?
on internet platforms. So, I personally would vote for the Middle Earth, but I think in this year it was the Bayonetta 2.
Is that your final answer?
Yeah, let's do that.
There we go. No, T. you
I
should have
was
gone
so
with-
close. Yeah, I should have gone with my heart.
Yeah. You should have stuck with it. We can do it. How about we get our next speakers on and get them to do it? Have a go.
That sounds fun.
That's a nice idea. We've got our last speakers for the day. We have Gabriel and Henry, I think. Sorry, yeah. And I'm just wondering, are you there? Yes, you are, guys. Would you two like to pick a year? Don't pick 2014. We've got this. We're gonna test your skills now. Game of the year. You can go all the way back to 1983 and 8-bit classic.
I don't know, Gabe. What year do you want to do? I feel like you've got.
Let's do
better knowledge
91.
on this.
That's my birth year.
1991. Okay. 16-bit game of the year or overall game of the year?
Overall, I think overall.
Okay. Overall, Carrier Command, F-19 Stealth Fighter, Sonic the Hedgehog, or Sensible Soccer. You see, now these mean something to me. I'm not sure if they mean anything to you now.
I feel like it was. I mean, Sonic the Hedgehog or Carrier Command would probably be my guess.
I mean,
I wanna
Sensible
say Sonic.
Soccer sounds the most sensible.
We're all going to ignore that, Alex.
Gabe, make the pick.
All right, I'm gonna say Sonic.
Yeah, I
just
think
because at the time it was, groundbreaking in its graphics and gameplay.
No, but is it the right year? That's the big question. You
That
sure?
is-
Final answer?
It's early, but I like Sonic. Let's go with Sonic.
Sonic. Oh,
Yeah.
there we go. Wonderful. You got it. Right. And on such a winning note, I think really we should let you crack on with your presentations then, actually.
Yeah, for sure.
So,
Gabe, do you want to get your slides in? There we go. Sweet.
Yep. All
There we
visible.
go.
And we'll leave you to it then, guys. Thank you.
All right. Well, first and foremost, thank you so much, everybody, for being here. My name is Gabriel Batista. I am a game solution architect at AWS. I work with small startup studios in the AWS cloud looking to set up their first studios. And I am one of the co-founders of the Cloud Game Development Toolkit. And with me today, I have my friend Henry.
Hi there, folks. My name's Henry Kiem. I'm also a solutions architect at AWS. I work with game studios. I worked on Amazon Luna for a while before this. I don't know if anybody's familiar with that. It's our cloud game streaming platform. And then I wanted to work more closely with studios, so I shifted over to this side of the house. And it's been a really awesome change of pace. I love working with Gabe, and we've had a lot of fun building out this project and just kind of meeting people in the industry and trying to find ways to be helpful. So we're really grateful to JetBrains for letting us be here and talk about this cool project. And we hope you find some of it interesting or compelling.
All right. So let's go ahead and jump right into it. So today I want to talk about a few different things. Like everything else in AWS, we are going to start from the state of our customers, what we're hearing from the industry, and how we worked backwards from that to create the toolkit. We'll talk a little bit about the toolkit's structure, how we thought about it, why we structured it the way that we did. We'll then deep dive a little bit into the modules that we have available in the toolkit. we'll have a demo for you today that we'll show off, and then we'll bring it back to the slides to talk a little bit about the roadmap and what's next for the toolkit. All right, so the state of game development today. So Henry and I work with startup studios. We talk with a myriad of different studios every single day. And after working in this space for a while, we started to see some of the common threads from what we're hearing from the studios, right? Some of the big ones being that developers want to build fun, innovative games. They don't really want to handle backend infrastructure, right? Like that's not why you get into the business. You get into the business to make fun games, and that's what they're interested in doing. A lot of our customers were also finding it difficult to manage version control systems. Games are a unique beast in this space because they're such large projects. A lot of studios are globally distributed, so you have this additional complexity of having to take the game that you're building and then be able to send it all around the world for all of the partner studios that you may be working with. And a lot of our customers were having difficulties with that. We also saw a lot of studios who were very interested in making the move up to the cloud, in modernizing their workloads, but they were finding it very complex to make that transition from on-prem up to the cloud, and understanding the kind of the shift of approach that you have when you're working in the cloud. It's more than just different tools. It's a different way to think about the workloads that you're running. And then finally, when you do make it up to the cloud, there are a ton of different services. There are a ton of different ways to set up these different workloads. And a lot of customers were getting kind of lost in the sauce with all of the different services that are available in AWS. And they weren't sure what the right approach would be, what services to use for the different workloads that they wanted to host. Now, all of this is compounded, like I just mentioned, by the fact that games are getting bigger and bigger every year, right? You look back to 1985, Super Mario Brothers, that thing was 40 kilobytes, which is totally crazy to think about, because when you look at a more recent game like Call of Duty 2023, 240 gigs. If any of you have played these games, you know the feeling of loading up Call of Duty and having a big DLC to download. I know at times I was downloading like 60 to 100 gigs for an update, right? And this is the final game. This is the optimized game. So when you're working on actual development, these sizes can be even bigger than that. And then again, bringing it back to the idea that you have these huge games, they're very complex, and you're not just working in a single location. You have multiple studios spread all around the world, and you need to be able to share the games with them, not only for development, but also for play testing. And you want to do so in a performant way and in a cost-effective way. And then, of course, looking at some surveys, the number one thing that customers complain about in terms of the challenges of adopting cloud technologies, adopting just new technologies in general, is having to learn new tools, right? If you're used to, let's say, Terraform for infrastructure as code, and then you're forced to learn some other language, that is additional time that you're tacking on to the development of your game. And it's more time that it takes for you to get to the meat and potatoes of it, which is actually building out your game. So from this, we took 3 project tenets. The first one is that we wanted to meet developers where they are today. As a matter of fact, when we started the project, we wrote multiple modules in the Cloud Development Toolkit, which is AWS's infrastructure as code offering. But after doing so, we kind of looked back, we spoke to some of our customers, and we found that nobody was really using that framework. A lot of our studios were actually using Terraform. And because of that, we actually scrapped the toolkit where it was, and we started from scratch to build everything out in Terraform, specifically because we didn't want to force anybody to have to learn a new tool. We want to make sure that you're already comfortable in the environment that you're working in. In addition to that, we found that it was very difficult for somebody to deploy a workload just to be able to test it out. I don't know about all of you. For me, the best way to learn is just kind of banging my head up against the wall. I like to spin up some of these workloads. I like to poke at the configurations, change things around, break it and fix it. And I find it difficult to have to learn one of these complex tools just to be able to deploy kind of a baseline version of it. And because of that, we wanted to make sure that we were codifying best practices and defaults into the toolkit so that anybody can come in, deploy one of the modules, play around with it, shut it back down without having to understand every single detail of any of these tools. With that said, we also wanted our users to retain full control. So while we do have best practices, they're defaulted in the toolkit, we try to make it as easy as possible for you to be able to deploy any of these tools. You can go in and change any of those defaults. The entire project is open source, so we try to make it as flexible as possible for somebody to come in and adjust the project to fit their particular studio and their particular needs. So from all of this came the Cloud Game Development Toolkit. So the toolkit is a collection of infrastructure as code templates, Terraform in this case, that capture common cloud game development workloads. Things like your version control systems, Perforce, CI/CD pipelines, think TeamCity or Jenkins or Horde, and then some additional workloads like caching, for example, and license servers, which we'll get into in just a second. The project is split up into 3 different parts. So what we hear a lot from our customers is that they don't want building blocks. They want solutions. They want something that they can take and they can deploy and it just works and they can run with it. But at the same time, we as solutions architects, we do want the building blocks because it makes it easier for us to be able to build the final solution, to be able to build the thing that our customers actually want to see. So because of that, we decided to split the toolkit into 3 parts. We have our modules. These are the individual applications, Perforce, TeamCity, Horde. They're all encapsulated in a module with all of the best practices in them, and they are deployable on their own. To speak to our customers' needs, we also made samples available. So samples take the modules, stitch them together into a bigger workload that you can then deploy and have something like a entire build pipeline, for example, in a single deployment, rather than having to stitch the modules yourself. Now, with both of those done, we looked back and we realized that there are a lot of customers who aren't in the stage where they are deploying their studios. They already have their studios up in the cloud, and they just need to, maintain what they already have. So because of that, we took the assets that we use for the modules, things like machine images, Docker containers, Ansible runbooks, and we made them available in the project so that if you already have something deployed and you just want the assets to be able to manage it, maybe some build agent images, things of the sort, those are also available. So we try to help studios regardless of where they stand, and regardless of their maturity level. Okay, so taking kind of a step deeper into the actual project structure, today we can break the toolkit into 4 general pieces. We have CI/CD, where we have a TeamCity module, a Unreal Engine Horde module, and a Jenkins module. So depending on what your preference is, you have options. For version control, we deployed Perforce. Perforce here actually encompasses a few different workloads. So Perforce, the version control system is called P4 Server, but then there are also additional workloads like Perforce Authentication, which helps you to use IDP authentication with Perforce, and Perforce Code Review, which is exactly what the name implies, code review system. And all of this is kind of baked into a single module. For caching, we started the project really focused on Unreal Engine. So we have Unreal Cloud DDC as an option for deployment. This helps to cache your assets across your studios, regardless of where you are in the world. And we've recently started making moves into Unity. So we also have a Unity Accelerator module that we released recently, along with a Unity license server module to go with it. Taking a quick look at the module structure, we try to keep this as standardized as we can. When you're looking at the module, there are a few different directories. First, at the root, we have the actual Terraform files. We try to keep the bulk of the modules in the main.tf file as much as possible. And then we have some of the additional workloads broken off into their own files. Things like load balancers or Route 53 definitions. That is our DNS server. Things of that sort. We try to break it out to make it easier to read. Along with that, we also have examples for each of our modules. So don't confuse the examples with the samples. The examples deploy just that particular module. We typically use it for things like testing, but if you want to deploy just a single module to play around with it, this is a good place to look. And then for the more complex modules, we may have a sub-modules folder. Perforce, again, being a great example here, while the Perforce module is a single thing that you can deploy. Within the configurations, you can define whether you want to deploy P4 server, P4 code review, and or P4 auth. And that these are all captured in the modules folder. All right. Looking at the assets, like I mentioned, we try to make as much of what we built in the toolkit available for people to use. So this is just an example, probably one of the more complex images. This is a build agent image for Linux, and you can see that we try to make all of the scripts available for installing additional tools, things like Octabuild or SC Cache, mounting volumes. All of that is available for you to use, change, and then hopefully feed back into the toolkit as a PR as you make changes to it. And then finally, the samples. So the samples use the modules. We try to keep the variables to a minimum on the sample level. We want these to be as easy to deploy as possible. A lot of the hard-coded values exist in the locals.tf file. So this is an easy way for us to just put in some hard-coded values for the deployments. You can go in there and change it. But if you just want something that you can play with, you just want something to stand up and be able to touch, then the variables are at a minimum. I believe we only really ask for like the domain name where you want to deploy these tools, and that's it. You get your entire build pipeline or Unity build pipeline, depending on which network you're deploying. All right, taking a deeper look into each of the individual modules here. So just going to zoom in a little bit. So this is the Perforce module. I know there's a lot going on in these architectures, but the important piece to understand here is that with a single deployment of Terraform, we can deploy multiple pieces, multiple workloads at the same time. So here we have our Helix Core commit server, which is our P4 server. It's backed by 3 separate EBS volumes. So this makes it easy for you to be able to grow or shrink any of this data, to be able to snapshot any of these volumes, so that it's easier for you to be able to back up your Perforce server. This is hosted on EC2. We found that Perforce requires additional cores. There's a lot that goes on with Perforce that didn't allow it to work very well in containers. So because of that, we went with EC2 for the P4 server, but we did containerize the Helix authentication server, or P4 auth, and the Helix Swarm service, which is now called P4 code review. Looking at these, the authentication service is pretty straightforward. There's not a ton of additional services that are deployed alongside of it. But for the code review, we do have some additional pieces. We have a Elastic file system attached to the container, along with an Elasticache serverless deployment. So this is essentially Redis, but it's completely managed by AWS. And it just makes our lives a lot easier. It's one less thing to have to worry about. It will grow and shrink automatically, scale in and out, and it will take care of any kind of failover that's necessary. The service is very much hands-off, which is nice for us. And then, of course, all of the...
I was just going to interject real quick, Gabe. Like, looking at this massive architecture, I think this actually, in spite of being kind of overwhelming, really gets to the point of the toolkit, which is deploying these tools in a production configuration is really complicated, right? It would be wrong to say that it's like an easy thing for just anybody to go and figure out. It's not something that you can't figure out, but there's a lot to figure out. And so what we're trying to do here is standardize the approach that you can take to do that and accelerate that process. So even though there's a lot, when it actually comes down to using the Cloud Game Development Toolkit to deploy these things, it's a few commands rather than loads of manual work to stand all this stuff up.
Exactly.
I really like this architecture in spite of how like chaotic it is.
Yeah, it's a lot to look at, right? But I mean, if you've ever deployed Perforce, I think that you understand how many moving pieces there are, and being able to deploy these where each of the individual applications already speaks to each other, all of the security groups are in place, like that's all done for you with the toolkit. And I think that's where a lot of the value comes from. So just pulling out like 2 points of interest here from the Perforce architecture. The first one is the Elasticache serverless deployment. Like I said, it's an in-memory database. It's essentially Redis. It makes it really easy for you to be able to just attach this database to the workload and not have to worry about it, not have to worry about maintaining it, how much storage is left. AWS takes care of all of that. And then when you're dealing with something like Perforce, there are a ton of secrets that you need to manage. The usernames and passwords and keys that go along to make all of these services work. And of course, we don't want to have those hard-coded in Terraform. We want to make sure that they're not showing up in the logs. So we leverage AWS Secrets Manager to be able to store all of these secrets. Terraform has some great integration with the service already, which made it really easy for us to be able to push and pull these secrets when we needed them. All right, moving on to TeamCity. TeamCity is a significantly simpler architecture. So again, taking a look at this, the service is hosted on ECS, Elastic Container Service. It's fronted by an application load balancer, and then it has 2 additional services mounted onto it. One is an Elastic File System to be able to store all of the configurations, and then an Amazon Aurora database. So much like the caching database that we were just looking at in Perforce, this is also a completely managed offering. The cool thing about Aurora actually is that it decouples the compute from the storage. So you can scale your compute and scale your storage completely independent of each other. And again, this just makes everybody's lives easier. It's one less thing to worry about. It's completely managed by AWS. We'll take care of scaling it. We'll take care of resilience, and you just worry about actually using the service. And then here towards the bottom, we have our build agents. There are a few different ways that you can handle this. If you want a full build machine, you can use an EC2 instance as your build agents. In the demo that we're going to show you today, we actually decided to go with containers, and in this case, serverless containers, to be able to deploy these build agents in an ephemeral way. They spin up, they do the work that needs to be done, and then when they're done, they just disappear, and you don't have to worry about managing any of that additional infrastructure. And then, of course, for a setup like this, we need somewhere to store our artifacts. So we are using an S3 bucket to store that, the final build of the game, where we can then either distribute it or deploy it in some other service, whatever it is that we want to do with it. Okay, and again, just kind of zooming into some of the services that we use. The Amazon Elastic File System has actually been a fantastic service for us because it makes it really easy to be able to store all of these different configurations from the different applications that we may be deploying. Makes it a lot easier for us to be able to back up all of that data when we need to. And then, of course, we have full control over who can see the data, read it, write it. Permissions are made very easy with this because it's all fronted by IAM policies, right? So essentially AWS policies that dictate who can and cannot mess with the information. And then on the other side, we have Amazon Aurora Serverless, which again, I know I touched on it, but Aurora comes in a few different flavors. We have just a regular Amazon Aurora, which is a database that you deploy in a subnet. You take care of it, you manage it. But then we also offer a serverless version of this, which is what we went with, because again, we wanted to keep the overhead as small as possible for any of these deployments to make it easier for people to be able to play around with the service when they need. But again, at the end of the day, it's up to you. If you want to go in there and replace this with any other database, it's relatively easy to do as long as you understand a little bit of Terraform. Excuse me. All right. So then looking at the assets, like I mentioned, there are two big players that we use for the assets. The first one is Packer. There are a lot of Amazon machine images or AMIs that we need to create for this kind of workload. So we leverage Packer to do this. It made it easy for us to be able to codify all of the different installations that we need to do, the different configurations for the machine images, and it allowed us to be able to hand that template over to users so that they could build their own AMIs and have it automatically uploaded to your AMI storage in the cloud that's private to your account. Along with that, we also used Ansible runbook specifically to be able to do a lot of the configurations. Perforce is a key target for this. Perforce has a lot of minute details that you need to handle when you're spinning up a server versus a replica, being able to copy information between the servers. So rather than having to memorize all of those steps, we just created a few runbooks that we could then share with our users to be able to run these workflows at the click of a button. And then finally, the first approach that we had for the toolkit, we started things off with Jenkins because Jenkins tends to be a more manual deployment. It's open source. You have to really understand how it all works. So because of that, we ended up creating a bunch of Jenkins file definitions that, again, we made available both for Unreal Engine, Godot. I'm not sure if we have a Unity one, but there are a ton of different ones with different configurations, and it's up to you to pick and choose. If you do have a Jenkins deployment, you can go in there and use those. So with all that said, I'm going to pass it over to Henry to talk a little bit about the demo that we have available today.
Thanks, Gabe. Yeah, so we'll start with this slide, which has the Unity build pipeline sample architecture on it. And this kind of just gets to the way we view standing up some of this if you're a net new studio, right? So a lot of the game studios that Gabe and I speak with, many of them start with 3, 5 developers, but this also works up to scales of 40 to 50. And we have many of the same conversations with sort of enterprise game studios, really big game studios that we have with the startups. And a lot of it revolves around, how do I stand something like this up, whether it's for 5 people or for 100 people? So there are kind of 3 things that we're going to represent in today's demo that Gabe's got on this slide here, right? The first one on the left side is our P4 server, right? This version control piece. And we mentioned that the P4 server, I don't know if a lot of you are familiar with Perforce, but Perforce is pretty ubiquitous for version control in game development. Now, GitHub, when you spin up a GitHub repo, it's pretty easy to just sign into GitHub, create a new repository, and upload all of your artifacts there. But as the game gets bigger, you start to need something that's a little bit more dedicated. And a lot of customers of AWS, a lot of game studios will use Perforce as that version control tool. So spinning Perforce up is a little bit more involved because it's a more powerful application. And it requires significantly more infrastructure. It requires a pretty large machine to actually run the Perforce application, the P4 server, and it requires storage that Gabe touched on, which here we've represented as 3 different EBS volumes or elastic block store volumes, right? So this is our compute and our storage. We're going to walk you through how we deploy that with the toolkit. We're going to show you that running, and we'll show you some of the infrastructure as well. And then we'll show you the code that actually deploys that stuff. In the middle, you've got this Unity license server, right? The Unity license server also is an application produced by Unity, right? So this is not an AWS tool. This is a third-party application in the Unity license server. But again, it requires infrastructure to run at production scale. And we had enough customers asking us, hey, how do I do that? That we went and built a module for it. So that's the idea of how the toolkit kind of grows. And then on the right, which I'm actually going to talk probably the most about, is the TeamCity server deployment, right? So TeamCity actually has a great product called TeamCity Cloud, which I'm hoping a lot of folks are familiar with. TeamCity Cloud is a SaaS-based model. So JetBrains actually manages the TeamCity infrastructure on your behalf. You can go, you can sign up and get stood up in minutes. The tricky thing is that in games, because the build machines themselves frequently need to be much larger, a lot of customers look to self-host their build infrastructure at the agent level. And so naturally, they might be more compelled to use something like TeamCity on premises, which is a self-managed version of the TeamCity server. So that's what we've built the module for. And it's based extensively and exclusively off of the TeamCity documentation. So I'm going to show you the TeamCity documentation that's relevant, and then I'm going to show you the source code that implements it. That's my objective, right? And this whole thing together forms a pretty clear pipeline. On the left side, we have our version control, which holds our Unity sample game. And then on the right side, we have our build infrastructure, which is TeamCity in this case, which outputs a built artifact to S3, which is the Amazon Simple Storage Service. Also pretty common in the industry. So without further ado, if we could hop over to the demo side of the house. Thank you. So what you'll see here is a maybe familiar site if you've used TeamCity before. TeamCity is a CI/CD application that's provided by JetBrains. It's really widely used in software development. It's also very widely used in games. And what we've got here is a little bit of a sample environment to show you. So I'm actually going to start over here on the left at the homepage. We've got a Unity sample game that we've defined here, right? And in that Unity sample game, we have one Linux build pipeline, right? We're building our sample game for the Linux platform. And where I'll start with is actually the assets for this sample game. So they need to live somewhere, like we mentioned, and they live in Perforce. Up here, you can see that I'm in P4 code review, and I can take a look and browse all of the assets that are in my Unity sample game, right? Assets, packages, here's the actual solution. You know, I can hop into assets. I can look at sample scene assets. Let's say, I don't know, let's look some fog, right? So here's a nice foggy scene PNG, right? A sample of what this scene looks like. And all of this is stored on AWS in the cloud in our Perforce server. And then this website, review.perforce. In our case, peculiar.games.aws.dev, this P4 code review application is also hosted on AWS. So before I proceed any further with the TeamCity piece, I'm going to show you what that looks like in AWS. So I'm going to hop over to the EC2 console, right? Gabe touched on this. This is where compute is deployed. And if I take a look at the EC2 console, you can see I have a bunch of instances running, right? These are my servers, and they're doing a number of different things. In the case of Perforce, these actually live in our Perforce account. And then what happens is, if I take a look, right, let me find a good example. Here we go. What we've deployed here is a whole slew of infrastructure just to make this one application work, right? So we need to handle load balancing, which is complicated and difficult to set up. We need to forward our load balanced requests to our server back to a containerized application. We don't want that containerized application to be exposed to the internet. So there's a number of pieces here, right? You can see we're taking in HTTPS requests, we're forwarding them to a private IP. There's loads of infrastructure here that we've deployed automatically using the Cloud Game Development Toolkit, right? So just to get this website up and running and to get the storage deployed for all of these assets that are part of this Unity game, we have written a number of modules, right? So I'm going to jump into some code real quick. So this should look a lot like what Gabe was talking through, right? This is the project at its root. I've cloned it down. You can see that assets directory that Gabe talked about. You can see that modules directory that Gabe talked about, and you can see the samples directory that Gabe talked about. So I'm going to open up modules. Under modules, you'll see a number of subdirectories, right? So Perforce and TeamCity and Unity. Those are the three we're going to be talking about today. The Perforce modules, actually the Perforce module, which is all of this code, is written in Terraform. That's what these .tf files are. And if you're not familiar with Terraform, it's a way to codify your infrastructure, right? So we are able to define with our single P4 server module a number of details about, you know, what type of instance we want to run it on, what the architecture of that instance should be, how much storage for the depots, how much storage for the metadata, how much storage for the logs, what VPC it should go in, right? all of this extensive configuration that we've done ahead of time so that you don't have to go through the details of setting all of this up, right? On the TeamCity front, it's similar, right? You'll see that we've defined things like, this is where I'm going to really focus. You have this task definition, right? This ECS task definition. Within that task definition, we're defining a container, and that container is running the TeamCity server, right? This is a publicly available TeamCity server container published to Docker Hub by JetBrains, right? And we're just using that application. We haven't rebuilt the service. We haven't changed anything, right? All we've done is say, hey, that application that people like is available and hostable on AWS, right? That's it. You'll see we've specified volumes that we want to attach it to. And then, like Gabe was highlighting, TeamCity requires a database and it requires a cache or a file system. Those are also pieces of this module. We've automatically deployed the storage, we've deployed a database, and we've deployed the application compute, right? And all of that is available. It's readable here. It's open source. You don't need to extract any of that out, right? There's no black box. It's all very readable. It's all here, highly digestible, right? So what this infrastructure as code provisions is based off of, it's what's running this application, right? So when we look at TeamCity, or we look at P4 code review, or we look at, the logs of this build that was successful, every single piece of that is running on infrastructure that's provisioned with the Cloud Game Development Toolkit. So briefly, I just want to jump into the TeamCity documentation. So this is the TeamCity on-premises documentation. Again, comes exclusively from TeamCity, and all we've done is followed TeamCity's instructions for running their application in production and codified that, right? So if I hop into setup TeamCity for production, you'll see that there's instructions on installing TeamCity server on Linux or Mac OS. And then there's instructions on configuring the TeamCity server with startup properties. There's instructions on installing TeamCity agents. And there's instructions on hosting build agents in the cloud, setting up an external database. And each of these documentation pages are the things that we've gone through to familiarize ourselves with the application. So for example, this talks about how you can use AWS Aurora, which is our proprietary SQL-based database service, as your backing database for TeamCity, right? And this documentation is great. It gives some really clear instructions on setting this thing up. That's what we've codified, right? So when I hop back into the AWS console, you'll see a database that has been provisioned that's dedicated for the TeamCity cluster. It's got 2 instances. All of this was codified, right? And then when the TeamCity server is running, it's using this database that we've provisioned. The next thing I want to highlight is the actual agents in this Linux build that are being used. So we have one agent that's provisioned here, this Unity Builder agent. And this Unity Builder agent is a container that is separated from the TeamCity server. So the TeamCity server is running containerized on ECS, which is Elastic Container Service. It's a managed container deployment service on AWS. And there's also an agent alongside it, right? So we've segmented out this control plane and then these agents. That's a big part of TeamCity. And we're deploying these agents on similar infrastructure to improve the latency between the TeamCity server and the agent, right? Those, if we take a look at our TeamCity cluster, right, this is our compute cluster, you'll see we have 2 services, right? We have the TeamCity service, and then we have this Unity build machine service. And because we have these 2 services, we can scale them independently. So if TeamCity is getting a lot of traffic, but isn't doing a lot of builds, we can scale the web service. If TeamCity needs significantly more build capacity, we can rapidly scale up the number of agents as part of this service, right? Each one of these has its own logs, its own attached storage, and I can view all of that from the AWS console as well. So you'll see the logs coming from the build agent, which Java executable it's using. It's starting up the TeamCity agent. It's downloading the TeamCity agent, right? You can see the agent spinning up in an infrastructure standpoint. And then at an application level, I can take a look at, the output of this particular build. I can look at the build log. I can see the version control route, which in our case is Perforce, being attached to the build agent. I can see it syncing down and setting Perforce environment variables, right? And then I can see it publishing internal artifacts. Finally, it gets to the Unity Linux build, right? It connects to that license server we were talking about. And as it goes through this build process, that hardware that's backed on AWS is spun up, does the build, and then can spin down, so you're not paying for anything excessive, right? Once the build completes, and there's a lot here, I won't go through all of it, right? But once the build completes, we now need somewhere to put it, right? We need a place to store that built game executable. And the natural solution for that is Amazon Simple Storage Service. So you'll see right here, we have step 2 of 2, which is actually uploading our artifact to S3. So what this allows us to do is say, hey, I want to do a build of my game. I don't have infrastructure available to do that build at scale. I check in my changes to Perforce, right? I make a change to the scene. That can trigger a build, which TeamCity manages. TeamCity can provision an agent on AWS, a containerized agent on AWS. That containerized agent can actually do the execution of the build. It can then upload that built artifact to S3. That's what you see here, right? This is the uploading build artifacts to S3 portion. And now that built artifact is on S3, I can distribute it to my playtesters. I can distribute it to whatever publishing platform I'm using, whether that's Steam or I'm provisioning it through a website, something like that. And I can make it available globally, right? And that really completes this sort of like end-to-end pipeline, right? I've gone from uploading subversion control all the way to a built artifact that I can distribute to my players, etc., right? So, last piece of this puzzle. Just to highlight a little bit, how you might get involved with this project, which we're going to talk about a little bit more. But while we've got the code up, I just want to show you, how extensive this project is. So we've got probably, 20 contributors across AWS who have participated in building this. Many of them are games essays, just like Gabe and myself. And if you are a small game studio and you're looking to get infrastructure stood up like this, it's really easy to get in touch with your AWS account team and ask about this particular project. And Gabe and I would be happy to come in and give you a deep dive walking through how you might stand this stuff up. We've got a pretty extensive contributing doc, right, on just the general structure of modules. If you've got some application that you want to make available or you want to leave feedback. We've got pretty clear guidance on our patterns around like when we use submodules inside of our modules, that kind of thing, like how we nest stuff, how we name variables, right? So what we're trying to do here is really raise the bar on this open source environment so that it's not so much everybody figuring it out on their own, like flying by the seat of their pants, right? We really want to make it as readable and easy to understand as possible. You'll also see we have this design standards doc, which is similar, right? This is sort of like a higher level strategy. And getting started with this project and contributing to it, not hard. We've had a number of external contributors raise PRs against this. We're not closed off to just AWS services. We recognize that, you want to use TeamCity or you want to use Jenkins or you want to use Perforce. So we're trying really hard to kind of open up that ecosystem and be as open source as possible, right? So to find the GitHub, which has a lot of the same documentation available, we'll have a QR code at the end of the slide, but I also know that a lot of people are on their computer, and so a QR code is not always the most useful, but it's just, if you just search Cloud Game Development Toolkit, it'll pop right up. You can see that we've got some good traction here. We have documentation available, and we're going to get a little bit into the roadmap next. So I think we can hop back over to that. But really just wanted to highlight, like, all of this infrastructure that's running on AWS is provisioned with code, right? There's no clicking around through the console to try and stand this stuff up. It's codified, it's best practices. We've done a lot of the security hardening ourselves. But it is an open source project, so it's constantly in development. So here you can see the output of our build, which is stored in Amazon S3. You can see we've got our x86 binary for Linux, our game data, our build manifest, right? So very constant pipeline. Some of this should be familiar to you if you've built a Unity game before, but if not, we're also happy to help with that. So without further ado, let's hop back over to the slides and talk through some of the roadmap that we have left.
All right.
What's next?
Okay, so let's talk a little bit about the roadmap. So as Henry already mentioned, the Toolkit is an open source project, so we're constantly getting feedback from our customers, from our users, and we try our best to integrate that into our roadmap. So all of this is subject to change depending on what we hear from our users. The number one thing that we're working on right now is a documentation overhaul. We tried our best to put in as much information as we could into the documentation. Now we're just going back and standardizing it, making it a little bit easier to read, so that we can get even more contributions back to the toolkit. We've also recently released the virtual desktop infrastructure module, or VDI module. There's a version 1, we'll call it, already up and available in the repository, but we're continuing to polish it, to make changes and make it easier for you to be able to deploy and use. Looking into future development, we are thinking of doing an Unreal Zen servers module and a Helix DAM module. That's digital asset management. These will help studios to be able to manage their infrastructure. While we already have Unreal Cloud Derived Data Cache, DDC, available in the toolkit, we know that DDC is typically used by larger studios distributed across the world, versus smaller studios where maybe you just want the caching to exist within your office, within a LAN. Then the Zen server is a better solution for that. So we're looking to continue to expand on our Unreal offerings. Looking at some of the samples that we also want to build for the future, we have 2 that we're targeting now. We are finishing up the multi-region cloud DDC sample. As of right now, we have a single region sample, but we want to make sure that the toolkit speaks to a multi-regional deployment. And the same thing for Perforce. We have a single region Perforce deployment, but we do want to create some examples that show what this may look like from set up or deployed in multiple regions. And then finally, we are at the very cusp of releasing a new workshop for the Cloud Game Development Toolkit. It just speaks about cloud game development as a whole. If you see any games-related AWS events going on, there's a good chance that we may be running this workshop. We actually have one coming up in Austin on the 29th, if I remember correctly. But yeah, this workshop you'll definitely see more often if you follow any of the AWS events.
Yep. And I know, just to highlight, like, you know, some of these terms might be unfamiliar to you, you know, Zen servers, Perforce, even Cloud DDC, Helix DAM, and that's completely understandable. You know, early stage game development, you might not need any of these things. But as you start to scale and you start to, you know, want to accelerate the rate at which you're developing these games, or introduce new, very useful tools for a lot of this stuff, come talk to us. Like, we're happy to help stand this stuff up. It doesn't have to be expensive. These can be really useful utilities that you know, improve your development experience. And I'm sure that your AWS account teams, the folks that are aligned to you, would be happy to talk about this too. We frequently can, you know, help provide POC support if you just want to, like, try something out and see if it's useful. That's really common, and that's a lot of what Gabe and I do. So yeah, just reach out to your AWS account team if you know who they are, and if not, you can always open a support case on AWS and find them. It's relatively easy to get in touch. So they've probably reached out to you.
Yeah, Henry is right. There is a ton of different, keywords, terminology being thrown around. The toolkit is exactly that. It is a toolkit, a collection of different tools. But the beauty of it is that we made it so that it's easy for you to deploy for the first time. So if any of this sounds interesting to you, don't be afraid to go into the module, look for those examples, deploy it, play with it, and then shut it back down when you're done.
Also, if you're just curious about AWS in general, and you've heard it because it's a massive cloud ecosystem and a platform that a lot of folks rely on and leverage every day. And you're just curious about where to get started, this is a really good place to get started in the games industry because these tools are relevant. So just hopefully we've encouraged some folks to, consider trying this stuff out and not be as intimidated by deploying some of them as you might have been before. Because Gabe and I didn't know anything about this before we started working on these projects. Like, we really had not had a lot of experience trying to do this ourselves. And it was only in trying to do this ourselves that we realized how hard it is.
It's easy to talk about it in theory. You deploy this, you do that. But then when you actually go, you actually deploy it and you have to configure it and you have to debug it. I think that's when you really feel the pain. And again, we always try to kind of put ourselves in our customer's shoes and then work backwards from there. How can we improve it? So with all of that said, again, this is an open source project. Help us build it out. Feel free to file bugs or request features in the GitHub issues tracker. If you make any changes, if you customize the toolkit in any way and you're willing to send that back to the toolkit so that we can continue to add additional features, please feel free to open up pull requests against the toolkit. We're constantly looking through the pull requests that are made so that we can continue to extend the toolkit. And then finally, and I would say most importantly, we would love for the repository to not just be a place for you to download the toolkit, but for it to also be a place where you can discuss the details of how to deploy these tools, ask questions. There's an entire discussions tab that we have available in the repository. So feel free to go in there, engage with the community, ask questions. We're here to help as best as we can. And here is a QR code, like Henry mentioned earlier, to the toolkit. You also, to the toolkit's documentation, excuse me. You also have a link at the bottom there. And that is our presentation. Thank you so much, everyone, for taking the time today. And yeah, if you have any questions, now's the time.
Yeah, hi, folks. Thank you very much. That was a fantastic overview of something that is really complicated. I think it's a really good point that you're making, that this stuff can be really hard, especially joining all the different pieces together for the different the different pieces. It can be bad enough setting up one thing, let alone setting up 4 of them to work together. So yeah, thank you for that. I do have to ask though, because I don't know Terraform terribly well. How does the toolkit work as a toolkit? Is it a collection of samples, like I take those Terraform files and tweak them for how I want them, or is it going to be used kind of like a library and a modules or something like that? I'm not familiar with it.
That's a really good question. So our intention at the forefront was to try and not build another kind of application, right? Not something that you go in and you can click a button and it does everything for you, because we realized that a lot of these deployments needed to be flexible enough where somebody who does want to kind of get in the weeds can go in there and tweak a line here or a line there and get something more custom. That being said, deployment is as straightforward as opening up the repo, finding one of our samples, which we feel cover like the overwhelming majority of use cases, right? So like the one today, which is a Perforce server, a Team City server with some containerized agents, and an S3 bucket to deploy your builds into. We have a sample that Gabe's actually going to merge probably this week that we built explicitly for this game dev day, that you will go in there and you might be required to like put in a domain name, like where do you want these things to be deployed? Like Gabe said, like we don't know what your studio is called. So you would put that in text in the file, right? Or the variables would prompt you, and you would run Terraform apply. Terraform is a CLI, and Terraform apply would look at all the files that you have in that directory, and it would begin applying them. You need to set up your AWS credentials, but Terraform also helps make that very easy. And our documentation walks through a good chunk of this, but that's kind of the flow, right? The files are there so that when you want to make a change to something, or you want to be able to view, what you have deployed, Terraform maintains state relevant to the actual source code. But the process of deploying this is as simple as like running a couple commands on the terminal. That's it.
Mhm.
So I don't know if that answers your question, but
Yeah, mostly, yeah. But I was just going to ask, then you say, we take one of the samples that you've built there. Is the sample, because you saw kind of like the main toolkit was a bunch of Terraform files, and then the samples were also a bunch of Terraform files. Are they kind of, are they like a snapshot of the toolkit, or are they like referencing the main thing?
They're referencing the modules. So they're in the toolkit.
Okay.
It's sort of like they are. We have a module for Perforce. We have a module for TeamCity, right? But you frequently want to deploy both of those things and have them be able to talk to each other and have the networking be set up so that they are allowed to talk to each other. And so a sample shows you how to put both of those things into, a virtual private cloud and set up networking and set up DNS and set up security. So the modules are these sort of building blocks that Gabe was referring to. The samples are us taking those building blocks and, building a little house. That's the easiest way to describe it.
Got it. That's perfect. That's it. That everything's clicked into place for me there. So that's great.
Yeah.
Thank you.
Just my 2 cents that if you are working extensively with the Terraform files, there is also a plugin for the IDEs of JetBrains, including the writer that you work with the Terraform, not only like other text editors that I would not want to speak out loud.
Yeah. No, that's a very good point. And I actually did want to speak to Rider really quickly if we could. I know this is a JetBrains GameDev day, and I was showing off Kira, which is Amazon's newest IDE, and it's what I use for a lot of stuff. But Rider, which is really widely used in games more and more, so that virtual desktop interface module that Gabe was mentioning, that's our attempt to make it really easy to spin up a virtual workstation on AWS, right? So you might not have a really high-powered machine at home that you can do game development on, and you would like to be able to do game development, but you don't want to go buy a whole nother PC or something, right? Or you have a MacBook like me, and you need some, beefy Windows machine to actually be able to do a lot of the game development work. So our VDI module helps spin up a GPU-enabled instance. It helps manage user provisioning. It helps set up Nice DCV, which is our remote desktop protocol at Amazon. But it also can install a lot of common game development tooling. So, for example, we would love to automate the deployment of Rider onto those instances, right? So if you have a studio and you need to spin up a bunch of workstations for that studio, you can spin up them through our module, and they'll have Rider pre-installed. You can point them to your license server, all that kind of good stuff. They can have the TeamCity agent pre-installed. Now, we aren't doing that just for Rider, right? This is an open source project, but I think there's a lot of promise in Rider, and I use Rider extensively when I work in the engine. So that's sort of why we started that way. Yeah, exactly. That's some stuff that's upcoming. So Gabe alluded to our VDI module that we're working on. That's one of the pieces of it is automated Rider installation.
Yeah, that sounds great, and obviously we'll do whatever we can to help, because we'd love to see it available in those kinds of environments as well.
We have done some really cool collaboration with JetBrains as well. Gabe and I forgot to mention that, but for example, TeamCity introduced a Kubernetes executor for its agents, which is just a really interesting pattern, and we came across it naturally. And there was a change that we needed to have TeamCity make so that it would support a different authentication model that we felt was a better AWS best practice. And so we opened up a support case, and our team and some engineers from TeamCity were going back and forth about the right way to do this. And I think that level of collaboration is like the best part about working on this toolkit has been being able to talk to partners and actually get really good feedback and just kind of be collaborative, trying to make this easier for people. So that was a huge prop that I forgot to mention, but I'm glad we got to it here.
Yeah, no, that's always nice. I'm always happy to hear kind of things like that. It is something that we do want to do, is work well with other players in the industry, because obviously it makes everybody's lives better. You know, if we can work well with you as a cloud platform or whatever services you provide, then, you know, it's a good thing. Everybody wins. What's not to like? I did have another question, which was going to be why you selected Terraform as well. So again, not being sort of familiar with this, is that the industry standard, the best kind of thing for this particular role, or, you know, what were the reasons behind picking it?
Yeah, so Terraform is, at least as far as we can see, the industry standard. All of the customers that we spoke to were using Terraform. Like I spoke to about earlier, we did start the toolkit using the cloud development kit, which is AWS's proprietary version of an infrastructure as code framework. But we found that a lot of customers didn't have any experience with it. They didn't really know how to use it. So rather than try to force this onto our developers and force them to learn an entirely new tool, we found that it would be better for us to just meet them where they are, use the tools that they are already using, which is why we ultimately made the shift, not just to Terraform, but also to Packer and to Ansible and all of the different tools that we have, so that you have the right tool for the right job.
Cool. That sounds like a nice way to be, I guess. Move to where the people are and provide the right tools that they're already using. This is good.
Yeah. Developers' jobs are hard as it is. You know, why make it harder?
Yeah.
If possible, I don't know if we can pull up my screen real quick again, but I did want to just show, you asked a question about, you know, what is the experience of actually doing this, right? It's a bunch of source code, and I didn't show this during the demo. I was showing more end result, but this is about as simple as it is to actually deploy something with the toolkit, right? So I'm in the simple build pipeline, which this one is Perforce and Jenkins, but we also have one that is Perforce and TeamCity and sets up the Unity license server, all the stuff we talked about today. But the extent, if you aren't familiar with Terraform, is running something like this: Terraform apply, right? Or Terraform plan. And in my case would be kind of like, hey, I want to see what Terraform's actually going to do. And you'll see what it prompts me for is a fully qualified domain name. So mine is something like this, right? Just a domain name. I hit enter, and then Terraform looks through all of those files that we just mentioned, and it comes up with a plan of what it's actually going to deploy to AWS, right? And I can take a look at all of those things that it's going to provision. So here are some of those secrets that Gabe was talking about. Here are those EBS volumes that we were talking about, right? The storage for my Perforce server. And then that's it, right? To actually deploy this thing, I would run Terraform apply, put in my domain name, hit enter. It will give me that same plan, right? It'll say, this is what we're going to do. And then all I have to do is say yes. And it will start doing the deployment, right? It's creating resources. And this can vary depending on what you're deploying. This one takes probably 10 to 15 minutes. And we'll spin up all of that stuff that we talked about. So you can see that it's going through the actual deployment now. It's creating resources. So I think that maybe provides some clarity on what the actual usage of the toolkit feels like.
Yeah, absolutely.
Anyway.
Yeah, it looks great. Yeah. Exactly. Let's not leave it running for 10 minutes. Yeah, no, that looks great, and I think it is a very useful way to be able to sort of create this architecture, especially in a way which somebody else has kind of verified for you as well. So it's helping you understand how this architecture should look and how it should fit together, which is a very good thing. I don't think I have any more questions. Alex, do you have anything else?
No, I believe not.
Okay, well then I think we might be done. Gabriel, Henry, that was a fantastic look at the development kit there. I hope you get lots of people now joining in and providing pull requests.
Yeah, that'd be great.
Yeah. Thank you very much for your time, and we'll see you again soon. Thank you.
Thank you so
Thank
much.
you.
Yeah.
Bye-bye.
Thank you, folks. Bye-bye.
Bye-bye. And that brings us to the end. That's it.
Yep. Matt, that was a long day, but I feel it was fruitful. It was really packed with a lot of information, with a lot of really great talks. There's a lot of times I really felt fascinated, and I was listening really hard. Sometimes they were all over my head, like the technicals that I was struggling to follow along, but still, I feel like I'm a new person after this conference.
Well, as long as you're a new, better person, that's the good thing.
We'll see.
We'll stick with new person. New person is fine and everything. Yeah, it has been a lot of great talk. So I'd just like to thank all of the speakers that have been involved. It's been a busy day, a packed day. Appreciate everybody putting all the effort into it, and appreciate everybody in the chat and who's been watching along on the stream as well. Thank you for sticking with us to the end. Because I'm sure you've been here since the very beginning, right? Yeah. Just like us, everyone else has been here for the whole time. I think so.
Sure.
I think so. And of course, I'd like to thank all of the staff behind the scenes who've also put in a huge amount of effort to make this work. As ever, this is recorded. The stream's going to be still available. You can rewind it. You can jump back and look at different talks. We'll be cutting them up, uploading them, posting them over the next few days as well. If you've registered, you'll see the links. Otherwise, you'll see them on the channel. So JetBrains.tv, the YouTube channel, like and subscribe, as they say, and plenty more content, lots of interesting stuff going on there. And at which point then I think it's time to say thank you all for joining, and goodbye. See you later.
Yeah, folks. Goodbye, and have a good rest of the week.
Yes.
See ya.
Bye-bye, everyone.
Bye-bye.